Hello everyone, welcome to this interesting video on AWS full course of 2022. In this video, we will explore various important aspects revolving around AWS and its related concepts in depth. But before diving deep into its concepts, we will first cover the basics and have an introduction to what is AWS, followed by exploring cloud computing services. Then, we will explore some of the very important services provided by AWS under various categories like compute, storage, database, and networking. Following that, we will explore and understand the complete mechanism and architecture of some of its very important features related to containers, storage, and security, that are AWS EC2, AWS S3, AWS IAM, AWS CloudFormation, AWS Route 53, AWS ECS, AWS Beanstalk, AWS VPC, AWS SageMaker, AWS CloudFront, AWS Autoscaling, and AWS Redshift. After which we will have a look at the comparison between AWS and other cloud platforms like Azure and GCP, to understand their individual identities and how they differ from each other based on various parameters. And we'll also see how Kubernetes are implemented on AWS. And after that, we will focus on how we can adopt AWS in our career and pave a path towards becoming AWS Cloud Practitioner or AWS Solution Architect. After that, we will discuss the top 10 reasons why AWS is a better option to go with. We will then conclude this video by discussing the essential interview questions and answer to help every individual clear an interview with full confidence. By the end of this video, I can assure you that all your AWS career-related queries would have been answered. For this training with me, I have our experienced AWS specialist, Sam and Rahul. Together, we'll walk you through the different crucial AWS keynotes. So let's start with an exciting video on AWS full course of 2022. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon and never miss an update from Simplilearn.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS Services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off, and he wanted to separate his cloud infrastructure, or scale up his work requests, and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell. Now, before we're done, let's have a look at a quiz. Which of these services are incorrectly matched? 1, 2, 3, 4. We'll be pinning the question in the comment section. Comment below with your answer and stand a chance to win an Amazon voucher. Several companies around the world have found great success with AWS. Companies like Netflix, Twitch, LinkedIn, Facebook, and BBC have taken advantage of the services offered by AWS to improve their business efficiency. And thanks to their widespread usage, AWS professionals are in high demand. They're highly paid and earn up to more than $127,000 per annum. Once you're AWS certified, you could be one of them too.
Hello everyone, let me introduce myself as Sam, a multi-platform cloud architect and trainer, and I'm so glad and I'm equally excited to talk and walk you through this session about what AWS is and talk to you about some services and offerings and about how companies get benefited by migrating their applications and infra into AWS. So what's AWS? Let's talk about that. Now, before that, let's talk about how life was without any cloud provider, and in this case, how life was without AWS. So let's walk back and picture how things were back in 2000, which is not so long ago, but a lot of changes for better had happened since that time. Now, back in 2000, a request for a new server is not an happy thing at all, because a lot of money, a lot of validations, a lot of planning are involved in getting a server online or up and running. And even after we finally got the server, it's not all said and done. There are a lot of optimization that needs to be done on that server to make it worth it and get a good return on investment from that server. And even after we have optimized for a good return on investment, the work is still not done. There will often be a frequent increase and decrease in the capacity, and even news about our website getting popular and getting more hits, it's still an bittersweet experience, because now I need to add more servers to the environment, which means that it's going to cost me even more. But thanks to the present day cloud technology, if the same situation were to happen today, my new server, it's almost ready, and it's ready instantaneously. And with the swift tools and technologies that Amazon is providing in provisioning my server instantaneously and adding any type of workload on top of it and making my storage and server secure, creating a durable storage where data that I store in the cloud never gets lost. With all that features, Amazon has got our back. So let's talk about what is AWS. There are a lot of definitions for it, but I'm going to put together a simple and a precise definition as much as possible. Now, let me iron that out. Cloud still runs on an hardware, all right? And there are certain features in that infrastructure, in that cloud infrastructure that makes cloud, or that makes AWS a cloud provider. Now, we get all the services, all the technologies, all the features, and all the benefits that we get in our local data center, like, security and compute capacity and databases. And in fact, we get even more cool features like content caching in various global locations around the planet. But again, out of all the features, the best part is that we get everything on a pay-as-we-go model. The less I use, the less I pay, and the more I use, the less I pay per unit. Very attractive, isn't it? Right? And that's not all. The applications that we provision in AWS are very reliable because they run on a reliable infrastructure, and it's very scalable because it runs on an on-demand infrastructure, and it's very flexible because of the designs and because of the design options available for me in the cloud. Let's talk about how all this happened. AWS was launched in 2002 after the Amazon, we know as the online retail store, wanted to sell their remaining or unused infrastructure as a service or as an offering for customers to buy and use it from them, sell infrastructure as a service. The idea sort of clicked, and AWS launched their first product in 2006. That's like 4 years after the idea launch. And in 2012, they held a big-sized customer event to gather inputs and concerns from customers, and they were very dedicated in making those requests happen. And that habit is still being followed. It's still being followed as reInvent by AWS. And at 2015, Amazon announced its revenue to be $4.6 billion. And in 2015 through 2016, AWS launched products and services that help migrate customer services into AWS. Well, there were products even before, but this is when a lot of focus was given on developing migrating services. And in the same year, that's in 2016, Amazon's revenue was $10 billion. And not the least, as we speak, Amazon has more than 100 products and services available for customers and get benefited from. Alright, let's talk about the services that are available in Amazon. Let's start with this product called S3. Now, S3 is a great tool for internet backup, and it's the cheapest storage option in the object storage category. And not only that, the data that we put in S3 is retrievable from the internet. S3 is really cool. And we have other products like migration and data collection and data transfer products. And here we can not only collect data seamlessly, but also in a real-time way monitor the data or analyze the data that's being received. That there are cool products like AWS Data Transfers available that helps achieve that. And then we have products like EC2, Elastic Compute Cloud. That's an resizable computer where we can anytime alter the size of the computer based on the need or based on the forecast. Then we have simple notification services, systems and tools available in Amazon to update us with notifications through email or through SMS. Now anything can be sent through email or through SMS if we use that service. It could be alarms or it could be service notifications if you want, stuff like that. And then we have some security tools like KMS, Key Management System, which uses AES 256-bit encryption to encrypt our data at rest. Then we have Lambda, a service for which we pay only for the time in seconds it takes to execute our code, and we're not paying for the infrastructure here. It's just the seconds the program is going to take to execute the code. If it's a short program, we'll be paying in milliseconds. If it's a bit bigger program, we'll be probably paying in 60 seconds or 120 seconds. But that's lot cheap, lot simple, and lots cost effective as against paying for service on an hourly basis, which a lot of other services are. Well, that's cheap, but using Lambda is a lot cheaper than that. And then we have services like Route 53, a DNS service in the cloud. And now I do not have to maintain an DNS account somewhere else and my cloud environment with AWS. I can get both in the same place. Alright, let me talk to you about how AWS makes life easier, or how companies got benefited by using AWS as their IT provider for their applications or for the infrastructure. Now, Unilever is a company, and they had a problem, right? And they had a problem, and they picked AWS as a solution to their problem, right? Now, this company was sort of spread across 190 countries, and they were relying on a lot of digital marketing for promoting their products. And their existing environment, their legacy local environment, proved not to support their changing IT demands, and they could not standardize their old environment. Now, they chose to move part of their applications to AWS because they were not getting what they wanted in their local environment. And since then, rollouts were easy, provisioning new applications became easy, and even provisioning infrastructure became easy, and they were able to do all that in push button scaling. And needless to talk about backups that are safe and backups that can be securely accessed from the cloud as needed. Now, that company is growing along with AWS because of their swift speed in rolling out deployments and being able to access secure backups from various places and generate reports, and in fact useful reports out of it that helps their business. Now, on the same lines, let me also talk to you about Kellogg's and how they got benefited by using Amazon. Now, Kellogg's had a different problem. It's one of its kind. Now, their business model was very dependent on an infra that will help to analyze data really fast, right? Because they were running promotions based on the analyzed data that they get. So they being able to respond to the analyzed data as soon as possible was critical or vital in their environment. And luckily, SAP running on HANA environment is what they needed, and they picked that service in the cloud, and that sort of solved the problem. Now, the company does not have to deal with maintaining their legacy infra and maintaining their heavy compute capacity and maintaining their database locally. All that is now moved to the cloud, or they are using cloud as their IT service provider, and now they have a greater and powerful IT environment that very much complements their business. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital cost. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service. Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL or American Online uses AWS, and using AWS they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data, and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy-to-use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to autoscaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System, or EFS, provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. An Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system, or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can the varying load of your application traffic in a single availability zones and also across availability zones. AWS Autoscaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Autoscaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Autoscaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy a web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, CloudWatch, EC2, S3, and a lot more. And all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage. And S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment. And CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well. And it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an autoscaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an autoscaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? All right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Cloud services are now available to satisfy almost any IT requirement. Although cloud computing services vary greatly, they all have some basic qualities and benefits in common, and they can be classified into a few basic cloud service kinds. Hello everyone, I'm Shamli and I welcome you all to this new video of Simplilearn on cloud computing services. Let me give you an overview of the concepts you are going to go through in this video. First, we will go through what is cloud computing. Then we will have an introduction to cloud computing services, followed by the types of cloud computing services. And at the end, we will look into the features and benefits of cloud computing services. So let's not waste any more time and get started with the video. So what is cloud computing? Cloud computing is the distribution of cloud computing services via the internet, including servers, storage, databases, networking, software, analytics, intelligence to provide faster innovation, more flexible resources, and economies of scale. You usually only pay for the cloud services you use, which helps you cut costs, run your infrastructure more efficiently, and scale as your business grows. Now that we know what cloud computing is, let's proceed with understanding cloud computing services. Cloud computing services provide users with a variety of capabilities, including email, storage, backup, data retrieval, app creation, testing, data analysis, audio-video streaming, software on demand, regardless of the type of service. Although cloud computing is still a relatively new technology, it is now being used by a wide range of organizations, including large enterprises, small businesses, non-profit government agencies, and even individual consumers. So, not all clouds are created equal, and not every sort of cloud computing is appropriate for every situation. A variety of models, varieties, and services have evolved to assist you find the best option for your needs. To begin, one must decide on the type of cloud deployment or cloud computing architecture that will be used to implement your cloud services. Cloud services can be deployed in three different ways: public cloud, private cloud, or hybrid cloud. Now let's dive down deeper into cloud computing services and explore its type in more detail. Cloud computing, unlike a microprocessor, is not a single piece of technology. Rather, it's a system made up of three services: infrastructure as a service, platform as a service, and software as a service. So let's have a better understanding of each, starting with infrastructure as a service. So what is infrastructure as a service? It is a type of cloud computing that uses the internet to provide virtualized computing resources. The cloud provider controls IT infrastructures such as storage, server, and networking resources, and also offers them to subscribe companies via virtual machines, accessible over the internet in the IaaS model. For businesses, it can provide numerous advantages, including the ability to make tasks faster, easier, more flexible, and less expensive. Now, let's have a look at the working of IaaS. Users connect to resources and services across a wide area network, such as the internet, and then use the cloud provider's services to complete the application stack. The user can, for example, log into the infrastructure as a service platform to build virtual machines, install operating systems in each VM, deploy middleware such as databases, create storage buckets for workloads and backups, and install the enterprise workload onto that virtual machine. Customers can then track cost, monitor performance, balance network traffic, solve application difficulties, and manage disaster recovery using the provider's service. So moving ahead, let's go through its advantages and disadvantages. Advantages. Organizations select infrastructure as a service because operating a workload without having to buy, manage, and support the underlying infrastructure is frequently easier, faster, and more cost effective. A company can rent or lease infrastructure from another company using infrastructure as a service. For workloads that are transitory, experimental, or change abruptly, it is an effective cloud service paradigm. For example, if a company is creating a new software product, hiring an IaaS provider to host and test the application may be more cost effective. Once the new software has been thoroughly tested and refined, the company can move it away from the IaaS environment and into a more traditional in-house deployment. If the expenses of a long-term commitment are lower, the organization could commit the piece of software to a long-term IaaS deployment. Now, disadvantages. Billing can be a challenge for some firms. Despite its flexible pay-as-you-go model, cloud invoicing is quite detailed, and it is broken down to reflect specific service usage. When evaluating the invoices for each resource and service involved in application deployment, users frequently experience sticker shock or discover expenses that are greater than expected. Another issue it faces is lack of insight because its providers own the infrastructure. The configuration and performance of that infrastructure are rarely transparent to its consumers. Users may find it more difficult to operate and monitor systems due to the lack of transparency. Users of infrastructure as a service are also concerned about service availability and reliability. The supplier has a big influence on the workload's availability and performance. The workloads of users will be impacted if a provider has network constraint or any other type of internal or external outage. Furthermore, because it is a multi-tenant design, the problem of noisy neighbors might have an adverse effect on users' workloads. So now these are the top infrastructure as a service providers. Linode is a privately held cloud hosting firm based in the United States that offers virtual private servers. Hostwinds, web hosting, cloud hosting, and dedicated server options are all available from Hostwinds. Microsoft Azure is a cloud computing service operated by Microsoft for application management via Microsoft Managed Data Centers. DigitalOcean offers developers cloud service that make it easy to deploy and grow programs that run on several machines at the same time. Alibaba Cloud is a cloud computing firm that serves online businesses as well as Alibaba's own e-commerce ecosystem. So the second service is platform as a service. What is platform as a service? Platform as a service products which are geared towards software development teams include computing and storage infrastructure, as well as development platform layer that includes web servers, database management systems, and software development kits for multiple programming languages. Working of platform as a service. For software development, it does not replace an organization's complete IT infrastructure. It's made possible by the hosted infrastructure of a cloud service provider. A web browser is the most common way for users to access the offerings. Platform as a service such as application hosting and Java development can be supplied via public, private, or hybrid clouds. So now let's look into the advantages and disadvantages. Advantages. The main advantage of platform as a service for users is its simplicity and convenience. Much of the infrastructure and other IT services will be provided by the platform as a service provider, which users can access from anywhere via a web browser. The flexibility to pay on a per-use basis allows businesses to forego the capital costs associated with on-premises gear and software. Many platform-as-a-service solutions are aimed towards software developers. These platform provider computation and storage infrastructures, as well as text editing, version management, compilation, and testing capabilities to assist developers in swiftly and efficiently developing new software. Coming to the disadvantages, platform as a service, on the other hand, can cause issues with service availability and resilience. Customers may suffer as a result of a service outage or other infrastructure interruption, which might result in costly productivity losses. Its suppliers, on the other hand, will typically deliver reasonably high uptimes. Another widespread problem is vendor lock-in, which occurs when users are unable to simply transition many of their services and data from one platform as a service solution to another. When choosing a provider, users must consider the business risk of service outages and vendor lock-in. Internal changes to a platform as a service product could also be a problem. The impact on users might be tough and disruptive. If a platform as a service provider ceases supporting a programming language or chooses to use a different set of development tools. So let's have a look at the top platform as a service provider. IBM Cloud Computing refers to a set of cloud computing services for businesses provided by IBM, a technology corporation. Red Hat is a collection of tightly integrated Red Hat technologies for building cloud infrastructure and developing cloud-native apps on premises. Elastic Beanstalk, AWS Elastic Beanstalk, is an Amazon Web Services application deployment orchestration solution. Salesforce offers CRM services as well as enterprise applications for customer service, marketing, automation, analytics, and application development. And Software AG Cloud is an open and independent cloud platform that serves as your one-stop shop for all software AG has to offer in the cloud. Now coming to the next service, which is software as a service. So what is software as a service? Customer relationship management, or CRM, marketing automation, and business analytics are just a few of the application-level services offered by software as a service companies. So how does it work? The provider gives consumers network-based access to a single copy of an application that the provider designed expressly for software as a service distribution in the software on-demand model. The source code for the program is the same for all clients, and new features or functionalities are rolled out to all the users at the same time. The data of each model's customer may be stored locally in the cloud or both locally in the cloud, depending on the service level agreement. Coming to its advantages, customers subscribe to a software as a service solution rather than buying and installing software or additional gear to support it. Many firms can now budget more effectively and predictably by converting costs to recurrent operating expenses. You can also cancel software as a service subscriptions at any time to avoid incurring recurring fees. Its systems are frequently customizable and can be connected with other corporate applications, particularly when using software for the same vendor. Vertical scalability is a feature of cloud services like software as a service, which allows clients to access more or fewer services or features on demand. Disadvantages of software as a service. When providers endure service delays, impose undesirable modifications to service offerings, or suffer a security breach, all of these things can have a significant impact on customers' ability to use the software as a service offering. Customers should be aware of their software as a service providers SLA and ensure that it is followed. If the provider adopts a new version of an application, it will roll it out to all of its clients, whether or not they want it. This may need the organization allocating additional training time and resources. Switching vendors can be tough, as it is with any cloud service provider. Customers must migrate massive volumes of data when switching vendors. Furthermore, some vendors use technologies and data types which can make transferring client data between cloud providers even more difficult. So coming to the top companies that provide software as a service, Adobe is a collection of Adobe incorporation programs and services that provide user with access to software for graphic design, video editing, web development, and photography, as well as a set of mobile apps and certain optional cloud services. SAP is a platform as a service designed by SAP SE for developing new applications and enhancing existing ones in a secure cloud computing environment managed by SAP. Google Cloud. Google Cloud Platform is a set of cloud computing services provided by Google that run on the same infrastructure as Google's internal products, such as Google Search, Gmail, Drive, and YouTube. Freshworks Cloud Platform allows users to manage their identities and access across all of their Freshworks products. And Atlassian, advanced features such as an 99.9% uptime SLA, unlimited storage, and premium support provide teams the confidence to scale reliably. Now that we have all the in-depth information about different types of cloud computing services, let's move ahead and explore its benefits and features, which makes it so popular and convenient. First, the supplier hosts and maintains the site in their own facility. The cloud hosting provider acquires, hosts, and maintains the necessary hardware and software. Users avoid the construction expenditures and maintenance problem that would be incurred if the service was established on-premise. Second, self-service using a web-based interface. Through a web interface, service users can initiate certain service functions as well as increase or reduce their service consumption level with little or no intervention from the service provider. Third is, you must pay to utilize the facility. Users of the service only pay for the services they use. When compared to the typical method of building on-site IT capacities targeted for the highest usage situations and then having that capacity to go unused for the most of the time. This can result in significant cost savings. And the fourth one is scalability that comes close to being infinite. Cloud computing service providers usually have the infrastructure in place to deliver their services at a large scale. That means that cloud service consumers can readily accommodate business expansion or periodic surges in service usage. Well, this is all about cloud computing services.
Hello everybody, welcome to Simplilearn's AWS S3 tutorial for beginners. My name is Kent, and today I'm going to be covering these following points. I'm going to be covering what is cloud computing. I'm going to be showcasing what AWS is in terms of cloud computing, and I'm also going to be covering the core fundamental service of the Simple Storage Service, which is a object storage service. We're going to be covering the benefits of the Simple Storage Service, better known as S3, what objects and buckets are, and we're going to be seeing how things are working in the background and implementing that in terms of lab assisted demonstrations in order for you to see what those features of S3 are. And then we'll perform a wrap up of the material we've done in a conclusion. So let's get started. What is cloud computing? So here is a definition of cloud computing, but I'm going to paraphrase it. Cloud computing is nothing more than you gaining access to infrastructure through web services with a pay-as-you-go model. Now, this is a very, very different model than we're traditionally involved in on an on-prem data center. So when I mean on-prem, I'm saying on-premise. Okay, so you'll hear that a lot, on-prem. Now, when we are on on-premise data center, we have to provision lots of infrastructure even before we get started with deploying any type of application, whether it be a mobile application, a web application, etc., etc. So every application needs some sort of underlying infrastructure, whether that be bare bone servers, databases. They're obviously going to be needing some types of storage, etc., etc. So all this is something that we have to kind of fight against in order just to get started with deploying our application. So this takes usually, traditionally, depending on the size of the company, about 3 months to set up. So what if we could leverage all this infrastructure as a service and just through some API call, that's what the web services is all about, we could provision a server or we could provision a database within minutes and then deploy any type of application that we want to on top of that stack, and also take advantage of any storage that we may want. We may want object level storage, which is what we're going to cover. We may want an Elastic file system, right? So there are different types of storages that we're eventually going to look at as you go down your learning path with Simplilearn. So cloud computing is really about provisioning of all these kinds of services, but not only at the infrastructure level. We're going to see how we could move up the stack and get entire platforms as a service, or even softwares as a service. So what is AWS? Well, AWS is really a cloud computing platform that will offer us many, many services through these API calls. Some are, again, just bare infrastructure like a service. Other can be a service as a software, for example, email. So here we have an example of the public data storage. This is S3, the simple storage service icon that you're going to see over and over again. This is a representation of an actual bucket in S3. So this will become more clear as we continue the slide deck and actually reinforce this with some hands-on lab. But as you can imagine, you may want to provision a private software-defined network in the cloud. And so we can do that in AWS. We can provide load balancing. We could provide scalability in terms of auto-scaling groups that will respond to increased demand as your application, let's say, becomes more popular. You want that infrastructure to grow elastically. So doing this on premise is traditionally not only extremely expensive and thus prohibitive, but very difficult to implement physically speaking as well. So by going with a cloud provider like AWS, we can severely reduce the expense and the complexity of setting all of this up, because we're trading capital expense for variable expense. So capital expense is about you procuring all the hardware that you need beforehand and the budget being approved before even getting that hardware in through your door, right? And then you have to configure it. So there's that complexity factor. Whereas if you're doing this through AWS, you can within minutes just provision all of that very quickly. So you're also not paying for everything all up front. You're paying this with a pay-as-you-go model. So very different. We're now removing what's called undifferentiated lifting, which is everybody has to do the same thing, but it's not really bringing any value to their end product. We all have to buy servers and configure them and scale them, etc., etc. So if we remove that element and have AWS handle that, we can concentrate on our business, which is our application, and improving that application and responding more to our clients' requests. We can be more agile, more flexible. So all of this leads to these points that we see here on the slide. Much easier to use, much easier to get our application to market. We're actually going to be leveraging the physical security that AWS implements for us. They have data centers all over the world that we're going to plug into, and that physical security is already implemented for us. There are varying levels of security that we're going to get into through our AWS journey, but right off the bat, you know that you have physical security. Of course, we're going to be talking about storage in this demonstration or in this slide deck over here. But the nice thing is we only pay for what we use. So that's that variable expense that I was talking about that we've traded for capital expense. We can easily set up databases. We can easily automate our backups and have those backups stored in the cloud through that S3 storage that we're going to get into. Okay, so lots of benefits of going through AWS here. And it's also comprehensive and simple to use. Comprehensive meaning that there are hundreds and hundreds of services. It's going to be actually quite time consuming for you to just know what each service does in general, but you'll get there through your journey. It's all about sticking with it and learning something new every day, which is what Simplilearn is all about. Over here, we have infrastructure as a service, platform as a service, and software as a service. So these are three different types of distinctions we have in the cloud industry to basically cover what's going on here on the right-hand side. So on-premise, you're traditionally involved in everything from networking, which is you, for example, buying the switches, the routers, the cabling, everything all the way up the stack to deploying your application, and you see everything in between there. Okay, so this is a very time-consuming job. Not only that, but it costs a lot of money because you have to buy all these machines up front, and you have to have the individuals with the right knowledge to maintain all of this stack. All right, so different individuals in different teams maintaining this whole on-premise data center. You may also have different data centers deployed globally. So you can imagine the cost overhead of this. So everything in green is basically you're managing it. Now we can offset that and ask AWS to handle part of this stack over here. So on this second column over here, we see infrastructure as a service, which basically says, AWS, I want you to handle all the networking, my software-defined network. I want you to handle my storage, elasticity. I want you to handle my compute power, my virtual machines. I want you to handle even administrating those machines at a physical layer as well. And I want you to physically secure them. So this will allow you more time to focus on all the green up here. Of course, we can move up the stack and say, I even want AWS to take on more responsibility. And that would be more of a platform as a service where AWS would also install and maintain the operating system for you. So you can imagine things like new versions of operating systems, security patches, maintenance patches, all of the like, and any middleware or runtime that you have on top of that. Think of something like the Java virtual machine, perhaps, that needs to be updated. Now, you wouldn't be responsible for maintaining all of what's in orange over here. You would only be responsible for deploying your application and making sure that your data is saved and secured, right? So again, platform as a service is a more hands-off approach. So think of it as you wanted to set up a CI/CD deployment environment for your development team, and you want it to be very involved in just handling your application code and making sure that it was properly compiled, built, tested, and deployed, right? Well, this could be implemented as a platform as a service. Or you could take your code as a zip file and give it to AWS's service called Beanstalk, which would automatically deploy your code and make sure that it's highly available, scalable, and fault tolerant across all of the orange stack over here, right? So more of a hands-off approach. Of course, we can go all the way up the stack and tell AWS to take care of everything for us and just ask for a service. much like a utility, like electricity or water. We might want to say we just want an email software service, and we're not really concerned about how the underlying operating system or servers or network are configured for that. We just want to use the software as a service. We don't want to administrate anything else. We just want to be sort of like an end user to it. So AWS will manage everything underneath the hood. So there are varying types of services. You pick and choose whichever one makes more sense for you and your team. So what is S3? S3 stands for Simple Storage Service, and it is an object storage service in Amazon. What this means is that it doesn't matter what kind of file you upload to S3, it will be treated as an abstraction, meaning an object. So you can upload a PDF file, you can upload a JPEG file, you can upload a database backup. It doesn't really matter. All that is abstracted away by the use of storing it within an object. We're going to talk more about what composes an object, but by doing so, what happens is S3 allows us to have industry leading scalability. So it doesn't matter if you're going to make a request for that database backup, let's say that object, 5 times or 10,000 times. That request, that demand will scale. The underlying infrastructure that is implemented behind the scenes is handled for you. So in a sense, it's kind of like a serverless service, a storage service where you're not implicated in handling anything underneath the covers. You're just uploading your objects and accessing them later on. In terms of data availability, very powerful as well, because it takes those objects and will replicate them across at least 3 availability zones. Of course, these availability zones have 1 or more data centers attached to them. So you have lots and lots of copies of your objects distributed globally, or at least at a regional, in a regional area. You can do this as well globally if you enable global replication. And you will see that your level of durability will skyrocket, and you're just not going to worry about losing an S3 object. Data security. Well, we can encrypt our data at rest, our objects at rest. We can encrypt it in transit. We can also come up with security policies at the bucket level, which we're going to talk about what a bucket is very soon. These are going to be implemented through what's called IAM policies, and you're going to be able to control who or what has access to your objects. And of course, because everything is handled underneath the covers, all the servers, all the storage nodes are cloud optimized for the best possible performance. So let's continue on our journey on what is S3. We're going to take a look at what is a bucket and what is an object. As you can see here, you have inside this bucket, which is a logical container for an unlimited amount of objects. You could have objects of different shapes and sizes. Like I said, you could have pictures, database backups, etc. So this is what's being represented here by different shapes. And you can think of a bucket really as almost like a folder where objects or files are placed within them. So there are many ways for us to place objects within a bucket. We can do this through the AWS console, which I'll be showing you very shortly. We can do this via the command line interface, or we can do this through a software development kit. At the end of the day, all those 3 options go through an API, right? So it's all about picking the right method that is best suited for whatever kind of end user or application that needs access to these buckets and to these objects. Now, once you've got the data or objects within this bucket, you can control pretty much how the data is accessed, how it's stored, whether you want it to be encrypted, and how it's even managed. So you can have organizations that have specific compliance needs. For example, any objects that are placed in there, perhaps some PDFs, are not to be modified or not to be touched for 90 days. Let's say we can imply object locks if we want to. We can imply security guards. We can also, for example, record all API actions that try to access, to list, to delete any kind of API operations on those objects at the bucket level or on the object level, we can record if that is some sort of organizational compliance need for auditing or for whatever internal auditing reason that you may have. So continuing on here, you can see that there are many organizations that use S3. One in point is Amazon itself. S3 is so popular and so durable that Amazon internally uses it to store its own data. You're guaranteed, almost that you're not going to lose any object in there because it has what we call 11 nines durability. Now, 11 nines durability is really an extreme amount of durability where it's mathematically almost impossible for you to lose an object once you place it in S3. You're in fact more liable to get hit by a meteorite than you are to lose an object in S3, statistically speaking, which is a pretty incredible statistic, but it's true. So if we continue here with the benefits of S3, some of these I've already described, but let's talk about the full picture here. We see the performance, scalability, availability, and durability of S3 are really first class in the industry. Again, durability, we were talking about that 11.9. So what that really means is 99.9999 in total. If you count all the nines, that's 11 of those nines. So most durable in the industry by far. And again, because everything is handled underneath the covers, it's a serverless service. They ensure the scalability and availability and the performance of the inner workings of that object level storage. Now, cost is of course always important, and S3 really shows up here with first class support again for cost. It's got very, very low cost. We can have object level storage for let's say a terabyte of object level storage for as little as $1 a month. So again, it will depend on the kind of storage class. We're going to have a discussion on different types of storage classes that we might want to transition or move over our objects from one storage class to the next, depending on how frequently accessed that data is. As you know, data over time seems to get less and less accessed as your needs shift from one place to another. We're going to talk about that coming up very soon. So we're going to want to really focus on that to reduce our end of the month costs for storage with S3. Of course, security is always at the forefront, and we want to make sure that we either simply secure by encrypting everything right off the bat, either at rest, in transit, or we want to put an object lock or just maintain security at the bucket level, maintaining, let's say, who or what has access to that data. Because by default, no one has access to the data unless we open up the door. And also we want to make sure that we don't give public access to our bucket for obvious reasons of giving away important information by mistake. So AWS makes it extremely difficult for you to accidentally do this. And I'm going to show this in a demonstration lab coming up very soon. And we can also query in place, which is very interesting. So you can imagine you putting, let's say, a file that's in CSV format or a JSON format or Parquet format, some sort of structured format or semi-structured format in S3, and you can actually use SQL queries on the spot to filter that data in place at the bucket level. You can also have other services that may want to extract some business intelligence from that data in your S3 bucket directly as well. So some other more advanced querying operations can take place at the S3 level. So this you will learn during your journey with Simplilearn as you're covering all the AWS technology stacks. And here, the most widely used storage cloud service in the industry. Because of all the points that we just covered, it really is the #1 storage or object level storage solution in the industry. Let's now take a look at objects and buckets in S3. So the objects are really the fundamental entities that are stored in S3, or the lowest common denominator, which means that we're not really interested in what kind of data is within the object at the layer of S3, because S3 doesn't have direct access to the data within an object. Like I said before, it's an abstraction of the data. So we don't know if it's a cat picture, if it's a backup of your database. It's just treated as a fundamental entity, aka the object. Now, every object is associated with metadata, so data about itself, things like what's the name of the object, what's the size, the time and date that the object was uploaded. Things of that nature are categorized as metadata. So S3 does have direct access to that. Now, the data within that object, of course, is accessible by other services. So it's not that once you've uploaded it, you've totally lost the data and it's only can be treated as an object. It's just that at this layer, it's simply just assigned metadata and a version ID, a unique version ID. And if you re-upload the exact same object a second or third time to S3, it will have its own version ID number. So a new unique version ID number will be generated. So really what buckets are their logical containers to store those objects. So of course, at an extremely high level, a bucket would be like your root file system, if you want to think about it like that. But that doesn't mean you can't go into this bucket and create separate folders. Now, when you create separate folders in a bucket, because you might want to logically organize all your objects, you might be fooled by the fact that you think this is a hierarchical storage system, when in fact it is not. And I'll talk about that in a second. So you cannot store an object without first storing it into a bucket. So of course, the first step would be for us to create a bucket and then upload objects within that bucket. So an object cannot exist without its container or its bucket. So there's no Windows Explorer view like we're used to in an operating system, because this is not a hierarchical view. No matter if you create folders within folders within folders, in fact, S3's internal architecture is a flat hierarchy. What we do instead is we assign prefixes, which are treated as folders, in order to logically organize our objects within our buckets. And I'm going to showcase a prefix in one of the demonstrations coming up very soon. So when you create, or when you're working with S3, first of all, you're working at a regional level. You're going to have to pick a region. For example, you might pick US East 1 region or US East 2 region, and the bucket that you're going to be creating will be replicated across several availability zones, but within that region. Also, that data, those objects, can be accessed globally because S3 uses the HTTP protocol. HTTP protocol is very permissive. Everybody knows how to administrate it and work with it. So we just need to give access to that object in terms of a permission policy and give it the proper URL, or give whoever needs access to it the proper URL, and they can access that via HTTP globally. So first, when you're creating a bucket, you have to select the region, and the object will live within that region, but that doesn't mean that it still can't be accessed globally. So let's now take a minute, go over to the AWS console, and actually let me showcase how to create objects and buckets. So for our first lab, we're going to be going and creating an S3 bucket and uploading an object to it. So we first have to log into the AWS console, which we have up here in the address bar. Let's click on either create free account if it's your very first time, or as is in my case, already have an account, and we're going to sign in here. You're going to have to pass in your IAM username, password, and your account ID, of course. Once you've logged in, you can search for the simple storage service, S3, either by coming up here in the search box and typing S3 and you'll find it there. That's probably the easiest way. Or if you want, you can take a look at all the services and it'll be under storage over here, the first one. Okay, so pick whichever method you see best for yourself. Once we're here, we want to create our first bucket. Now I've already have a couple of buckets here, so we're going to go on and create a new bucket. The very first thing is you have to specify a bucket name. Now this bucket name has to be globally unique. If you take a look here at the region that we're in, it doesn't actually select a specific region. It selects the global option, which means that this bucket will become globally accessible. So that is why it needs to have a unique name, much like a DNS name has to be unique for your website, right? So I'm going to come up here and pick a name that I think is going to be unique. So I'm going to say Simplilearn S3 demo. All right, let's take a look at if that's going to work out. Of course, we have to pick a region, but it is globally accessible. So you either pick a region that's closest to your end users, or in our case, since we're just doing a demonstration, we can do whichever is closer to us right now. Okay, and we're going to skip these options for now. We're going to come back to them later on. We're just going to create the bucket. Now hopefully that was a unique name and allowed me to create that, and it looks like it did. So if I scroll down, you can see that it clearly got created over here. Now we're going to click on that and we're going to start uploading objects to this bucket. So let me click on the upload button, and you can either select one or more files, or you can select an entire folder. So I'm going to just go and select a specific cat picture that I have here. Okay, and again, we'll go through some of those other options later on, and we'll just click upload. Now this should take no time at all because of the fact that it's a very small object or file that's being uploaded. So it has succeeded. We can close this up. And we see now clearly that the object is in our bucket. If we go to properties, we can see the metadata associated with this bucket. We can see the region that it's in. We can see the ARN, which is the Amazon resource name, which uniquely identifies this resource, this bucket, across the globe. So if ever you needed to reference this, let's say in an IAM policy or whatever other service needed to communicate with S3, you would need this ARN. It's a very important piece of information. And of course, we have the creation date. Some high level metadata. So objects, as we have covered already, consist of not only the data itself, but the metadata. So there's lots of metadata, and there's a lot of other features that we can go here and enable very easily. And this will be the basis of the future demonstrations that I'm going to do. All right. So just to recap what we just did, we created a unique bucket, give it a name of Simplilearn S3 demo, and uploaded our first object to it. So let's now take a look at the inner workings of the Amazon S3. When we upload an object into a bucket, we have to select which one of these storage classes the object will reside in. So you see I have 6 storage classes here at the bottom, and each have their own characteristics that we're going to get into. By default, if you don't specify anything, it'll get placed in what's called the S3 standard storage class, which is the most expensive out of all these storage classes. Once your object gets colder, and what I mean by colder is your access patterns diminish, meaning that you're accessing that file less and less over the course of time, so it gets colder, you will transition that object from one tier to the next, all the way to, for example, S3 Deep Archive. So again, Deep Archive signifies extremely cold, so maybe you're only referencing this data once a year, once every couple of years. And so you want to have the cheapest possible storage available. So right now you can get about 1 terabyte of storage per month for about $1 a month with S3 Glacier Deep Archive. So you are going to be very interested in knowing how to transition from one or more of these storage classes over time in order to save on your storage costs. That's really why we're doing this. So let's go through some of these storage classes. By default, like I said, whenever you upload an object, you automatically get placed into the standard storage class. So any files that you're working on frequently, daily, this is the best fit for it. You've got the highest level of accessibility and durability as well. Not that the others don't have the same level of durability. However, we'll see how when you transition from one storage tier to the next, some characteristics do change in order for you to save on some costs. We're going to go through some of those. Now, this would be considered hot data, right? Data that's used all the time, maybe just by you, maybe by everybody, right? So that's the perfect place to place it in the standard storage class. Now, over time, like I said, you may find yourself working less and less, perhaps on a document that was due by the end of the month. That document was submitted, and then afterwards, you don't work on that document anymore. Perhaps you're only working on revisions based on feedback from your colleagues that are asking you to make some corrections or some amendments. And so only those corrections or amendments come in perhaps once a month. And so in that case, you might find yourself finding a justification for moving that document from the standard tier to the standard IA or infrequently accessed tier. Maybe any objects not modified for more than 30 days are a good fit for that. And that's really the criteria for IA, inactive access, is that S3 or AWS itself recommends to only put objects in there if they haven't been accessed for at least 30 days. So you get a price reduction, a rebate for putting objects that are not accessed frequently in here. Of course, if you remove objects, let's say before the 30-day limit, then you are charged a surcharge for retrieving an object that you said was infrequently accessed, but it really was not. So bear that in mind. If you're going to place objects in infrequent access, be somewhat reasonably assured that you're not going to be going there and accessing them. You can still access those files, no problem, just as quickly. They have the same level of accessibility and durability. However, like I said, anything less than 30 days, you'll get a price ding on that. If you want to have long-term storage, we're talking about Amazon Glacier. So this is more anything over 90 days that hasn't been modified, or 180 days. There's two subcategories of Amazon Glacier that we're going to get into. And this is the cheapest storage by far. And Amazon Glacier doesn't really operate through the AWS console as the same as the standard and the infrequent access. You can't really upload objects to Glacier via the console in the browser. You can only do so, let's say, through the command line interface or through an SDK. The only thing you can do on the web console with Glacier is actually create what's called a vault, which is a logical container for your archives. But then after that, you have to go through the CLI or the SDK to do the rest of the work there. If we continue on, there's some gray areas between the S3 standard and the Glacier. One is the one zone infrequently accessed storage class. So if we go back to the regular standard and IA storage class, all of these objects are stored across a minimum of 3 availability zones. If you want a further price reduction, you can store your objects in a one zone IA storage class, which means that instead of taking that object and replicating it across 3 or more availability zones, it will only store it in a single availability zone, therefore reducing the level of availability that you have to that object. So in this case here, if that single availability zone would go down, for example, you would not have access to that object. Once it would come back up, of course, you would. The other thing is if there was an immense catastrophe where the actual availability zone was destroyed, well, of course, then your object is also gone. So if that's something that doesn't worry you because you have already many copies of this object maybe lying around on premise, then this is a good option for you because it's data that you're willing to lose access to for short periods of time if ever that single availability zone goes down. So it's about an extra 20% off the price from already the normal IA standard price. There is another one called the standard reduced redundancy storage. This one is kind of getting phased out as we speak because the same price for this storage class is about the same amount you're going to pay for the normal IA standard class. What this does is, again, is a good fit for your objects that you're not really worried about losing if there is some sort of catastrophe that happens in an availability zone. There's less copies of it that are stored. And so if that data center and that availability zone goes down, then you lose your object. So of course, it offered at the time the highest price reduction possible, but now the difference between this one and the normal IA standard storage class is so small in terms of price that you're probably not going to migrate to or navigate to this storage class. But it is still there in the documentation, and it may very well come up still in the certification exam, so at least be aware of that. Let's now take a look at some individual features of S3, starting off with lifecycle management. So lifecycle management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days, like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit, okay? It doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 Intelligent Tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very, very low monitoring fee. And the nice thing is if ever you take out an object in access for the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the management tab in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like, I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs, right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition. And let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added. And also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So I'm going to create logs, create a folder. And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there, of course, just for demonstration purposes. We're going to upload that. And now we have, we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3 without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket. And that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful, but you can get more fine-grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine-grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide-ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access, or anything, any other service to have access to this S3 bucket. We could even say /* to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you could see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then try to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it. Right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker. Okay. You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it and your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets. And you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend. And that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions, something that is not enabled by default because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. Let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the management tab here a replication rule. So I'm going to create a replication rule, call it Simplilearn rep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time, or we can ask this user interface to create a new role for us. So we'll opt for that. And we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, et cetera, et cetera. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format, once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo 2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible. Of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our Simplilearn S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now, this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course, now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt, again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature. Once you enable it, as I just showed over here, this is a feature that you pay additionally for. So bear that in mind. Make sure that you take a look at the pricing page in order to figure out how much this is going to cost you. So that is it. Congratulations. You just learned how to simply enable transfer acceleration to lower the latency from the end user's point of view. We're now ready to wrap things up in our conclusion and go over at a very high level what we just spoke about. So we talked about what S3 is, which is a core service, one of the original services published by AWS in order for us to have unlimited object storage in a secure, scalable, and durable fashion. We took a look at other aspects of S3 in terms of the benefits. We mainly focused on the cost savings that we can attain in S3 by looking at different storage classes. Now, of course, S3 is industry recognized as one of the cheapest object storage services out there that has the most features available. We saw what goes into the object storage in terms of creating first our buckets, which are our containers, high-level containers in order for us to store our objects in. Again, objects are really an abstraction of the type of data that are in there, as well as the metadata associated with those objects. We took a look at the different storage tiers, the default being the standard, all the way till the cheapest one, which is the Glacier, which are meant for long-term archived objects. For example, log files that you may hold on to for a couple of years, may not need to access routinely, and will have the cheapest pricing option by far. So we have many pricing tiers, and if you want to transition from one tier to the next, you would implement a lifecycle policy or use the intelligent tiering option that can do much of this for you. We took a look at some very interesting features, starting from the lifecycle management policies that we just talked about, all the way to versioning, cross-region replication, and transfer acceleration. So with this conclusion, you are now ready to at least start working with S3. Hello everybody, my name is Kent, and today we're going to be covering AWS Identity and Access Management, also known as IAM, tutorial by Simplilearn. So these are the topics which we'll be covering today. We'll be defining what AWS security is, the different types of security in AWS, what exactly is identity and access management, the benefits of identity and access management, how IAM works, its components, its features, and at the end, we're going to do a great demo on IAM with multi-factor authentication and users and groups. So without any further ado, let's get started. So let's get started with what is AWS security. Your organization may span many regions or many accounts, and you may encompass hundreds, if not thousands, of different types of resources that need to be secured. And therefore, you're going to need a way to secure all that sensitive data in a consistent way across all those accounts in your organization while meeting any compliancy and confidentiality standards that have to be met. So for example, if you're dealing with healthcare data or credit card information or personal identification information like addresses, this is something that needs to be thought out across your organization. So of course we have individual services in AWS, which we will explore in this video. However, in order to govern the whole process at an organizational level, we have AWS Security Hub. Now, AWS Security Hub is known as a CSPM, which stands for a Cloud Security Posture Management Tool. So what does that really mean? Well, it's going to encompass, like I said, all these tools underneath the hood in order to bring a streamlined way for you to organize and adhere to these standards across your organization. It'll identify any misconfiguration issues and compliance risks by continuously monitoring your cloud infrastructure for the gaps in your security policy reinforcements. Now, why is that important? Well, these misconfigurations can lead to unwanted data breaches and also data leakages. So in order to govern this at a very high level, like I said, we need to incorporate AWS Security Hub that will automate and manage all these underlying services for us in order to perhaps take automated action. We call that remediary actions. And you can approve these actions manually, or you can automate those actions as you see fit across your organization. So let's delve a little bit deeper into what is AWS security, and then we'll start looking individually at some of these services. And so our organization has special needs across different projects and environments. So of course, the production, development, test environments, all are going to have their own unique needs. However, it doesn't matter which project or which business unit we're talking about and what are their storage backups needs. They should all be implemented in a concise, standardized way across your organization to meet that compliancy we were just talking about. So we want to automate all these tedious manual tasks that we've been doing, like ensuring that perhaps our buckets in S3 are all encrypted or all our EBS volumes are encrypted. And we want to have an automated process in place in order to give us time on other aspects of our business, perhaps our application development, to bring better business value. And that allows us to grow and innovate the company in a way that's best suited for it. So let's take a look at the different types of AWS security. Now, there are many different types of security services out there. However, we're going to concentrate primarily on IAM in this video tutorial. So I like to think of IAM as the glue between all AWS services, because by default, we don't have permission for any one service to communicate with another. So let's just take, for example, an EC2 instance that wants to retrieve an object from S3. Well, those two services could not interact unless we interacted with IAM. So something that's extremely important to learn. And by the end of this video tutorial, you'll be able to understand what IAM is. We have Amazon Guard Duty here, which is all about logs. Basically aggregates all logs from, example, CloudTrail, which we still haven't talked about. It's at the end of this list over here. But instead of looking at CloudTrail individually, Guard Duty will actually take a look at CloudTrail will take a look at your VPC flow logs, and we'll take a look at your DNS logs and monitor that account and your network and your data access via machine learning algorithms. And it'll ID any threat where you can automatically remediate the workflow that you've approved. So for example, if you know of a malicious IP address that's making API calls, well, those API calls are registered in CloudTrail, right? So this machine learning algorithm will be able to detect that and take action. So this is really governed at a higher level than you having to individually inspect all your DNS logs, flow logs, and CloudTrails individually and take action through some scripting fashion that you've come up with. So Guard Duty manages all that. We have Amazon Macie, which once again uses machine learning, but also uses pattern matching. Pattern matching can be used with matching kind of libraries that are already in place, or you can come up with your own pattern matching, and that's used to discover and protect your sensitive data. So for example, if you had healthcare data, also known as HIPAA compliancy, or credit card data that's lying around, well, Macie will discover it and will protect it. So as your data grows across your organization, that might be harder and harder to do in your own way. So Macie really facilitates discovering and protecting that, so you can concentrate on other things. AWS Config is something that kind of works in tandem with all the other services. It's able to continuously monitor your resources configurations and ensure that they match your desired configuration. So for example, maybe you state that your S3 buckets should be encrypted by default, all of them, or you want to make sure that your IAM user access keys are rotated. And if they're not, then take remediary action. So a lot of these automated remediary actions, right, are basically executed via AWS config. So you'll see the AWS config actually used by other services underneath the hood. And then you have CloudTrail. CloudTrail is all about logging every single type of API call that's made. So it'll always record the API call, who made it, from what source IP, the parameters that were sent with the API, the response, all that data, which is really a gold mine for you to investigate if there's any security threat. And again, this trail over here, and there can be many, and there's lots and lots of data generated by these trails, can be analyzed by these other services, specifically Guard Duty here, that automates that process so you don't have to. So let's get to the next one, which is, what is identity and access management? So what is IAM? Like I said, IAM is the glue between all AWS services. It will allow those services to communicate with each other once you put IAM into place. The other thing is it allows us to manage our AWS users, which are known as IAM users, and group them together into groups to facilitate assigning and retrieving or removing permissions from them instead of doing it on an individual scale. So of course, if you had 200 IAM users and you wanted in one shot to add a permission to a group that contained 200 IAM users, well, you can do that in one operation instead of 200. Now we do have a distinction between IAM users and end users. End users use applications online, whereas IAM users are your employees in your organization that are interacting directly with AWS resources. So for example, an EC2 instance would be a resource that, let's say, a developer would be interacting with. And traditionally, those are resources that are used full-time from 9 to 5, let's say, 5 days a week, 365 days a year, okay? Now, sometimes those users have to have elevated permissions for a temporary amount of time, and that is more suited for a role. And that will eliminate the need to create separate accounts just for, type of actions that are needed for, let's say, an hour a month or 2 hours a week or something like that. Something like backing up an EC2 instance, removing some files, doing some cleanups. Traditionally, you don't have those permissions as a developer, but you can be given temporary permissions to assume this role. So it's kind of like putting a hat on your head and pretending you're somebody that you're usually not for a temporary amount of time. Once you take off the hat, you go back to being your old boring IAM user self, which doesn't have access to performing backups or cleanups and stuff like that. So the roles interact with a service called a secure token service, which gives us specific keys, specifically an access key, a secret key, much like a username and password. And then we have a token key, which only gives you access to this role, this elevated permission, for 1 to 12 hours. So we'll talk more about roles as we go on through this video tutorial, but it's important that you at least remember at this point, even if you don't know all the details, that roles have to do with temporary permissions, elevated permissions. So what are the benefits of IAM? Well, across our organization, we're going to have many accounts, and like I said, hundreds if not thousands of resources. So scalability is going to be an issue if we don't have a very high level visibility and control over the entire security process. And once we have a tool like, for example, Security Hub, which we saw on the first slide, we can continuously monitor and maintain a standard across our organization. So very, very important to have that visibility. And we do when we integrate with AWS Security. Now, we also need to eliminate the human factor, right? So we don't want to manually put out fires every single time. Of course, there will be times when something new occurs that we've never seen before that will be needed. However, once an occurrence happens and reoccurs, we can obviously come up with a plan to remediate the action. So once we automate, we can definitely reduce the time to fix that reoccurring error, or it could be a new error that we don't have to interact with because we're using machine learning algorithm services like I was talking about, like GuardDuty or Macy. And we can really reduce the risk of security intrusions and data leakage and such by using IAM to facilitate this. Of course, you may have many compliance needs. You may be dealing with applications that use healthcare data or credit card information for payments, or you might be dealing with a government agency, let's say in the US, that has certain compliancy requirements that needs assurances that if their data is stored on the cloud, that you're still following the same compliance controls that you were, let's say, on premise. So we have a very, very long list of compliance requirements that each AWS service adheres to. And you can go on the AWS documentation online and you could figure out if, for example, DynamoDB is compliant with HIPAA compliancy. And it is. And so you can be assured that you can use that. So AWS itself has to constantly maintain these compliancy controls in place, and they themselves have to pass all these certifications, and that gets passed on to us. So much less work for us to implement these compliance controls. We can just inherit them by using AWS's security model by IAM. And last but not least, we can build the highest standards for privacy and data security. Now, having all this on our own on-premise data center poses security challenges, especially physical security challenges. You have to physically secure the data center. You might have security personnel that you need to hire, 24/7 camera surveillance, et cetera, et cetera. So just by migrating to the cloud, we can take advantage of AWS's global infrastructure. They're very, very good at building data centers. That's part of their business, and securing them. So of course we have a shared security model in place. However, you can rest assured that at least as the lowest common denominator, physical security has been put into place for us. Again, as other services are used, more managed services or more higher end services used in AWS, more and more of that security model will be AWS's responsibility and less yours. We will always have a certain type of responsibility for our applications, but we can again use these high-level services to ensure that our ability to encrypt the data at rest and in transit are always maintained by coming up with specific rules that need to be adhered to. And if those rules are not adhered to, then we have remediary actions that take place in order to maintain, again, that cross-account or organizational-wide security control. Okay, so lots of benefits of using IAM. And let's now take a look at exactly how IAM works and delve deeper into authentication and authorization. So there are certain terms here that we need to know about. One of them is principal. Now, principal is nothing more than an entity that is trying to interact with an AWS service, for example, an EC2 instance or an S3 bucket. Now, that could be a user, an IAM user. It could be even a service, or it could be a role. So we're going to take a look how principals need to be specified inside IAM policies. Authentication. So authentication is exactly how it sounds. Who are you? Could be something as simple as username and password, or it could involve an email address. Example, if you're the root user of the account when you're creating the account for the very first time. Other normal users will not need to log in with their user email. It'll only be the root user that needs that. You could also have developer type access, which needs access, let's say, via command line interface or a software development kit, also known as an SDK. Now, for those kind of access points, we're going to need access keys and secret keys, or public-private keys, let's say, if you want to even authenticate and log in through SSH to an EC2 instance. So there are many different types of authentication that we could set up when creating IAM users based on what kind of access they need. Do they just need access to the console? Do they need access to just services in terms of as a programmatic need? So those are different types of authentication. And then we have the actual request. Now, we could make a request in AWS through various ways. We're going to be exploring that via the console, the AWS console. However, every button you click, every drop-down list you select, that invokes an API call behind the scenes. So everything goes behind a centralized, well-documented API. Every service has an API. So if you're dealing with Lambda, let's say, well, Lambda has an API. If you're dealing with EC2, EC2 has an API. Now, you could interact with that API, like I said, via the console indirectly. You could use a command line interface. You can use an SDK for your favorite programming language like Python. So all of them get funneled through, all your requests get funneled through an API. But that doesn't mean you're allowed to do everything just because we know who you are and you have access to some keys, let's say, to make some API calls. You have to be authorized in order to perform certain actions. So maybe you're only authorized to communicate with DynamoDB, and also maybe you're only authorized to perform reads and not writes. So we can get some very fine-grained authorization through some IAM policies in order to control not only who has access to our AWS, but what they're allowed to do. So very fine-grained actions, read actions, write actions, both, maybe just describe or list some buckets. So depending on the AWS user that's logged in, we can control exactly what actions, because every API has fine-grained actions that we can control through IAM. And of course, many different types of resource. When we're coming up with these policies, all these actions can be grouped into resources. So perhaps we can say, well, this user only has access or read-only access to S3, specifically these buckets, and can write to DynamoDB table, but cannot terminate or shut down an EC2 instance. So all these kind of actions can be grouped into resources on a per resource basis based on the kind of role you have in the projects or in the company. So now let's take a look at the components of IAM. We've already seen that we can create IAM users and that how they are different than your normal end users. Now those entities represent a person that's working for an organization that can interact with AWS services. And some of those permissions that we assign through what's called identity-based policies to such a user will have permissions, for example, that are always necessary every time that they're logged in. So perhaps this user, Tom, always needs access to the following services over here, for example, an RDS instance or an S3 bucket, etc., etc. And sometimes they will need temporary access to other services, for example, DynamoDB. So in those cases, there would be a combination of normal IAM policies assigned to the user and certain assume role calls done at runtime in order to acquire this temporary credential, elevated permission. There is also the root user, which is different than your typical super user administrator access. There are some things that a root user can do that an administrator access cannot. For example, a root user, first of all, logs in with their email address and can also have the option to change that email address, something that is very tightly coupled to the AWS account. So you cannot change the email address with an administrator account. The other thing a root user can do is they can change the support contract. They can also view billing information or taxes information, VAT information, for example. So the best thing to do, the best practice is that once you've created your AWS account, you are obviously the root user. The best thing to do is to enable multi-factor authentication, store away those keys in a secure location, and your first administrative task should be to create an administrator super user, from which that point on you will log in as only an administrative user, and you will create other type of administrative users, and those administrative users will create other IAM users. So never log into your AWS account as a root user unless you need to access that specific functionality that I said that is over and above a super user administrator account. So here we have a set of IAM users, and we could assign to them directly IAM policies, which give them access to certain services. However, the best practice is to create groups, which is just a collection of IAM users. And suppose we have a developer group and a group of security administrators. Of course, we could assign different types of policies to that group, and every user that is assigned to the developer group will inherit those IAM permissions. Makes it much easier to manage your IAM users this way. And for the fact that also you can have users that can be assigned to groups, as you can see here, but what's not shown here that is possible as well is you could have a user that is part of two groups at the same time. The thing that you cannot have, though, is the notion of subgroup. So I can't extend this group and create a smaller group of developers out of this big group here. So we don't have hierarchical groups, but we do allow users to partake in different groups at the same time. So they will inherit those permissions, those IAM policy permissions from, for example, if user A was part of developers and user A was part of security, they would inherit these two policy statements over here. Now there is another type of IAM policy, and that is called a resource-based policy. So resource-based policies are not attached directly to, for example, users, but they're attached more to resources like an S3 bucket, for example. And so when you have such a case, a user group can't be designated as a principal to a group. That's just one of the restrictions. However, there are other ways to get around that. As I said, when you think of an IAM role, I want you to think that these are temporary credentials that are acquired at runtime and are only good for a specific amount of time. Now, an IAM role is really made up of two components. We have what's called a trust policy. So who do you trust to assume this role? Who do you trust to even make an API call to assume the role? After that, we have an IAM policy. Once you've been trusted to assume the role and you get those temporary tokens, what are you allowed to do? Maybe you're allowed to have read-write access to the DynamoDB. So here we have no long-term credentials that are connected to role. You do not assign a role to a user. The user or service will assume the role via API call via the secure token service, STS. And with those temporary credentials, we'll then be able to access, for example, an EC2 instance if the IAM policy attached to the IAM role says that you can do so. So your users and your applications perhaps running on an EC2 instance and the AWS services themselves don't normally have access to the AWS resources, but through assuming a role, they can dynamically attain those permissions at runtime. So it's a very flexible model that'll allow you to bypass the need to embed security credentials all over the place and then have to maintain those credentials and make sure they're rotated and they're not acquired by anybody trying to find a security hole in your system. So from a maintenance point of view, they're really an excellent tool to use in your toolbox, your security toolbox. So let's take a look at the components of IAM. We have the IAM policy over here, which is really just a JSON document. And that JSON document will describe what this user can do if it's attached directly to it, or if the IAM policy is attached to the group, whatever user is attached to that group will also have the same policy inherited. So these are more long-term credentials in terms of, or permissions rather, that are attached to your login for the duration of your login, whereas roles are, as we've already stated, temporary. And again, once you've established a trust relationship, then we can assign a policy, for example, a policy that gives you only read-only access to a CloudTrail to a role. Now, it's up to the user to assume that role either through the console or through some programmatic means. Whichever way is performed, the user will have to make a direct or indirect call to STS for the assume role call. Now, these permissions are examined by AWS when a user submits a request. So this all happens at runtime dynamically. So when you change a policy, it will take effect pretty much immediately as soon as the user makes the next request. That new security policy, whether you just added or removed the permission, will take immediate effect. So what we're going to do now is just really quickly go to the AWS console and actually show you how an IAM policy looks like. So I've just logged into my AWS management console, and if I search for identity and access management, it should be the first one to show up. I'll just click on that. And I want to show you actually how these IAM policies look like. If you go to the left-hand side here, there's an entry for policies, and there are different types of policies that we can filter out. So let's filter them out by type. We have customer managed, we have AWS managed, and more in line with job functions that AWS managed also. So we're going to take a look at AWS Managed. All that means is that AWS has created and will actually update, maintain these pre-established and already vetted identity policies, IAM identity policies. So I could further down maybe look at all the S3 policies that are available, and we can see there are some that allows only read-only access. There are some that will give us full access. And there are, of course, other types here that we're not all going to explore, but let's just easily kind of take a look here at the full access. You can see it's just a JSON document. And of course, you cannot modify it since this is a managed policy. However, you can copy it and modify it. And in that case, it will become your own version of it. And so it'll be customer defined. And so when you go here and you do a filter, you can filter on your own customer managed policies. So over here, we are simply allowing certain actions, right? We talked about actions before that were based on API. So here we have an API that starts with S3. So this is for the S3 API. And instead of filtering out exactly specifically what API calls are there, we're basically saying all API calls. So star representing all API actions. And again, there is another category of S3 which deals with object Lambda, and we are allowing all operations on that specific API as well. We could, if this was our own customer managed policy, actually scale down on which resource, which bucket, let's say, or which folder in a bucket this would apply to. But in this case, since this is a full access, we're basically being given permission to execute every single API action under S3 for all buckets. We're going to see in the lab or the demonstration at the end of this tutorial that I'm going to show you how to scale that down. Okay, so that's how an IAM policy looks like. And if you want to assign an IAM policy to a user, well, stay tuned for the demonstration at the end of the video tutorial. What's not at the end of the video tutorial is really how to create a role. So I'll show you what a role is here. Again, there's a whole bunch of roles already set up that we can go and take a look at here. But we can go and create our own role as well. And I might create a role, for example, that gives in EC2, let's choose EC2, access to S3. So if I click EC2 and click Next Permissions, I can actually assign the S3 permission right over here. It's just a policy, just like we took a look at. Obviously assign it a tag and review it. And I'm just going to call this my EC2 role to S3. Create the role. And because I selected EC2 as a service, it automatically will include that in the trust policy. So now when I go and I create an EC2 instance, I can attach this role to that EC2 instance, and that EC2 instance will automatically be able to, if we're using the Linux 2AMI, let's say, have access to, or full admin access to, any S3 bucket in the AWS account. So let's go take a look at where we would actually attach that role on the EC2. So when you're creating an EC2, let's just say we go here, we say launch an EC2 instance, and we'll pick this AMI over here because it'll already include the packages necessary to perform the assume role call to STS for us, so we won't have to code that. And we don't have to embed any credential keys in order to get this running, which is really good, which is the whole point of what I'm doing, because by assuming a role, I don't have to manage that. And I'm just going to pick the free T2 micro. And it is here, once you pick whatever you need, whatever VPC and whatnot, that you come to the IAM role and you select the role to be assumed dynamically. Now I have a whole bunch of them here, but this is the one that I had created here, my EC2 role to S3. And if I go and I launch this EC2 instance, and then I had an application, let's say, that needed to contact S3, or even if I went on the command line of the EC2 instance, I would be able now to communicate with the S3 service because they being AWS, would actually use this role to perform an assume role call to get those temporary STS tokens for me, which will then allow me to access my IAM policy, which gives me full access to S3, and off I go. So this is a great way, like I said, to avoid having to administrate any embedded keys in this EC2 instance. And I could take this role away at any time as well. So there you have it, a little demonstration on how to create a role, how to attach it to an EC2 instance, and also how managed and customer managed policies look like in IAM. Of course, there is also the fact that we have multiple accounts, and so we could assign a policy that will also allow a user in another account access to our account. So cross-account access is something that's very well needed, and also is a feature of IAM. So when you need to share access to resources from one account to another in your organization, we are in need of an IAM policy to facilitate that. So also roles can come into play here for that. By also assigning granular permissions, we can make sure that we implement the concept or the best practice of the least privilege access. And also we have secure access to AWS resources, because by default, again, we have the principle of least privilege, and no service can communicate with another until we enable it via IAM. So very, very secure out of the box. Of course, if you want to add an additional layer, multi-factor authentication rather, and that'll allow you to ensure through a hardware device, perhaps let's say a hardware token device, or your cell phone that has some software that generates a code that will allow you to identify you are actually the person that is typing the username and password, and not somebody who's actually stolen your username and password. So at the end of this video tutorial, we will show you, or I will show you how to enable that. And of course, identity federation is a big thing, where your users may have been defined outside of AWS. You may have thousands of users that you've already defined, let's say in an Active Directory or in an LDAP environment on-prem, and you don't want to recreate all those users again in AWS as IAM users. So we can tie in, we can link the users, your user database that's on-prem, or even users that have been your user account that's been defined, let's say on a social site like Facebook or Twitter or Google, and tie that into your AWS account. And there is an exchange of information, there is a setup to do, but at the end of the day, it is either a role in combination with an IAM policy that will allow to map what you're allowed to do once you've been authenticated by an external system. So this has to do with perhaps like I said, LDAP or Active Directory, and you can tie that in with AWS SSO. There are many different services here that can be leveraged to facilitate what we call identity federation. And of course, IAM itself is free. So it's not a service per API request. AWS is very concerned to put security first, and so IAM is free. It's just the services that you use. For example, if you're securing an EC2, of course, that EC2 instance falls under the current pricing plan. So of course, compliance, like I mentioned, is extremely important, making sure that it's business as usual in the cloud. And so, for example, if you were using the payment card industry data security standard to make sure that you're storing and processing and transmitting credit card information appropriately, in order to do your business, well, you can be assured that the services you use in AWS are PCI DSS compliance. And there's many, many other types of compliance that AWS adheres to as well. So password policies, of course, are important. By default, we do have a password policy in place, but when you go to the IAM console, you're free to update that password policy, make it more restrictive based on whatever policy you have at your company. So many features, and so I think we're ready now to go into a full demonstration, and I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called Simplilearn S3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right, and now what's going to happen is eventually when I create our two IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. It says this is a demo file which user2-MFA should only be able to have access to. So what's left to do now is to create two users, one called user1 and one called user2-MFA, and that's what we're going to do right now. Let's head over to IAM, Identity and Access Management. And on the left-hand side here, we're going to click on Users. You can see here I don't have much going on. I just got an administrator user, so I want to create two new users. We'll start with one at a time, so one called user1. Now, by default, we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now, and also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user, but I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3, star, and also object Lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users and make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user one. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create, called user2-MFA, or MFA rather. All right. So now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here, assigned MFA device. We have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now, what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case, the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do /folder1, and then I'm also going to do /star for all the objects in that folder, okay? So here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions. Very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists, or bool if exists. All right. So there's got to be a key value pair that exists. And there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. And I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. What I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder 1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user 1 and user 2-MFA, then let me just apply this. That would mean that user 1 would not be able to see the contents of our object inside folder 1, and user 2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user 1 and user 2-MFA and prove this is actually the case. So I am now logging back in as user 1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder 1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected, and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing, but with user 2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user 2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. little painful for, demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3. And I'm going to go into folder 1 of our bucket in question. And I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file which user2MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2. Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign up first. So let us go back to IAM and we're going to be creating our first group. We're going to simply create the button or click on the button create group and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission for example, let's say based on DynamoDB, right? So I'm going to get full access to DynamoDB, going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show 2 more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us. So
here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the on and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users. The end user could be in the internet. The end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment. Here, most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that, suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container, image, and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more containers in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But with when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right. This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already. And it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are 2 availability zones here. They can actually run across availability zones. And ECS has got 2 modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, Elastic network interface card, separate Elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has 2 components. You see task right here. So they have 2 components. We have ECS container instance, and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV, the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it along with the benefits that ECS provides. Previously, they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remain and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab, we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure a cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and a bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate. And this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs and These are the places where they get stored. That's not the focus as of now. Right, so I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit. And the task CPU is 0.25 virtual CPU. Name of the service. Is it a batch job? Is it a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer and port 80 receives information on port 80, HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access the service using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2. And then under EC2, I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser. And now it's accessible through the load balancer URL. Right now, this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now, using IP is not all that advisable because these containers can die and then a new container gets created, and when a new container gets created, it gets a new IP, right? So hardcoding IP is hardcoding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53. And finally, we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot, meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years. Right, and then you will gradually be, utilizing it from, 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application. You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy, and he comes up with an idea, and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested, and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application, or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser, or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And these records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency-based routing. Just like the name says, we use latency-based routing if we have resources in multiple AWS regions, and if we want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency-based routing. And for using latency-based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can shift, you can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can access it we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people, and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability, otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these sites, these companies are very critical, they're being highly available, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used with all the weighted routing. Their resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12. So let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal, and I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me. Right, click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names. Right, all that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting. Right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly. Right, it's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket. Static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider, and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier, and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer, and if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about a scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. For if you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are 2 types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now, after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons. That's it. Nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now, what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now, in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now, after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the autoscaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, autoscaling, and hence monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are 2 types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you 2 different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the client should be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and it may route, you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments, and they are created in the autoscaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is, if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances, or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the autoscaling group. So that's something which we have discussed already. Now, this autoscaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does autoscaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the autoscaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the autoscaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the autoscaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group autoscaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now understanding the worker environment, what happens is that the web server environment is the client facing. The client sends a request for an access to the web server, and in this diagram the web server further sends it to the SQS, which is a simple queue service, and the queue service sends it to the worker environment, and then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with a worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now, the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now, first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what we have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application. Put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed, that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on Select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description. It's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on Configure More Options. So let's click on Configure More Options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy our applications over it. If you wanted to modify, just click on a Modify button, And here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an Elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references, that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it, and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups or HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's in the, so we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more. Hi, this is the 4th lesson of the AWS Solutions Architect course. Migrating to the cloud doesn't mean that resources become completely separated from the local infrastructure. In fact, running applications in the cloud will be completely transparent to your end users. AWS offers a number of services to fully and seamlessly integrate your local resources with the cloud. One such service is the Amazon Virtual Private Cloud. This lesson talks about creating virtual networks that closely resemble the ones that operate in your own data centers, but with the added benefit of being able to take full advantage of AWS. So let's get started.
In this lesson, you'll learn all about virtual private clouds and understand their concept. You'll know the difference between public, private, and elastic IP addresses. You'll learn about what a public and private subnet is. And you'll understand what an internet gateway is and how it's used. You'll learn what route tables are and when they are used. You'll understand what a NAT gateway is. We'll take a look at security groups and their importance, and we'll take a look at network ACLs and how they're used in Amazon VPC. We'll also review the Amazon VPC best practices and also the costs associated with running a VPC in the Amazon cloud. Welcome to the Amazon Virtual Private Cloud and Subnet section. In this section, we're going to have an overview of what Amazon VPC is and how you use it. And we're also going to have a demonstration of how to create your own custom virtual private cloud. We're going to look at IP addresses and the use of elastic IP addresses in AWS. And finally, we'll take a look at subnets, and there'll be a demonstration about how to create your own subnets in an Amazon VPC. And here are some of the terms that are used in VPCs. There's subnets, route tables, elastic IP addresses, internet gateways, NAT gateways, network ACLs, and security groups. And in the next sections, we're going to take a look at each of these and build our own custom VPC that we'll use throughout this course. Amazon defines a VPC as a virtual private cloud that enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using the scalable infrastructure of AWS. A VPC is your own virtual network in the Amazon cloud
which is used as the network layer for your EC2 resources. And this is a diagram of the default VPC. Now there's a lot going on here, so don't worry about that. What we're going to do is break down each of the individual items in this default VPC over the coming lesson. But what you need to know is that a VPC is a critical part of the exam, and you need to know all the concepts and how it differs from your own networks. Throughout this lesson, we're going to create our own VPC from scratch, which you'll need to replicate at the end of this so you can do well in the exam. Each VPC that you create is logically isolated from other virtual networks in the AWS cloud. It's fully customizable. You can select the IP address range, create subnets, configure route tables, set up network gateways, define security settings using security groups, and network access control lists. So each Amazon account comes with a default VPC that's pre-configured for you to start using straight away, so you can launch your EC2 instances without having to think about anything we mentioned in the opening section. A VPC can span multiple availability zones in a region. And here's a very basic diagram of a VPC. It isn't this simple in reality. And as we saw in the first section, here's the default Amazon VPC, which looks kind of complicated. But what we need to know at this stage is that the CIDR block for the default VPC is always a 16 subnet mask. So in this example, it's 172.31.0.0/16. What that means is this VPC will provide up to 65,536 private IP addresses. So in the coming sections, we'll take a look at all of these different items that you can see on this default VPC. But why wouldn't you just use the default VPC? Well, the default VPC is great for launching new instances when you're testing AWS. But creating a custom VPC allows you to make things more secure, and you can customize your virtual network as you can define your own IP address range. You can create your own subnets that are both private and public, and you can tighten down your security settings. By default, instances that you launch into a VPC can't communicate with your own network. So you can connect your VPCs to your existing data center using something called hardware VPN access, so that you can effectively extend your data center into the cloud and create a hybrid environment. Now to do this, you need a virtual private gateway, and this is the VPN concentrator on the Amazon side of the VPN connection. Then on your side, in your data center, you need a customer gateway, which is either a physical device or a software application that sits on your side of the VPN connection. So when you create a VPN connection, a VPN tunnel comes up when traffic is generated from your side of the connection. VPC peering is an important concept to understand. A peering connection can be made between your own VPCs or with a VPC in another AWS account, as long as it's in the same region. So what that means is, if you have instances in VPC A, they wouldn't be able to communicate with instances in VPC B or C unless you set up a peering connection. Peering is a one-to-one relationship. A VPC can have multiple peering connections to other VPCs, but, and this is important, transitive peering is not supported. In other words, VPC A can connect to B and C in this diagram, but C wouldn't be able to communicate with B unless they were directly peered. Also, VPCs with overlapping CIDRs cannot be peered. So in this diagram you can see they all have different IP ranges, which is fine, but if they had the same IP ranges, they wouldn't be able to be peered. And finally for this section, if you delete the default VPC, you have to contact AWS support to get it back again. So be careful with it and only delete it if you have good reason to do so and know what you're doing. This is a demonstration of how to create a custom VPC. So here we are, back at the Amazon Web Services Management Console. And this time we're going to go down to the bottom left where the networking section is. I'm going to click on VPC. And the VPC dashboard will load up. Now there's a couple of ways you can create a custom VPC. There's something called the VPC Wizard, which will build VPCs on your behalf from a selection of different configurations, for example a VPC with a single public subnet or a VPC with public and private subnets. Now this is great because you click a button, type in a few details and it does the work for you. However, you're not going to learn much or pass the exam if this is how you do it. So we'll cancel that and we'll go to your VPCs and we'll click on Create a VPC. And we're presented with the Create a VPC window. So let's give our VPC a name. I'm going to call it Simplilearn_VPC. And this is the kind of naming convention I'll be using throughout this course. Next we need to give it the CIDR block, or the classless interdomain routing block. So we're going to give it a very simple one, 10.0.0.0, and then we need to give it the subnet mask. So you're not allowed to go larger than 15. So if I try to put 15 in, it says no, not going to happen. For a reference, subnet mask of 15 would give you around 131,000 IP addresses, and subnet 16 will give you 65,536, which is probably more than enough for what we're going to do. Next you get to choose the tenancy. There's two options, default and dedicated. If you select dedicated, then your EC2 instances will reside on hardware that's dedicated to you. So your performance is going to be great, but your cost is going to be significantly higher. So I'm going to stick with default. And we just click on yes, create. It'll take a couple of seconds. And then in our VPC dashboard, we can see our Simplilearn VPC has been created. Now, if we go down to the bottom here to see the information about our new VPC, we can see it has a route table associated with it, which is our default route table. So there it is. And we can see that it's only allowing local traffic at the moment. We go back to the VPC again. We can see it's been given a default network ACL. And we'll click on that and have a look. And you can see this is very similar to what we looked at in the lesson. So it's allowing all traffic from all sources, inbound and outbound. Now if we go to the subnet section and just widen the VPC area here, you can see there's no subnets associated with the VPC we just created. So that means we won't be able to launch any instances into our VPC. And to prove it, I'll just show you. We'll go to the EC2 section. So this is a glimpse into your future. This is what we'll be looking at in the next lesson. And we'll just quickly try and launch an instance. We'll select any instance, it doesn't matter. Any size, not important. So here, the network section, if I try and select Simplilearn VPC, it's saying no subnets found, this is not going to work. So we basically need to create some subnets in our VPC, and that is what we're going to look at in the next lesson. Now, private IP addresses are IP addresses that are not reachable over the internet, and they're used for communication between instances in the same network. When you launch a new instance, it's given a private IP address and an internal DNS hostname that resolves to the private IP address of the instance. But if you want to connect to this from the internet, it's not going to work. So then you'd need a public IP address, which is reachable from the internet. You can use public IP addresses for communication between your instances and the internet. Each instance that receives a public IP address is also given an external DNS hostname. Public IP addresses are associated with your instances from the Amazon pool of public IP addresses. When you stop or terminate your instance, the public IP address is released and annulled when the instance starts. So if you want your instance to retain its public IP address, you need to use something called an elastic IP address. An elastic IP address is a static or persistent public IP address that's allocated to your account and can be associated to and from your instances as required. An elastic IP address remains in your account until you choose to release it. There is a charge associated with an elastic IP address if it's in your account but not actually allocated to an instance. This is a demonstration of how to create an Elastic IP address. So we're back at the Amazon Web Services Management Console. We're going to head back down to the Networking VPC section, and we'll get to the VPC dashboard. On the left-hand side, we'll click on Elastic IPs. Now you'll see a list of any Elastic IPs that you have associated in your account. And remember, any Elastic IP address that you're using that isn't allocated to something, you'll be charged for. So I have one available, and that is allocated to an instance currently. So we want to allocate a new address, and it reminds you that there's a charge if you're not using it. I'm saying yes, allocate, and it takes a couple of seconds, and there's our new Elastic IP address. Now we'll be using this IP address to associate with the NAT gateway when we build that. AWS defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select. You can use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. The net mask for the default subnet in your VPC is always 20, which provides up to 4,096 addresses per subnet, and a few of them are reserved for AWS use. A VPC can span multiple availability zones, but a subnet is always mapped to a single availability zone. This is important to know. So here's our basic diagram, which we're now going to start adding to. So we can see the virtual private cloud, and you can see the availability zones, and now inside each availability zone we've created a subnet. Now you won't be able to launch any instances unless there are subnets in your VPC. So it's good to spread them across availability zones for redundancy and failover purposes. There's two different types of subnet, public and private. You use a public subnet for resources that must be connected to the internet, for example web servers. A public subnet is made public because the main route table sends the subnet's traffic that is destined for the internet to the internet gateway, and we'll touch on internet gateways next. Private subnets are for resources that don't need an internet connection or that you want to protect from the internet, for example database instances. So in this demonstration we're going to create some subnets, a public and a private subnet, and we're going to put them in our custom VPC in different availability zones. So we'll head to Networking and VPC, wait for the VPC dashboard to load up. We'll click on Subnets. We'll go to Create Subnet. And I'm going to give the subnet a name. So it's good to give them meaningful names. So I'm going to call this first one for the public subnet 10.0.1.0, and I'm going to put this one in the US East 1B availability zone, and I'm going to call it Simplilearn public. So it's quite a long name, I understand, but at least it makes it clear for what's going on in this example. So we need to choose a VPC. So we obviously want to put it in our Simplilearn VPC. And I said I wanted to put it in US East 1B. I'm using the North Virginia region, by the way. So we click on that. Then we need to give it the CIDR block. Now, as I mentioned earlier, when I typed in the name, that's the range I want to use. And then we need to give it the subnet mask. And we're going to go with 24, which should give us 251 addresses in this range, which obviously is going to be more than enough. If I try and put a different value in that's unacceptable to Amazon, it's going to say, it's going to give me an error and tell me not to do that. Let's go back to 24 and click. I'm going to cut and paste this, by the way, just because I need to type something very similar for the next one. Click Create. And it takes a few seconds. Okay, so there's our new subnet. And if I just widen this, you can see, so that's the IP range, that's the availability zone, it's for Simplilearn, and it's public. So now we want to create the private. So I'm going to put the name in. I'm going to give the private the IP address block of that. I'm going to put this one in US East 1C, and it's going to be the private subnet. Obviously I want it to be in the same VPC. Availability zone of US East 1C, and we're going to give it 10.0.2.0/24, and we'll click Yes, Create. And again, it takes a few seconds. Okay, so let me sort by name. So there we are, we can see now we've got our private subnet and our public subnet. In fact, let me just type in Simplilearn, there we are. So now you can see them both there. And you can see they're both in the same VPC, Simplilearn VPC. Now if we go down to the bottom, you can see the route table associated with these VPCs. And you can see that they can communicate with each other internally, but there's no internet access. So that's what we need to do next. In the next lesson, you're going to learn about internet gateways and how we can make these subnets have internet access. Welcome to the networking section. In this section, we're going to take a look at internet gateways, route tables, and NAT devices. And we'll have a demonstration on how to create each of these AWS VPC items. So to allow your VPC the ability to connect to the internet, you need to attach an internet gateway. And you can only attach one internet gateway per VPC. So attaching an internet gateway is the first stage in permitting internet access to instances in your VPC. Now here's our diagram again, and now we've added the internet gateway, which is providing the connection to the internet to your VPC. But before you can configure internet correctly, there's a couple more steps. For an EC2 instance to be internet connected, you have to adhere to the following rules. Firstly, you have to attach an internet gateway to your VPC, which we just discussed. Then you need to ensure that your instances have public IP addresses or elastic IP addresses, so they're able to connect to the internet. Then you need to ensure that your subnet's route table points to the internet gateway, and you need to ensure that your network access control and security group rules allow relevant traffic to flow to and from your instance. So you need to allow the rules to let in the traffic you want, for example HTTP traffic. After the demonstration for this section, we're going to look at how route tables, access control lists, and security groups are used. In this demonstration, we're going to create an internet gateway and attach it to our custom VPC. So let's go to Networking VPC, bring up the VPC dashboard, and on the left hand side we click on Internet Gateways. So here's a couple of internet gateways I have already, but I need to create a new one. So create Internet Gateway. I'll give it a name, which is going to be Simplilearn Internet Gateway, IGW. And I'm going to click Create. So this is an internet gateway which will connect a VPC to the internet, because at the moment our custom VPC has no internet access. So there, it's created. Simplilearn IGW. But its state is detached because it's not attached to anything. So let me try and attach it to a VPC. And it gives me an option of all the VPCs that have no internet gateway attached to them currently. So I only have one, which is Simplilearn VPC. Yes, attach. Now you can see our VPC has internet attached, and you can see that down here. So let's click on that and it will take us to our VPC. But before any instances in our VPC can access the internet, we need to ensure that our subnet route table points to the internet gateway. And we don't want to change the main route table, we want to create a custom route table. And that's what you're going to learn about next. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only be associated with one route table. However, multiple subnets can be associated with the same route table. Every VPC has a default route table, and it's good practice to leave this in its original state and create a new route table to customize the network traffic routes associated with your VPC. So here's our example, and we've added two route tables, the main route table and the custom route table. The new route table, or the custom route table, will tell the internet gateway to direct internet traffic to the public subnet. But the private subnet is still associated to the default route table, the main route table, which does not allow internet traffic to it. All traffic inside the private subnet is just remaining local. In this demonstration, we're going to create a custom route table, associate it with our internet gateway, and associate our public subnet with it. So let's go to Networking and VPC. The dashboard will load and we're going to go to Route Tables. Now our VPC only has its main route table at the moment, the default one it was given at the time it was created. So we want to create a new route table and we want to give it a name. So we're going to call it Simplilearn. I'm going to call it route table, RTB for short. And then we get to pick which VPC we want to put it in. So obviously we want to use Simplilearn VPC. So we click Create. It'll take a couple of seconds, and here you are. Here's our new route table. So what we need to do now is change its route so that it points to the internet gateway. So if we go down here to routes, at a minute you can see it's just like our main route table. It just has local access. So we want to click on Edit, and we want to add another route. So the destination is the internet, which is all the zeros, and our target, and we click on this, it gives us the option of our internet gateway, which we want to do. So now we have internet access to this subnet, to this route table. And we click on Save. Save was successful. So now we can see that as well as local access, we have internet access. Now at the moment, if we click on subnet associations, you do not have any subnet associations. So basically both our subnets, the public and private subnets, are associated with the main route table, which doesn't have internet access. So we want to change this. So we'll click on Edit, and we want our public subnet to be associated with this route table. So click on Save. So it's just saving that. So now we can see that our public subnet is associated with this route table, and this route table is associated with the internet gateway. So now anything we launch into the public subnet will have internet access. But what if we wanted our instances in the private subnet to have internet access? Well, there's a way of doing that with a NAT device, and that's what we're going to look at in the next lecture. You can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating connections with the instances in the private subnet. So we talked earlier about public and private subnets to protect your assets from being directly connected to the internet. For example, your web server would sit in the public subnet and your database in the private subnet, which has no internet connectivity. However, your private subnet database instance might still need internet access or the ability to connect to other AWS resources. If so, you can use a Network Address Translation device, or a NAT device, to do this. A NAT device forwards traffic from your private subnet to the internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IP address of your instance is replaced with the NAT device address, and when the internet traffic comes back again, the NAT device translates the address to your instance's private IP address. So here's our diagram, which is getting ever more complicated, and if you look in the public subnet, you can see we've now added a NAT device, and you have to put NAT devices in the public subnet so that they get internet connectivity. AWS provides two kinds of NAT devices, a NAT gateway and a NAT instance. AWS recommends a NAT gateway as it's a managed service that provides better availability and bandwidth than NAT instances. Each NAT gateway is created in a specific availability zone and is implemented with redundancy in that zone. A NAT instance is launched from a NAT AMI, an Amazon Machine Image, and runs as an instance in your VPC, so it's something else you have to look after, whereas a NAT gateway, being a fully managed service, means once it's installed, you can pretty much forget about it. A NAT gateway must be launched into a public subnet because it needs internet connectivity. It also needs an Elastic IP address, which you can select at the time of launch. Once created, you need to update the route table associated with your private subnet to point internet-bound traffic to the NAT gateway. This way, the instances in your private subnets can communicate with the internet. So if you remember back to the diagram when we had the custom route table, which was pointed to the internet gateway, now we're pointing our main route table to the NAT gateway, so that the private subnet also gets internet access, but in a more secure manner. Welcome to the Create a NAT Gateway demonstration, where we're going to create a NAT gateway so that the instances in our private subnet can get internet access. So we'll start by going to Networking and VPC. And the first thing we're going to do is take a look at our subnets, and you'll see why shortly. So here are our Simplilearn subnets. So this is the private subnet that we want to give internet access, but if you remember from the section, NAT gateways need to be placed in public subnets. So I'm just going to copy the name of this subnet ID for the public subnet, and you'll see why in a moment. So then we go to NAT gateways on the left hand side, and we want to create a new NAT gateway. So we have to put a subnet in there. So we want to choose our public subnet. Now, as you can see, it truncates a lot of the subnet names on this option, so it's a bit confusing. So we know that we want to put it in our Simplilearn VPC in the public subnet, but you can see it's truncated. So it's actually this one at the bottom, but what I'm going to do is just paste in the subnet ID, which I copied earlier, so there's no confusion. Then we need to give it an Elastic IP address. Now, if you remember from the earlier demonstration, we created one, so let's select that. But if you hadn't allocated one, you could click on the Create New EIP button. So we'll do that. Okay, so it's telling me my NAT gateway has been created. And in order to use your NAT gateway, ensure that you edit your route table to include a route with a target of, and then our NAT gateway ID. So it's given us the option to click on our edit route tables. So we'll go straight there. Now here's our route tables. Now, here's the custom route table that we created earlier, and this is the default, the main route table, which was created when we created our VPC. So we should probably give this a name so that we know what it is. So let me just call this Simplilearn RTB main. So now we know that's our main route table. So if you take a look at the main route table and the subnet associations, you can see that our private subnet is associated with this table. So what we need to do is put a route in here that points to the NAT gateway. So if we click on routes and edit, and we want to add another route, and we want to say that all traffic can either go to the Simplilearn internet gateway, which we don't want to do. We want to point it to our NAT instance, which is this NAT ID here. And we click Save. So now any instances launched in our private subnet will be able to get internet access via our NAT gateway. Welcome to the Using Security Groups and Network ACL section. In this section, we're going to take a look at security groups and network ACLs, and we're going to have a demonstration on how you create both of these items in the Amazon Web Services console. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. Basically, a security group controls the inbound and outbound traffic for one or more EC2 instances. Security groups can be found on both the EC2 and VPC dashboards in the AWS Web Management Console. We're going to cover them here in this section, and you'll see them crop up again in the EC2 lesson. And here is our diagram, and you can see we've now added security groups to it. And you can see that EC2 instances are sitting inside the security groups, and the security groups will control what traffic flows in and out. So let's take a look at some examples, and we'll start with a security group for a web server. Now obviously a web server needs HTTP and HTTPS traffic as a minimum to be able to access it. So here is an example of the security group table, and you can see we're allowing HTTP and HTTPS, the ports that are associated with those two, and the sources, and we're allowing it from the internet. We're basically allowing all traffic to those ports, and that means any other traffic that comes in on different ports would be unable to reach the security group and the instances inside it. Let's take a look at an example for a database server security group. Now imagine you have a SQL Server database, then you would need to open up the SQL Server port so that people can access it. Which is port 1433 by default, so we've added that to the table and we've allowed the source to come from the internet. Now because it's a Windows machine, you might want RDP access so you can log on and do some administration. So we've also added RDP access to the security group. Now you could leave it open to the internet, but that would mean anyone could try and hack their way into your box. So in this example we've added a source IP address of 10.0.0.0.0. So only IP ranges from that address can RDP to the instance. Now there's a few rules associated with security groups. By default, security groups allow all outbound traffic. So if you want to tighten that down, you can do so in a similar way to you can define the inbound traffic. Security group rules are always permissive. You can't create rules that deny access, so you're allowing access rather than denying it. Security groups are stateful, so if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. And you can modify the rules of a security group at any time, and the rules are applied immediately. Welcome to the Create Security Group demonstration, where we're going to create two security groups, one to host DB servers and one to host web servers. Now if you remember from the best practices section, it said it was always a good idea to tier your applications into security groups, and that's exactly what we're going to do. So if we go to networking and VPC to bring up the VPC dashboard, on the left hand side under security we click on security groups. Now you can also get to security groups from the EC2 dashboard as well. So here's a list of my existing security groups, but we want to create a new security group, and we're going to call it Simplilearn Web Server SG security group, and we'll give the group name as the same, and our description is going to be Simplilearn Web Servers security groups. Okay, and then we need to select our VPC. Now it defaults to the default VPC, but obviously we want to put it in our Simplilearn VPC. So we click Yes, Create. Takes a couple of seconds. And there it is, there's our new security group. Now if we go down to the rules, the inbound rules, you can see there are none. So by default, a new security group has no inbound rules. But what about outbound rules? If you remember from the lesson, a new security group by default allows all traffic to be outbound. And there you are, all traffic has destination of everywhere. So all traffic is allowed. But we want to add some rules. So let's click on inbound rules, click on edit. Now this is going to be a web server. So if we click on the drop down, we need to give it HTTP. So you can either choose custom TCP rule and type in your own port ranges, or you can just use the ones they have for you. So HTTP, this pre-populates the port range. And then here you can add the source. Now if I click on it, it's giving me the option of saying allow access from different security groups. So you could create a security group and say I only accept traffic from a different security group, which is a nice way of securing things down. You could also put in here just your IP address so that only you could do HTTP requests to the instance. But because it's a web server, we want people to be able to see our website, otherwise it's not going to be much use. So we're going to say all traffic, so all source traffic can access our instance on port HTTP 80. I want to add another rule because we also want to do HTTPS, which is hiding from me. There we are. And again, we want to do the same. And also, because this is going to be a Linux instance, we want to be able to connect to the Linux instance to do some work and configuration. So we need to give it SSH access. And again, it would be good practice to tie it down to your specific IP or an IP range, but we're just going to do all for now. And then we click on save, and there we are, there we have our ranges. So now we want to create our security group for our DB servers. So let's click create security group, and then we'll go through it and give it a similar name, Simplilearn DB servers SG. And the description is going to be Simplilearn DB servers security group. And our VPC is obviously going to be Simplilearn VPC. So let's click yes, create, we'll wait a few seconds. And here's our new security group. As you can see, it has no inbound rules by default, and outbound rules allow all traffic. So this is going to be a SQL Server database server. And so we need to allow SQL Server traffic into the instance. So we need to give it Microsoft SQL port access. Now the default port for Microsoft SQL Server is 1433. Now in reality, I'd probably change the port the SQL Server was running on to make it more secure, but we'll go with this for now. And then the source. So we could choose the IP ranges again, but what we want to do is place the DB server in the private subnet and allow the traffic to come from the web server. So the web server will accept traffic, and the web server will then go to the database to get the information it needs to display on its on the website. Or if people are entering information into the website, we want the information to be stored in our DB server. So basically, we want to say that the DB servers can only accept SQL Server traffic from the web server security group. So we can select the Simplilearn web server security group as the source traffic for Microsoft SQL Server data. So we'll select that. Now our SQL Server is obviously going to be a Windows instance, so from time to time we might need to log in and configure it. So we want to give RDP access. Now again, you would probably put a specific IP range in there. We're just going to do all traffic for now. Then we click save. And there we are. So now we have two security groups, DB servers and web servers. A network ACL is a network access control list, and it's an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. You might set up network ACLs with rules similar to your security groups in order to add an additional layer of security to your VPC. Here is our network diagram, and we've added network ACLs to the mix. Now you can see they sit somewhere between the root tables and the subnets. This diagram makes it a little bit clearer, and you can see that a network ACL sits in between a root table and a subnet. And also you can see an example of the default network ACL, which is configured to allow all traffic to flow in and out of the subnets to which it's associated. Each network ACL includes a rule, whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. So if you take a look at this table, you can see on the inbound, some traffic would come in and it would look for the first rule, which is 100. And that's saying I'm allowing all traffic from all sources. So that's fine, the traffic comes in. If that rule 100 wasn't there, it would go to the asterisk rule. And the asterisk rule is saying traffic from all sources is denied. Let's take a look at the network ACL rules. Each subnet in your VPC must be associated with an ACL. If you don't assign it to a custom ACL, it will automatically be associated to your default ACL. A subnet can only be associated with one ACL. However, an ACL can be associated with multiple subnets. An ACL contains a list of numbered rules which are evaluated in order, starting with the lowest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rules that may contradict it. AWS recommends incrementing your rules by a factor of 100, so there's plenty of room to implement new rules at a later date. Unlike security groups, ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic. Welcome to the network ACL demonstration, where we're just going to have an overview of ACLs where they are in the dashboard. Now you don't need to know a huge amount about them for the exam, you just need to know how they work and where they are. So let's go to networking and VPC, and when the dashboard loads, on the left hand side under security there's network ACLs. So let's click on that. Now you can see some ACLs that are in my AWS account. So we want the one that's associated with our Simplilearn VPC. So if we extend this VPC column, that's our network ACL there, Simplilearn VPC. Now let's give it a name because it's not very clear to see otherwise. Also, I'm kind of an obsessive tagger, so let's call it Simplilearn ACL and click on the tick. So there we are. So now it's much easier to see. So we click on inbound rules. So this is exactly what we showed you in the lesson. The rule is 100, so that's the first rule that's going to get evaluated, and it's saying allow all traffic from all sources. And the outbound rules are the same. So if you wanted to tighten down the new rule, you could click edit. We would give it a new rule number, say, which would be 200. So you should always increment them in 100. So that means if you had 99 more rules you needed to put in place, you'd have space to put them in between these two. And then you could do whatever you wanted. You could say, you know, we are allowing HTTP access from all traffic, and we're allowing, or you could say, actually, you know what, we're going to deny it. So this is the way of blacklisting traffic into your VPC. Now I'm not going to save that because we don't need it, but this is where network ACLs sit, and this is where you would make any changes. It's also worth having a look at the subnet associations with your ACL. So we have two subnets in our Simplilearn VPC, so we would expect to see both of them associated with this network ACL because it's the default. And there they are. There's both our public and our private subnets are associated. And you can also see up here on the dashboard, it says default. So this is telling us this is our default ACL. If you did want to create a new network ACL, you would click create network ACL. You'd give it a name, just say new ACL, and then you would associate it with your VPC. So we would say Simplilearn VPC. Takes a few seconds, and there we are. There we have our new one. Now you can see this one says default no, because it obviously isn't the default ACL for our Simplilearn VPC, and it has no subnets associated with it. So let's just delete that because we don't need it. But there you are. There's a very brief overview of network ACLs. Welcome to the Amazon VPC Best Practices and Costs, where we're going to take a look at the best practices and the costs associated with the Amazon Virtual Private Cloud. Always use public and private subnets. You should use private subnets to secure resources that don't need to be available to the internet, such as database services. To provide secure internet access to the instances that reside in your private subnets, you should provide a NAT device. When using NAT devices, you should use a NAT gateway over NAT instances because they're a managed service and require less administration effort. You should choose your CIDR blocks carefully. Amazon VPC can contain from 16 to 65,536 IP addresses, so you should choose your CIDR block according to how many instances you think you'll need. You should also create separate Amazon VPCs for development, staging, test and production, or create one Amazon VPC with separate subnets, with a subnet each for production, development, staging and test. You should understand the Amazon VPC limits. There are various limitations on the VPC components. For example, you're allowed 5 VPCs per region, 200 subnets per VPC, 200 route tables per VPC, 500 security groups per VPC, 50 in- and outbound rules per VPC. However, some of these rules can be increased by raising a ticket with AWS support. You should use security groups and network ACLs to secure the traffic coming in and out of your VPC. Amazon advises to use security groups for whitelisting traffic and network ACLs for blacklisting traffic. Amazon recommends tiering your security groups. You should create different security groups for different tiers of your infrastructure architecture inside VPC. If you have web tiers and DB tiers, you should create different security groups for each of them. Creating tier-wise security groups will increase the infrastructure security inside the Amazon VPC. So if you launch all your web servers in the web server security group, that means they'll automatically all have HTTP and HTTPS open. Conversely, the database security group will have SQL Server ports already open. You should also standardize your security group naming conventions. Following a security group naming convention allows Amazon VPC operation and management for large-scale deployments to become much easier. Always span your Amazon VPC across multiple subnets in multiple availability zones inside a region. This helps in architecting high availability inside your VPC. If you choose to create a hardware VPN connection to your VPC using Virtual Private Gateway, you are charged for each VPN connection hour that your VPN connection is provisioned and available. Each partial VPN connection hour consumed is billed as a full hour. You'll also incur standard AWS data transfer charges for all data transferred via the VPN connection. If you choose to create a NAT gateway in your VPC, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. Data processing charges apply for each gigabyte processed through the NAT gateway. Each partial NAT gateway hour consumed is billed as a full hour. This is the practice assignment for designing a custom VPC, where you'll create a custom VPC using the concepts learnt in this lesson. Using the concepts learnt in this lesson, recreate the custom VPC as shown in the demonstrations. The VPC name should be Simplilearn VPC. The CIDR block should be 10.0.0.0/16. There should be 2 subnets, one public with a range of 10.0.1.0 and one private with a range of 10.0.2.0, and they should be placed in separate availability zones. There should be one internet gateway and one NAT gateway, and also one custom route table for the public subnet. Also create 2 security groups, Simplilearn Web Server Security Group and Simplilearn DB Server Security Group.
So let's review the key takeaways from this lesson.
Amazon Virtual Private Cloud, or VPC, enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center. but with the benefits of using scalable infrastructure of AWS. There are three types of IP address in AWS. A private IP address. This is an IP address that's not reachable over the internet, and it's used for communication between instances in the same network. A public IP address is reachable from the internet, which you can use for communication between your instances and the internet. And there's an elastic IP address. This is a static, public, persistent IP address that persists after an instance restarts, whereas a public IP address is reassociated after each restart. Amazon defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select, and a subnet is always mapped to a single availability zone. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. To allow your VPC the ability to connect to the internet, you need to attach an internet gateway to it, and you can only attach one internet gateway per VPC. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only have an association with one route table. However, multiple subnets can be associated to the same route table. And you can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services. But a NAT device will prevent the internet from initiating connections with instances inside your private subnet. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. A Network Access Control List, or Network ACL, is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets.
Today's session is on AWS SageMaker. Let's look into what we have in our today's session. So what's in it for you? We would be covering what is AWS, why do we need AWS SageMaker, what is AWS SageMaker Services, what are the benefits of using the AWS SageMaker, machine learning with AWS SageMaker, how to train a model with AWS SageMaker, how to validate a model with AWS, and the companies that are using AWS SageMaker. Along with that, we will be covering up one live demo on the AWS platform. Now let's understand what is AWS. So what is AWS? It's an Amazon Web Services. It's the largest or most widely used public cloud platform offered by Amazon. It provides services over the internet. AWS services can be used to build, monitor, and deploy any type of application in the cloud. AWS also uses the subscription pricing model. That means you only pay for whatever the services you use for. Now, why do we need AWS SageMaker? Let's look into it. So let's consider an example of one of the company, that is ProQuest. Now, before AWS SageMaker, the ProQuest is a global information content and technology company that provides valuable content such as ebooks, newspapers, etc. to the users. Before AWS SageMaker, the ProQuest requirement was to have a better user experience, maximum relevant search results. Now, after AWS SageMaker, they were able to achieve those results. So they achieved more appealing video user experience. They achieved more relevant search results for the users. Now, what do we mean by AWS SageMaker? Why this service is primarily used? So Amazon SageMaker is a cloud machine learning platform that helps users in building, training, tuning, and deploying machine learning models in a production-ready hosted environment. So it's kind of a machine learning service which is already hosted on the AWS platform. Now, what are the benefits of using AWS SageMaker? The key benefits of using AWS SageMaker are: it reduces machine learning data cost, so you can do the cost optimization while running this particular service on the AWS. All ML components are stored in a particular place in a dashboard, so they can be managed together. Highly scalable, so it can be scalable on, you can scale this particular service on the fly. It trains the models quite faster, maintains the uptime, so you can be assured that your workloads will be running all the time. It will be available all the time. High data security. So security becomes a major concern on the cloud platforms, and it ensures that you have the high data security. Along with that, you can do a data transfer to different AWS services like S3 bucket and all with the simple data transfer techniques. Now, machine learning with AWS SageMaker, let's look into it. So machine learning with AWS SageMaker is a 3-step function. So one is to build, second is to test and tune the model, and third is to deploy the model. Now with the build, it provides more than 15 widely used ML algorithms for training purpose. Now to build a model, you can collect and prepare training data, or you can select from the Amazon S3 bucket also. Choose and optimize the required algorithm. So some of the algorithms that you can select are k-means, linear regressions, logistic regression. SageMaker helps developers to customize ML instances with the Jupyter Notebook interface. In the test and tune, you have to set up and manage the environment for training. So you would need some sample data to train the model. So train and tune a model with the Amazon SageMaker. SageMaker implements hyperparameter tuning by adding a suitable combination of algorithm parameters. Also, it divides the training data and stores that in the Amazon S3. S3 is a simple storage service which is primarily used for storing the objects and the data. Hence, it is used for storing and recovering data over the internet. And below you can see that AWS SageMaker uses Amazon S3 to store data as it's safe and secure. Also, it divides the training data and stores in Amazon S3, where the training algorithm code is stored in the ECR. ECR stands for Elastic Container Registry, which is primarily used for containers and Dockers. ECR helps users to save, monitor, and deploy Docker and the containers. Later, SageMaker sets up a cluster for the input data, trains it, and stores it in the Amazon S3 itself. So this is done by the SageMaker itself. After that, you need to deploy it. So suppose you want to predict limited data at a time, you use Amazon SageMaker hosting services for that. Okay. But if you want to get prediction for an entire data set, prefer using Amazon SageMaker batch transform. Now the last step, that is to deploy the model. So once tuning is done, models can be deployed to SageMaker endpoints, and in the endpoint, real-time prediction is performed. So you would have some data which you would reserve and validate your model whether it is working correctly or not. Now evaluate your model and determine whether you have achieved your business goals. Now the other aspect is how we can train a model with AWS SageMaker. So this is basically a flow diagram which shows you how to train a model with the AWS SageMaker, and here we have used a couple of services of an AWS to get that done. So model training in AWS SageMaker is done on machine learning compute instances, and here we can see there are two machine learning compute instances used as helper code and the training code. Along with that, we are using two S3 buckets and the ECR for the container registry. Now let's look into what are the ways to train the model as per the slides. So below are the following requirements to train a model. So here in the diagram you can see these are the following requirements to train a model. The URL of an Amazon S3 bucket where the training data is stored, that is mentioned. The compute resources on machine learning compute instances. So these are all your machine learning compute instances. Then the URL of an Amazon S3 bucket where the output will be stored, and the path of AWS Elastic Container Registry where the code data is saved. The inference code image lies in the Elastic Container Registry. Now what are these called? These are called as the training jobs. Now when a user trains a model in Amazon SageMaker, he/she creates a training job. So we need to first create a training job, and then the input data is fetched from the specified Amazon S3 bucket. Once the training job is built, Amazon SageMaker launches the ML compute instances. So these compute instances will be launched once the training job is built. Then it trains the model with the training code and the data set, and it shows the output and model artifacts in the AWS S3 bucket. So this is done automatically. Now here the helper code performs a task when the training code fails. The interference code which is in the Elastic Container Registry, consists of multiple linear sequence containers that process the request for inference on data. The EC2 Container Registry is a container registry that helps users to save, monitor, and deploy container images, whereas container images are the ready applications. Once the data is trained, the output is stored in the specified Amazon S3 bucket. So here you can see the output will be stored here. To prevent your algorithm being deleted, save the data in Amazon SageMaker critical system, which can process your ML compute instances. Now, how to validate a model? Let's look into it. So you can evaluate your model using offline or using the historical data. So first thing is that you can do the offline testing to validate a model. You can do an online testing with the live data. So if you have a live data coming or real-time streams coming, you can validate a model from there as well. You can validate using a holdout set, and also you can validate using the k-fold validation. Now use historical data to send requests to the model through the Jupyter Notebook in Amazon SageMaker for the evaluation. Online testing with live data deploys multiple models into the endpoints of Amazon SageMaker and directs live traffic to the model for validation. Validating using a holdout set is part of the data is set aside, which is called holdout set. So the part of the data is left, which is basically called as the holdout set. This data is not used for the model training. So later, when the model is trained with the remaining input data and generalize the data based on what is learned initially. So whatever the data which is left out will be used for validating a model, because we have not used that data while training a model. The k-fold validation is the input data is split into two parts. One part is called k, which is the validation data for testing the model, and the other part is k-1, which is used as a training data. Now, based on the input data, the machine learning model evaluates the final output. Now, the companies that are using AWS SageMaker, one is the ADP. So you must be knowing about ADP, Zalando, Dow Jones, which is the stock market, ProQuest, and the Intuit. Now let's look into the demo that how we can actually run the AWS SageMaker. So we'll use the R algorithm and then package the algorithm as a container for building, training, and deploying a model. We are going to use the Jupyter Notebook for that, for model building, for model training, for model deployment, and the code for the demo is in the below link. So you can see here that from this link you can get the code for the demo. Let's try to do a demo on the AWS. Now I would be using a link which is provided by Amazon to build, train, and deploy the machine learning model on the SageMaker, as you can see on my screen. And in this tutorial, you would have some steps where you can put those steps and the code, Python codes, into your AWS SageMaker Jupyter Lab. So in this tutorial, you will learn how to use Amazon SageMaker to build, train, and deploy a machine learning model. And for that, we will use the popular XGBoost ML algorithm for this exercise. So first of all, what you need to do is you have to go to the AWS console, and there you have to create a notebook instance. So in this tutorial, you will be creating a notebook instance. You will prepare the data, train the model to learn from the data, deploy the model, evaluate your ML model's performance, and once all those activities are done, then we'll see how we can actually remove all the resources in order to prevent the extra costing. Now the first step is we have to enter to the Amazon SageMaker console. So here you can see I'm already logged in into the SageMaker console. You can click on the services, search for the SageMaker here, and here you get the Amazon SageMaker service. Now the next step is that we have to create a notebook instance. So we will select the notebook instance from the SageMaker service, and then after the notebook instance is selected, we'll put a name to our instance and we'll create a new IAM role for that. So let's wait for the SageMaker Studio to open. So here you can see the studio is open, and you just have to click on the notebook instances, and here you have to create a notebook instance. So here you can see a couple of notebook instances have already been created. One of them is in service. So this is the notebook instance that we are going to use for creating the demo model. I'll show you how you can create a notebook instance. You just have to click on create notebook instance button and put your notebook instance name. So you can put something like demo-SageMaker 987, or we can put it as model. We'll go with notebook instance type as default, which is mlt2.media. And in the permission and encryptions under the IAM role, we'll click on create a new IAM role. Now, why we are creating a new IAM role? So that we can allow the SageMaker to access any S3 bucket that has been created on our account. Just click on create a role, and here you would see that the new IAM role will be created with the set of permissions. Then rest of the things we'll keep it as default, and then you just have to click on create a notebook instance. The notebook instance creation takes some time, so you just have to wait for a couple of minutes to get that in service. We already have one of the notebook instance that has been created, so we will be using that to create a demo. Now going back to the steps, so these are the steps that we have already performed. Now once the notebook instance is created, then we have to prepare the data. So in this step, we will be using the SageMaker notebook instance to pre-process the data that would require to train the machine learning model. And for that, we would be opening up the Jupyter notebook, and then we have to select an environment, a kernel environment in the Jupyter notebook that would be conda_python 3. So let's follow these steps. Go back to the SageMaker, click on the notebook instances, select the running notebook instance, and here you would select the Open Jupyter Lab. Now here you would see that the SageMaker would try to open up the Jupyter notepad, and we would be performing all our inputs into that Jupyter notebook and executing the results there itself. So just wait for the notebook to open. Now here you can see the Jupyter Lab notebook has been opened. So I would be selecting one of the notebook that has been created. So this one. So likewise, you can create your own notebook also. How you can do that? First of all, let me select the kernel environment. So I would be selecting conda_python 3 and just click on select. So how you can create your own notebook? Just have to click on file, click on new, and here you can select the notebook. Just name your notebook, select the environment conda_python 3 to run this demo. So I have my notebook open. So in the tabs, I would be putting up the Python codes, and I would be executing those codes to get the output directly. So the next step is to prepare the data, train the ML model, and deploy it. We will need to import some libraries and define a few environment variables in the Jupyter notebook environment. So I would be copying this code, which you can see that would try to import NumPy, pandas. These are all required to run the Python syntax. So just copy this code and paste it into your notebook. Right? So once you do that, execute your code, and here you can see that you get the output, which is that it has imported all the necessary libraries that have been defined in the code. Now the next step is we would create an S3 bucket into the S3 service, and for that you have to copy this Python code. Just that you have to edit it. So you have to specify this bucket name that you want to get created. So here I would provide the bucket name, which should be unique, should not overlap. So something like SageMaker -demo is the name that I have selected for the bucket. And now you have to execute that code. It says that the S3 bucket has been created successfully with the name SageMaker -demo 9876. So this is something which you can verify. So you can go to the S3 service, and there you can verify whether the bucket has been created or not. Now the next task is that we need to download the data to the AWS SageMaker instance and load it into the data frame. And for that, we have to follow this URL. So from this URL, which is build, train, deploy machine learning model, would have a data in the form of bank_clean.csv, and this will be deployed onto our SageMaker instance. We'll copy this code and paste it here and execute the code. So it says that it has successfully downloaded bank_clean.csv, which has the data inside it, and that has been loaded into the SageMaker data frame successfully. Now we have a data to build and train our machine learning model. So what we are going to do, we are going to shuffle the data and we are going to split it, one into the training data set and the other one into test data set. So for the training data set, we are going to use 70% of the customers that are listed in the CSV file, and 30% of the customers in the CSV file data, we will be using it as a test data to train the model. So we will copy the following code into a new code cell, and then we are going to run that code cell. So I'll just copy it for training the data so that we can segregate the data model, 70% for building the model and 30% for testing the data. So click on run the execution, and here you can see that we got the output successfully. Now we have to train the model from that data. So how we are going to train that model? And for that we'll use SageMaker pre-built XGBoost model, which is an algorithm. So you will need to reformat the header and first column of the training data and load the data from the S3 bucket. So what I'll do is I'll copy this syntax and paste it in the node cell. So it has the train data, it would train the model. Click on run execution. Now it is changing the S3 input class, which will be renamed to training input, because now we are training the model with the training data. So we just have to wait for some time till it gets executed completely. Now the next thing is that we need to set up the Amazon SageMaker session to create an instance of the XGBoost model. So here we are going to create this SageMaker session. We are going to create an instance of the XGBoost model, which is an estimator. So just copy that code and paste it here. Execute it. And here you can see that it will start. It has basically changed the parameter image name to the image_URI in the SageMaker Python SDK v2. Now we'll follow the next step, that is with the data loaded in the XGBoost estimator, we'll set up train the model using gradient optimization. And we'll copy the following code, and that would actually start the training of the model. So copy this code, and this would actually start training the model using our input data that we have reserved, 70% of that data that we have reserved for training the model. So just copy that, again initiate the execution, and it will start the training job. Now we'll deploy the model, and for that I would copy the deploy code, put that in the cell, and execute it. So it says parameter image will be renamed to image URI and using already existing model. So XGBoost was deployed already. If you have not done that, if you're doing it the first time, so it will initiate another XGBoost instance. So where you can find your XGBoost endpoints created, you just have to scroll down, and here under the inference, click on the endpoints, and you should find the XGBoost endpoints defined here. So here you can see that today I have created one XGBoost endpoint, and that is now in process of creating. So just refresh it, So it is still created. It is going to take some time to get that in service. Now our endpoint is in service state, so now we can use it. So going forward with the next steps, we'll try to predict whether the customer in the test data enroll for the bank product or not. For that, we are going to copy this code, put that in the Jupyter cell function and execute it. So here it gives you the output that it has actually evaluated, and the same output we got in the screenshot of the demo as well. Now we are going to evaluate the model performance. So what we are going to do, we are going to get the prediction done. So based on the prediction, we can conclude that you predicted a customer that will enroll for a certificate of deposit accurately for 90% of the customers in the test data, with a precision of 65% for enrolled and 90% which haven't enrolled for it. So for that, we are going to copy this code and execute it here in the cell. So if it is predicted correctly, that means our model is working absolutely fine. So here you can say the overall classification rate is 89.5% and there is the accurate prediction that has been made by the model. And that's what the output we can see here in the screenshot of a model. So that means our model is absolutely working fine. It has been built, deployed and trained correctly. Now the next thing is that once you are done with that, you terminate your resources, and for that you just have to copy this code and put that in the cell function so that the additional resources and the endpoints and the buckets that have been created by the Jupyter Notepad should be terminated, so that you would not be incurred with the extra costing. So just execute it, and here you would see that it would try to terminate all the additional resources that we have created from the Jupyter Notebook. Today's tutorial is on AWS CloudFront. Let's look into what we have today in the CloudFront. So what's in it for you? We would be covering up the concept of what is AWS, what was earlier before AWS CloudFront, after AWS CloudFront, what were the services that were introduced, how it benefited, what do we mean by AWS CloudFront, benefits of the using AWS CloudFront, and how AWS CloudFront actually is known as a content delivery service, the name of the companies that are using AWS CloudFront, and we would be covering up one live demo. Now, AWS is the Amazon Web Services. It's a cloud service provider that basically offers a multiple services, variety of services, such as compute power, database storage, networking, and other resources, so that you can create your solutions on the cloud and help the business grow. Now, with AWS, you only pay for whatever the services you use. So for example, if you are using a service for a couple of hours, then you pay for only that many hours that you have used that service. Before AWS CloudFront, so there is an example that we are going to talk, and that is you must be aware of an application called Spotify. So when you used to access Spotify and when you click on it, it kept on loading, and at the end you used to get the error. And the error was that the connection failed. And why you received that error? Because of a latency issue, probably a network error, right? So how you can solve these kind of a latency issues, and that is also going to, these kind of an issues are also going to impact the performance of an application. So with the introduction of AWS CloudFront, this problem of loading the application got resolved. So after AWS CloudFront, with the help of AWS CloudFront, Spotify gives the facility of updating new features, access to million songs that you can access instantly. So with the use of AWS CloudFront, the latency issues were solved, and successfully you can basically access your application. Now, what we mean by AWS CloudFront? So AWS CloudFront is a globally distributed network that is offered by AWS, Amazon Web Services, which securely delivers content to the end users across any geography with a higher transfer speed and an improved or a low latency. Now, what are the benefits of AWS CloudFront? There are multiple benefits. One is the cost effective. So it helps you to do the cost optimization when you use the CloudFront. It is time saving, so it is implemented easily, and also lot of issues with respect to accessing the application, with respect to latency and all, can be resolved. Content privacy. So the content is placed to the end users and also to the CloudFront servers in a secured manner, in a secured way. It is highly programmable and you can make the changes, amend the changes on the fly, and you can target any location, any geography across the globe. Along with that, it helps you to get the content deliver quickly. Now, how AWS CloudFront delivers the content? Let's look into the architecture. So this is a flow, and the flow is with respect to how the user is going to get a content from the CloudFront. Now, the client first access a website by typing a URL on the browser, and in the step 1 it tries to access the application. Then the client requests, when the website is open, the client requests for an object to download, such as, for example, a particular file. Now at that time the DNS routes user request to download that file to AWS CloudFront. The AWS CloudFront connects to the nearest edge locations. Edge locations are basically the servers where it caches the files, documents, and the web codes. AWS CloudFront connects to its nearest edge location in order to serve the user the request. At edge location, AWS CloudFront looks for its requested cache file. Once the file is found, let's say if the file is available in the cache of an edge location, AWS CloudFront then sends the file to the user. Otherwise, if the file is not found in the cache memory of an edge location, AWS CloudFront compares the requirement with the specification and share it with a respected server. That means a web server or a server where the file is actually available. The web server, responds to the edge location by sending the file back to the CloudFront edge location. And then as soon as the AWS CloudFront receives the file, it shares with the client, also adds the file to the cache of an edge location for a future reference. This is how the flow of a CloudFront is. Now, the name of the companies that are using the AWS CloudFront. So one of them is Geo7 app, which is a very popular app. So it uses Amazon CloudFront to deliver 15 petabytes of audio and video to its subscribers globally, which is a huge data. Sky News, it uses the service in order to unify the content for faster distribution to subscribers. The Discovery Communications also uses the CloudFront. It uses the service for delivering API, static asset, and also the dynamic content. And then the TV1 EU, Streaming Europe, is basically also uses the CloudFront service that helps in improving latency and performance that results in fastest delivery of content. Now let's look into the demo how to use CloudFront to serve private S3 bucket as a website. Now I'm going to run a CloudFront distribution demo on the AWS console, and we'll basically try to deliver the content from a private S3 bucket and then map that with the domain name using the Route 53 service. So what we need for this demo, we would need a domain URL, we would need a Route 53 service, we would need CloudFront, we have to create a CloudFront distribution, and that will be linked with our S3 bucket, the private S3 bucket, right? And in the S3 bucket, we would have one HTML file, the index.html file. So let's move into AWS console. So right now I have opened up the CloudFront distribution, and here you can see that couple of distributions have already been created. So what I'm going to do, I'm going to create a distribution. Now there are two types of delivery method for your content. One is the web distribution and the other one is RTMP. RTMP stands for real-time audio or video distribution. It's basically used for distribution of a media content or a media file which are available in the S3 bucket. Here we are going to select a web distribution because primarily we will be using files which uses protocols HTTP or the HTTPS. So you have to click on Get Started, and in the origin domain name you have to specify the bucket where your code is available. So I have a bucket already created. Here you can see. And what you need to do is you have to create a bucket with the URL name or the domain name, which you would be mapping with the Route 53 service. So this is a bucket that has already been created. Let me show you in a new tab. So here you have to go to the storage. Under the storage, you have to select the S3 bucket. Let's open the link in the new tab and let's look into how we can create the S3 buckets. Now here are a couple of buckets already created. I have created one bucket with the domain name that I'm going to use and map it with the Route 53 service. So that is basically mapped to a region which is in Ohio. And if you open up this bucket, here you will find an HTML web page. The index.html has been already added, right? So similarly, you have to create a bucket with a domain, and an index.html page needs to be uploaded there. Now again, we'll go to the CloudFront. We'll try to create a distribution. Just have to click on create distribution. Select a web delivery method. Select an origin domain, which is sunshinelearning.in. And origin path, you don't have to specify. Origin ID is this one. So basically, when you define an origin domain name, automatically the origin ID appears. You can customize this origin ID as per your requirement also. So rest of the things, primarily we keep it as a default settings only until and unless if we require some customized settings to be done. So let's say if you have to change the cache behavior settings, you can do that. Otherwise, we'll keep it as default. Now in the distribution setting, you can either select use all edge locations for the best performance. So what does AWS basically do here? It uses all the edge locations which are associated with AWS across the globe. Otherwise, you can specify based on the regions also, right? Apart from that, if you want to enable firewalls or the access control list, you can specify here. And then what you need to do is in the default root object, here you have to specify your index.html page, which is in the S3 bucket. The distribution state has to be enabled, and if you want to use IP version 6 as well, you need to enable it. Click on create distribution. Now you can see here a distribution has been created. It's in progress and it is enabled. And it takes around 15 to 20 minutes to get that distribution completed. The reason is that the web codes, the web pages will be distributed across all the edge locations across the globe. So hence it takes time to get that done, right? Well, let's move on to Route 53 service and let's create the hosted zones. So we'll type Route 53 here, scalable DNS and domain name registration. And what we are going to do here is we are going to map our URL, the domains pointed to the name servers that will be provided by the Route 53. So we have to create a hosted zone. Let's wait for it. So now the Route 53 dashboard is open, and you can see one hosted zone is already created. So just click on the hosted zone. And in order to point the traffic from the external domains towards the AWS, you have to first point the domains traffic to the hosted zone in the Route 53. So I'll click on create hosted zone, but before that I will first delete the existing one, and then I'll create another record, another hosted zone, right? Put your domain name. Let's say I put as sunshinelearning.in, and it is acting as a public hosted zone. Rest of the things will be default. Click on create hosted zone. Now it gives you 4 name servers, and these 4 name servers has to be updated in the domain. So you have to update these name servers in a platform from where you have purchased the domain, right? So this is half of the work done. Then what you need to do is you have to go and create records. Now in the records, you can select a routing policy. So right now what we are targeting basically that the traffic from the domain should be pointed directly towards the CloudFront distribution. Hence, we are going with a simple routing right now. Click on next. Here you have to specify the record sets. So we are going to create the records. Just click on default simple record. Put here as World Wide Web. And you have to select an endpoint. So endpoint we are selecting for the CloudFront distribution. So we have to specify alias for the CloudFront distribution. Now here we are going to put the CloudFront distribution URL, and then we are going to define the simple record set. So what we need is we need a CloudFront distribution URL, which you can find it from the CloudFront service itself, and you can find the domain name here itself. You just have to copy that and then paste it here in the distribution, and then just click on define simple records. Again, click on create records, and here you can see the record set has been updated. Now this domain is basically pointed towards these name servers, which are further pointed towards the CloudFront distribution. Right now, the only thing which is left is that within the domain, from wherever you have purchased the domain, you should update these 4 name servers, and then you can see the live traffic coming on this domain will have an output from the CloudFront distribution. Today's topic is on AWS Autoscaling. So this is Akhil. I would be taking up a tutorial on the autoscaling. Let's begin with our tutorial, and let's look into what we have in today's session. So I would be covering up why we require AWS Autoscaling, what is AWS Autoscaling, what are the benefits of using the scaling service, how this autoscaling works, the different scaling plans we have, what is the difference between the snapshot and the AMI, what is a load balancer, and how many types of load balancers we have, and along with that I would be covering up a real live demo on the AWS. Let's begin with why we require AWS Autoscaling. Now, before AWS Cloud Scaling, there was a question in the mind of enterprises that they were spending a lot of money on the purchase of the infrastructure. If they have to set up some kind of a solution, so they have to purchase an infrastructure, and a one-time cost was required. So that was a burden for them in terms of procuring a server, hardware, software, and then having a team of experts to manage all those infrastructure. So they used to think that no longer they require these resources if there was a cost-efficient solution for their project. That was the project manager used to think. Now, after the AWS Cloud Scaling that was introduced, automatically the autoscaling maintains the application performance based on the user requirements at the lowest possible price. So what does the autoscaling does is that whenever there is a scalability required, it manages it automatically, and hence the cost optimization became possible. Now, what is AWS Autoscaling? Let's look into deep. So AWS Autoscaling is a service that helps users to monitor their applications and the servers and automatically adjust the capacity of their infrastructure to maintain the steadiness. So they can increase the capacity, they can even decrease the capacity also for the cost optimization. And also predictable performance at the lowest possible cost. Now, what are the benefits of autoscaling? It gave the better fault tolerance applications. You can get the servers created and you can have a clone copy of the servers so that you don't have to deploy the applications again and again. Better cost management because the scalability is decided by the AWS automatically based on some threshold parameters. It was a reliable service, and whenever the scaling is created or initiated, you can get the notifications onto your mail IDs or to your cell phones. Scalability, as I mentioned, is always there in the autoscaling. It can scale up, it can scale down as well. And it has the flexibility in terms of whenever you want to schedule it, if you want to stop it, if you want to keep the size of the servers at a fixed number, you can always make the changes on the fly, and the better availability. Now, with the use of the autoscaling, we come around with the terminology called snapshot and the AMI. Let's look into the difference between the snapshots and the AMI. Snapshots versus AMI. So in a company, there was one of the employee that was facing an issue with launching the virtual machines. So he asked his colleague a question. Is it possible to launch multiple virtual machines with a minimum amount of time? Because it takes a lot of time in terms of creating the virtual machines. The other colleague said that yes, it is possible to launch multiple EC2 instances, and that can be done at a lesser time and with the same configuration. And this can be done either you use a snapshot or the AMI on the AWS. Then the colleague said that what are the differences between the snapshot and AMI? Let's look into the difference now. The snapshots basically kind of a backup of a single EBS volume, which is just like a virtual hard drive that is attached to the EC2 instance. Whereas the AMI, it is basically used as a backup of an EC2 instance only. The snapshots opts for this when the instance contains multiple static EBS volumes. When you opt for the snapshot, whenever the instance contains multiple static EBS volumes. AMI, this is widely used to replace the failed EC2 instance. In the snapshots, here you pay only for the storage of the modified data, whereas with the AMI, you pay only for the storage that you use. The snapshots are non-bootable images on EBS volume, whereas AMI are bootable images on the EC2 instance. However, creating an AMI image will also create the EBS snapshots. Now, how does AWS Autoscaling work? Let's look into it. So for the AWS Autoscaling to work, you have to configure single unified scaling policy per application resource. And this scaling policy, with that you can explore the applications also. And then select the service you want to scale. Also, for the optimization, select do you want to optimize the cost or do you want to optimize the performance. And then keep track of scaling by monitoring or getting the notifications. Now, what are the different scaling plans we have? So, in the autoscaling, a scaling plan basically helps a user to configure a set of instructions for scaling based on the particular software requirement. The scaling strategy basically guides the service of AWS Autoscaling on how to optimize resources in a particular application. So, it's basically kind of the parameters that you set it up so that how the resource optimization can be achieved in the autoscaling. With the scaling strategies, users can create their own strategy based on their required metrics and thresholds, and this can be changed on the fly as well. What are the two types of scaling policies we have? So there are basically dynamic scaling and the predictive scaling. Now, what is dynamic scaling? It basically guides the service of AWS Autoscaling on how to optimize the resources. And it is helpful in optimizing resources for availability and particular price. Now, with scaling strategies, users can create their plan based on the required metrics and thresholds. So a metric can be like, let's say, a network in, network out, or it can be a CPU utilization, memory utilization likewise. Now, in the predictive scaling, its objective is to predict future workload based on daily and weekly trends and regular forecast future network traffic. So it is kind of a forecast that happens based on the previous past experiences. It uses a machine learning technique for analyzing that network traffic, and this scaling is like how weather forecast works, right? It provides schedule scaling actions to ensure the resource capacity is available for application requirement. Now, with the auto scaling, you would need the load balancers also, because if there are multiple instances that are created, then you would need a load balancer to distribute the load to those instances. So let's understand what do we mean by a load balancer. A load balancer basically acts as a reverse proxy, and it is responsible for distributing the network or the application traffic across multiple servers. With the help of a load balancer, you can achieve a reliability, you can achieve a fault tolerance of an application. That is basically, it increases the fault tolerance and the reliability. So for example, when there is a high network traffic that is coming to your application, and if that much traffic comes to your application to the instances, your instances may crash. So how you can avoid that situation? So you need to manage the network traffic that is coming to your instances, and that can be done with the load balancer. So thanks to the AWS load balancers, which helps in distributing network traffic across backend servers in a way that it increases performance of an application. Here in the image, you can see the traffic coming from a different resources landing onto the EC2 instance, and the load balancer is actually distributing that traffic to all the 3 instances, hence managing the network traffic quite properly. Now, what are the types of load balancers we have? There are 3 types of load balancers on the AWS. One is the classic load balancer, second is the application load balancer, and the third one is the network load balancer. Let's look into what we have in the classic load balancer. So the classic load balancer is the most basic form of load balancing, and we call it as a primitive load balancer also, and it is widely used for the EC2 instances. It is based on the IP address and the TCP port, and it routes network traffic between end users as well as in between the backend servers. And it does not support host-based routing, and it results in low efficiency of resources. Let's look into what we have in the application load balancer. This is one of the advanced forms of load balancing. It performs a task on the application level in the OSI model. It is used when there are HTTP and HTTPS traffic routing is required, and also it supports the host-based and path-based routing and performs well with the microservices or the backend applications. The network load balancer performs the task at layer 4 of the connection level in the OSI model. The prime role of the network load balancer is to route the TCP traffic, and it can manage a massive amount of traffic and is also suitable to manage the low latencies. Let's look into the demo and see how practically we can create the autoscaling. Hi guys, let's look into the demo for how we can create an autoscaling on the AWS console. So right now I'm logged into the AWS console and I am in the Mumbai region. What you need to do is you have to go to the compute section, and under that click on the EC2 service. Let's wait for the EC2 service to come. Now just scroll down, and under the load balancing there is an option called autoscaling. So there first you have to create a launch configuration, and then after that you have to create the autoscaling groups. So click on launch configuration, and then you have to click on create launch configurations. So click on create launch configuration. Now this launch configuration is basically the set of parameters that you define while launching an autoscaling, so that this uniformity is maintained with all the instances. So that includes, let's say if you select a Windows OS or a Linux OS, that particular type of an operating system will be implemented in all the instances that will be part of an autoscaling. So there are certain set of parameters that we have to specify during the launch configuration, so that we can have a uniformity in terms of launching the servers. So here I would select an Amazon Linux AMI, and then I would select the type of a server, which will be t2.micro. Click on configure details, put the name to the launch configuration. Let's say we put it as a demo, and the rest of the things we'll keep it default. Click on add storage. Since it's a Linux AMI, we can go with the 8 GB storage. That should be fine. Click on configure security group. Let's create a new security group which has the SSH port open, and that is open for anywhere, which is basically source IPv4 and IPv6 IPs. Any IP would be able to access that. Click on review. Just review your launch configuration. If you want to make changes, you can do that. Otherwise, click on create a launch configuration. You would need the key pair, and this key pair will be a unique key pair which will be used with all the instances that are part of the autoscaling group. So we can select an existing key pair if you have that. Otherwise, you can create a new key pair. So I have an existing key pair. I'll go with that, acknowledge it, and click on create launch configuration. Now we have successfully launched the configuration of an autoscaling. The next thing is to create an autoscaling group. So click on create an autoscaling group using this launch configuration. Put a group name. Let's say we put something like test, and the group size to start with, it says 1 instance, so that means at least a single instance will always be running, and it will be initiated and running 24/7 till the auto scaling is available. You can increase the size of the minimum base instances also. Let's say you can change it to 2 also. So you would get at least 2 servers running all the time. So we'll go with the one instance. The network would be the VPC default, and in the VPC particular region, we can select the availability zones. So let's say if I select availability zone 1A and then availability zone 1B. So how the instances will be launched? So one instance will be launched in 1A, the other one in the 1B, the third one in the 1A, fourth one in the 1B. Likewise, it will be equally spread among the availability zones. Next part is to configure the scaling policies. So click on it. If you want to keep this group at its initial size, let's say if you want to go with only a single instance or 2 instances and you don't want the scaling to progress, you can put it, keep this group at its initial size. So this is basically a way to halt the scaling. But we'll use the scaling policies to adjust the capacity of this group. So click on it. And we would scale between, let's say, minimum 1 instance that we have, and we'll scale it between 1 to 4 instances. And what condition, on what basis these instances will be scaled up or scaled down would be defined in the scale group size. So the scaling policies you can implement based on a scale group size or using the simple scaling policies using the steps. So in the scale group size, you have certain metrics. You can use average CPU utilization. You can define a metric related to average network in, average network out, or the load balancer request counts per target. And if you create the simple scaling policies using steps, then you need to create the alarms, and there you can get some more metrics that you can add up as a parameter for the auto scaling. Let's go with the scaling group size. Let's go with the metric type as average CPU utilization, and the target value here you have to specify what would be the threshold that when the instance CPU utilization is crossed, then a new instance should be initiated. So you can put a reasonable threshold for that. Let's say we put something like 85%, and whenever the instance CPU utilization is crossed 85% threshold, you will see that there will be a new instance created. Let's go to the next configure notifications, and here you can add notifications. So let's say if there is a new instance that is initiated and you want to basically be notified, so you can get notifications over your email IDs, or you can get it on the cell phones. So for that, for adding the notification, you would need the SNS service, and that is called as a simple notification service. And you have to create a topic there. You have to subscribe for the topic using your email ID, and then you should get the notifications. Click on configure tags. The tags are not mandatory. You can basically put a tag. Let's say if you want to identify the instance, what purpose it was created. Otherwise, you can leave it blank also. Click on review and review your scaling policies, notification, tags, as well as the scaling group details. Click on create auto scaling group, and here you go. Your scaling has been launched. Click on close, and you should get at least a single instance initiated automatically by the auto scaling. So let's wait for the details to appear. So here you can see our launch configuration name, demo, auto scaling group name, test, minimum instance we want 1, the maximum instances we want 4. We have selected 2 availability zones, AP South 1A, AP South 1B, and the instance 1 has been initiated. And if you want to verify where exactly this instance has been initiated, just click on the instances here, and here you will see that our single instance has been initiated, that is in service, and that has been initiated in AP South 1B. Now once the threshold of this instance crosses 85%, that is what we have defined in the scaling policies, then you should see that another instance will be initiated. So likewise, this is basically I have created steps to initiate a scaling policy, that means to increase the number of servers whenever the threshold crosses. Likewise, here itself you can add another policy to scale down the resources in case if the CPU utilization goes to a normal value. Today we are going to discuss about Amazon Redshift, which is one of the data warehouse service on the AWS. So let's begin with Amazon Redshift and let's see what we have for today's session. So what's in it for you today? We'll see what is AWS, why we require Amazon Redshift, what do we mean by Amazon Redshift, the advantages of Amazon Redshift, the architecture of Amazon Redshift, some of the additional concepts associated with the Redshift, and the companies that are using the Amazon Redshift. And finally, we'll cover up one demo which will show you the practical example that how you can actually use the Redshift service. Now, what is AWS? As we know that AWS stands for Amazon Web Service. It's one of the largest cloud providers in the market, and it's basically a secure cloud service platform provided from the Amazon. Also, on the AWS, you can create and deploy the applications using the AWS service. Along with that, you can access the services provided by the AWS over the public network, that is, over the internet. They are accessible. Plus, you pay only whatever the service you use for. Now, let's understand why we require Amazon Redshift. So earlier, before Amazon Redshift, what used to happen that the people used to, or the developers used to fetch the data from the data warehouse. So data warehouse is basically a terminology which is basically represents the collection of the data. So a repository where the data is stored is generally called as a data warehouse. Now, fetching data from the data warehouse was a complicated task because might be a possibility that the developer is located at a different geography and the data warehouse is at a different location, and probably there is not that much network connectivity or some networking challenges, internet connectivity challenges, security challenges might be, and a lot of maintenance was required to manage the data warehouses. So what were the cons of the traditional data warehouse services? It was time consuming to download or get the data from the data warehouse. Maintenance cost was high, and there was the possibility of loss of information in between the downloading of the data, and the data rigidity was an issue. Now, how these problems could overcome, and this was basically solved with the introduction of Amazon Redshift over the cloud platform. Now, we say that Amazon Redshift has solved traditional data warehouse problems that the developers were facing, but how? What is Amazon Redshift actually is? So what is Amazon Redshift? It is one of the services over the AWS, Amazon Web Services, which is called as a data warehouse service. So Amazon Redshift is a cloud-based service or a data warehouse service that is primarily used for collecting and storing the large chunk of data. So it also helps you to get or extract the data, analyze the data using some of the BI tools. So business intelligence tools you can use and get the data from the Redshift and process that. And hence it simplifies the process of handling the large scale data sets. So this is the symbol for the Amazon Redshift over the AWS. Now let's discuss about one of the use case. So DNA is basically a telecommunication company, and they were facing an issue with managing their website and also the Amazon S3 data, which led down to slow process of their applications. Now, how could they overcome this problem? Let's see that. So they overcome this issue by using the Amazon Redshift, and all the company noticed that there was a 52% increase in the application performance. Now, did you know that Amazon Redshift is basically cost less to operate than any other cloud data warehouse service available on the cloud computing platforms? And also the performance of an Amazon Redshift is the fastest data warehouse, we can say that is available as of now. So in both cases, one is that it saves the cost as compared to the traditional data warehouses, and also the performance of this Redshift service or a data warehouse service, the fastest available on the cloud platforms. And more than 15,000 customers presently they are using the Amazon Redshift service. Now let's understand some of the advantages of Amazon Redshift. First of all, as we saw that it is one of the fastest available data warehouse service, so it has the high performance. Second is, it is a low cost service. So you can have a large scale of data warehouse or the databases combined in a data warehouse at a very low cost. So whatever you use, you pay for that only. Scalability. Now, in case if you wanted to increase the nodes of the databases in your Redshift, you can actually increase that based on your requirement, and that is on the fly. So you don't have to wait for the procurement of any kind of a hardware or the infrastructure. It is whenever you require, you can scale up or scale down the resources. So the scalability is again one of the advantage of the Amazon Redshift. Availability, since it's available across multiple availability zones, so it makes this service as a highly available service. Security, so whenever you access Redshift, you create a clusters in the Redshift, and the clusters are created you can define a specific virtual private cloud for your cluster, and you can create your own security groups and attach it to your cluster. So you can design the security parameters based on your requirement, and you can get your data warehouse or the data items in a secured place. Flexibility, and you can remove the clusters, you can create another clusters. If you are deleting a cluster, you can take a snapshot of it and you can move those snapshots to different regions. So that much flexibility is available on the AWS for the service. And the other advantage is that it is basically a very simple way to do a database migration. So if you're planning that you wanted to migrate your databases from the traditional data center over the cloud on the Redshift, it is basically very simple to do a database migration. You can have some of the inbuilt tools available on the AWS, you can connect them with your traditional data center and get that data migrated directly to the Redshift. Now let's understand the architecture of the Amazon Redshift. So architecture of an Amazon Redshift is basically it combines of a cluster, and that we call it as a data warehouse cluster. In this picture, you can see that this is a data warehouse cluster and this is a representation of a Amazon Redshift. So it has some of the compute nodes which does the data processing, and a leader node which gives the instructions to these compute nodes. And also the leader node basically manages the client applications that require the data from the Redshift. So let's understand about the components of the Redshift. The client application of Amazon Redshift basically interact with the leader node using JDBC or the ODBC. Now what is JDBC? It's a Java database connectivity, and the ODBC stands for Open Database Connectivity. The Amazon Redshift service using a JDBC connector can monitor the connections from the other client applications. So the leader node can actually have a check on the client applications using the JDBC connections. Whereas the ODBC allows a leader node to have a direct interaction or to have a live interaction with the Amazon Redshift. So ODBC allows a user to interact with live data of Amazon Redshift. So it has a direct connectivity, direct access of the applications, as well as the leader node can get the information from the compute nodes. Now, what are these compute nodes? These are basically kind of a databases which does the processing. So Amazon Redshift has a set of computing resources which we call it as a nodes, and the nodes, when they are combined together, they are called it as a clusters. Now a cluster, a set of computing resources which are called as nodes, and this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1 to n number of nodes, and that's why we call that the Redshift is a scalable service, because we can scale up the compute nodes whenever we require. Now the data warehouse cluster, or each cluster, has one or more databases in the form of nodes. Now what is a leader node? This node basically manages the interaction between the client application and the compute node. So it acts as a bridge between the client application and the compute nodes. Also, it analyzes and develops designs in order to carry out any kind of a database operations. So leader node basically sends out the instructions to the compute nodes, basically perform or execute that instruction and give that output to the leader node. So that is what we are going to see in the next slide, that the leader node runs the program and assign the code to individual compute nodes, and the compute nodes execute the program and share the result back to the leader node for the final aggregation, and then it is delivered to the client application for analytics or whatever the client application is created for. So compute nodes are basically categorized into slices, and each node slice is allotted with specific memory space, or you can say a storage space, where the data is processed. These node slices works in parallel in order to finish their work, and hence when we talk about a Redshift as a faster processing capability as compared to other data warehouses or traditional data warehouses, this is because that these node slices work in a parallel operation that makes it more faster. Now, the additional concept associated with Amazon Redshift is there are two additional concepts associated with the Redshift. One is called as the column storage and the other one is called as the compression. Let's see what is the column storage. As the name suggests, column storage is basically kind of a data storage in the form of a column, so that whenever we run a query, it becomes easier to pull out the data from the columns. So column storage is an essential factor in optimizing query performance and resulting in quicker output. So one of the examples are mentioned here. So below example show how database tables store record into disk block by row. So here you can see that if we wanted to pull out some kind of an information based on the city, address, age, we can basically create a filter, and from there we can put out the details that we require, and that is going to fetch out the details based on the column storage. So that makes data more structured, more streamlined, and it becomes very easier to run a query and get that output. Now the compression is basically to save the column storage. We can use a compression as an attribute. So compression is a column level operation which decreases the storage requirement, and hence it improves the query performance. And this is one of the syntax for the column compression. Now the companies that are using Amazon Redshift, one is LYA, the other one is Equinox, the third one is the Pfizer, which is one of the famous pharmaceuticals company. McDonald's, one of the burger chains across the globe, and Philips, it's an electronic company. So these are one of the biggest companies that are basically relying, and they are putting their data on the Redshift data warehouse service. Now in another video, we'll see the demo for using the Amazon Redshift. Let's look into the Amazon Redshift demo. So these are the steps that we need to follow for creating the Amazon Redshift cluster. And in this demo, what we'll be doing is that we'll be creating an IAM role for the Redshift so that the Redshift can call the services, and specifically we'll be using the S3 service. So the role that we'll be creating, we'll be giving the permission to Redshift to have an access of an S3 in the read-only format. So in the step one, what we require, we'll check the prerequisites, and what you need to have is the AWS credentials. If you don't have that, you need to create your own credentials, and you can use your credit and the debit card. And then in the step two, we'll proceed with the IAM role for the Amazon Redshift. Once the role is created, we'll launch a sample Amazon Redshift cluster mentioned in the step 3, and then we'll assign a VPC security groups to our cluster. Now you can create it in the default VPC also, you can create a default security groups also, otherwise you can customize the security groups based on your requirement. Now to connect to the sample cluster, you need to run the queries, and you can connect to your cluster and run queries on the AWS Management Console query editor, which you will find it in the Redshift only. Or if you use the query editor, you don't have to download and set up a SQL client application separately. And in the step 6, what you can do is you can copy the data from the S3 and upload that in the Redshift, because the Redshift would have an access, a read-only access for the S3, as that will be created in the IAM role. So let's see how we can actually use the Redshift on the AWS. So I am already logged in into my account. I am in North Virginia region. I'll search for Redshift service, and here I find Amazon Redshift. So just click on it. Let's wait for the Redshift to come. Now this is a Redshift dashboard, and from here itself you have to run the cluster. So to launch a cluster, you just have to click on this launch cluster, and once the cluster is created, and if you wanted to run queries, you can open query editor, or you can basically create queries and access the data from the Redshift. So that's what it was mentioned in the steps also, that you don't require a separate SQL client application to get the queries run on the data warehouse. Now, before creating a cluster, we need to create the role. So what we'll do is we'll click on the services and we'll move to IAM role section. So IAM role I can find here under the security, identity and compliance. So just click on the identity access management and then click on create roles. So let's wait for IAM page to open. So here in the IAM dashboard, you just have to click on the roles. I already have the role created. So what I'll do is I'll delete this role and I'll create it separately. So just click on a create role, and under the AWS services, you have to select for the Redshift, because now the Redshift will be calling the other services, and that's why we are creating the role. Now, which other services that the Redshift will be having an access of? S3. Why? Because we'll be putting up the data on the S3, and that is something which needs to be uploaded on the Redshift. So we'll just search for the Redshift service, and we can find it here. So just click on it and then click on Redshift customizable in the use case. Now click on next permissions, and here in the permissions, give the access to this role, assign the permissions to this role in the form of an S3 read-only access. So you can search here for the S3 also. Let's wait for the policies to come in. Here it is. Let's type S3. And here we can find Amazon S3 read-only access. So just click on it and assign the permissions to this role. Tags, you can leave them blank. Click on next review. Put a name to your role. Let's put my Redshift role and click on a create role. Now you can see that your role has been created. Now the next step is that we'll move to Redshift service and we'll create one cluster. So click on the services click on Amazon Redshift. You can find that in the history section since we browsed it just now. And from here, we are going to create a sample cluster. Now, to launch a cluster, you just have to click on launch this cluster. Whatever the uncompressed data size you want in the form of a gigabyte, terabyte, or petabyte, you can select that. And let's say if you select in the form of GB, how much GB memory you want, you can define it here itself. This also gives you the information about the costing. On demand is basically pay as you use. So they are going to charge you $0.5 per hour for using the 2 node slices. So let's click on launch this cluster, and this will be a DC2.large kind of an instance that will be given to you. It would be in the form of a solid state drive, SSDs, which is one of the fastest way of storing the information. And the nodes 2 are mentioned by default. That means there will be 2 node slices that will be created in a cluster. You can increase them also. Let's say if I put 3 node slices, so it is going to give us 3 into 0.16 TB per node storage. Now here you have to define the master username password for your Redshift cluster, and you have to follow the password instructions. So I would put a password to this cluster, and if it accepts, that means it does not give you any kind of a warning. Otherwise it is going to tell you about you have to use the ASCII characters and all. And here you have to assign this cluster the role that we created recently. So in the available IAM roles, you just have to click on my Redshift role, and then you have to launch the cluster. If you wanted to change something with respect to the default settings, let's say if you wanted to change the VPC from default VPC to your custom VPC, and you wanted to change the default security groups to your own security groups, so you can switch to advanced settings and do that modification. Now let's launch the cluster, and here you can see the Redshift cluster is being created. Now if you wanted to run queries on this Redshift cluster, so you don't require a separate SQL client, you just have to follow the simple steps to run a query editor, and the query editor you will find it on the dashboard. So let's click on the cluster, and here you would see that the Redshift cluster would be created with the 3 nodes in the US East 1B availability zone. So we have created the Redshift cluster in the Ohio region, and now what we'll do is we'll see how we can create the tables inside the Redshift, and we'll see how we can use the copy command so that we can directly move the data uploaded on the S3 bucket to the Redshift database tables. And then we'll query the results of a table as well. So how we can do that? First of all, after creating the Redshift cluster, we have to install SQL Workbench /J. This is not a MySQL, which is managed by Oracle, and you can find this on the Google. You can download it from there. And then you have to connect this client with the Redshift database. How you can do? Click on File, click on Connect Window, and after connecting a window, you have to paste the URL, which is a JDBC driver. This driver link, you can find it onto the AWS console. So if you open up a Redshift cluster, there you would find the JDBC driver link. Let's wait for it. So this is our cluster created. Let's open it. And here you can find this JDBC URL. And also make sure that in the security groups of a Redshift, you have the port 5439 open for the traffic, incoming traffic. You also need to have the Amazon Redshift driver, and this is the link where you can download the driver and specify the path. Once you are done with that, you provide the username and the password that you created while creating the Redshift cluster. Click on OK. So this connects with the database, and now the database connection is almost completed. Now what we will be doing in the SQL Workbench, we'll be first creating the sales table, and then in the sales table, we'll be adding up the entries copied from the S3 bucket, and then move it to the Redshift database. And after that, we'll query the results in the sales table. Now, whatever the values you are creating in the table, the same values needs to be in the data file. And I have taken up this sample data file from this link, which is docs.aws.amazon.com, Redshift, sample database creation. And here you can find a download file, ticketdb.zip file. This folder has basically multiple data files, sample data files, which you can actually use it to practice uploading the data on the Redshift cluster. So I have extracted one of the files from this folder, and then I have uploaded that file in the S3 bucket. Now we'll move into the S3 bucket. Let's look for the file that has been uploaded on the S3 bucket. So this is the bucket sample, and sales_tab.txt is the file that I have uploaded. This has the entries, data entries that will be uploaded using a copy command onto the Redshift cluster. Now, after putting up the command for creating up the table, then we'll use a copy command. And copy command, we have to define the table name. The table name is sales, and we have to define the path from where the data would be copied over to the sales table in the Redshift. Now, path is the S3 bucket, and this is the Redshift bucket sample, and it has to look for the data inside the sales_tab.txt file. Also, we have to define the role ARN that was created previously. And once it is done, then the third step is to query the results inside the sales table to check whether our data has been uploaded correctly on the table or not. Now what we'll do is we'll execute all these three syntax. It gives us the error because we have to connect it again to the database. Let's wait for it. Execute it. It again gives us the error. Let's look into the name of the bucket. It's Redshift bucket sample. So we have two T's mentioned here. Right, let's connect with the database again and now execute it. So table sales created, and we got the error. The specified bucket does not exist. Redshift bucket sample. Let's view the bucket name, Redshift bucket sample. Let's copy that, put it here, connect to the window, connect back to the database. Right, and now execute it. So table sales created. The data in the table has been copied from the S3 bucket to sales_tab.txt to the Redshift, and then the query of the results. The results from the table has been queried.
Hi guys, I'm Rahul from Simplilearn, and today I'd like to welcome you all to the greatest debate of the century. Today, I'm joined by two giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under two categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elasticache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GB of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GB of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like Platform as a Service and Infrastructure as a Service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements. Hi guys, today we've got something very special in store for you. We're going to talk about the best cloud computing platform available, Amazon Web Services.
Rahul, I think you said something wrong here. The best cloud computing platform is obviously Google Cloud Platform.
No, it isn't. AWS has more than 100 services that span a variety of domains.
Alright, but Google Cloud Platform has cheaper instances. What do you have to say about that?
Well, I guess there's only one place we can actually discuss this. A boxing ring.
So guys, I'm Apeksha and I will be Google Cloud Platform.
And I'm Rahul, I'll be AWS.
So welcome to Fight Night.
This is AWS versus GCP. The winner will be chosen on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, the things they give you for free, and instance configuration. Now first let's talk about AWS. AWS was launched in 2004 and is a cloud service platform that helps businesses grow and scale by providing them services in a number of different domains. These domains include compute, database, storage, migration, networking, and so on. A very important aspect about AWS is its years of experience. Now, AWS has been in the market a lot longer than any other cloud service platform, which means they know how businesses work and how they can contribute to the business growing. Also, AWS has over $5.1 billion of revenue in the last quarter. This is a clear indication of how much faith and trust people have in AWS. They occupy more than 40% of the market, which is a significant chunk of the cloud computing market. They have at least 100 services that are available at the moment, which means just about every issue that you have can be solved with an AWS service.
Now that was great, but now can we talk about GCP? I hope you know that GCP was launched very recently in 2011 and it is already helping businesses significantly with a suite of intelligent, secure and flexible cloud computing services. It lets you build, deploy and scale applications, websites, services on the same infrastructure as Google. The intuitive user experience that GCP provides with dashboards, wizards is way better in all the aspects. GCP has just stepped in the market and it is already offering a modest number of services. And the number is rapidly increasing. And the cost for a CPU instance or regional storage that GCP provides is a whole lot cheaper. And you also get a multi-regional cloud storage. Now what do you have to say on that?
I'm so glad you asked. Let's look at present day. In fact, let's look at the cloud market share of the fourth quarter of 2017. This will tell you once and for all that AWS is the leader when it comes to cloud computing. Amazon Web Services contributes 47% of the market share. Others like Rackspace or Verizon Cloud contribute 36%, Microsoft Azure contributes 10%, the Google Cloud Platform contributes 4%, and IBM Software contributes 3%. 47% of the market share is contributed by AWS. Do you need me to convince you any more?
Wait. All that is fine, but we only started a few years back and have already grown so much in such a less span of time. Haven't you heard the latest news? Our revenue is already $1 billion per quarter. Wait for a few more years and the world shall see.
And AWS makes $5.3 billion per quarter. It's going to take a good long time before you can even get close to us.
Yes, we'll see.
Now, let's compare a few things. For starters, let's compare pricing. For AWS, a compute instance of 2 CPUs and 8 GB RAM costs approximately $68 US. Now, a compute instance is a virtual machine in which you can specify what operating system, RAM, or storage you want to have. For cloud storage, it costs 2.3 cents per GB per month with AWS.
You really want to do that? Because GCP wins this hands down. Let's take the same compute instance of 2 CPUs with 8 GB RAM. It will cost approximately $50 per month with GCP. And as per my calculations, that's a 25% annual cost reduction when compared to AWS. Talking about cloud storage costs, it is only 2 cents per GB per month with GCP. What else do you want me to say?
Let's talk about market share and options. Now, AWS is the current market leader when it comes to cloud computing. Now, as you remember, we contribute at least 47% of the entire market share. AWS also has at least 100 services available at the moment, which is a clear indication of how well AWS understands businesses and helps them grow.
Yeah, that's true, but you should also know that GCP is steadily growing. We have over 60 services that are up and running, as you can see here, and a lot more to come. It's only a matter of time when we will have as many services as you do. Many companies have already started adopting GCP as a cloud service provider.
Now, let's talk about things you get for free. With AWS, you get access to almost all the services for an entire year with usage limits. Now, these limits include an hourly or by-the-minute basis. For example, with Amazon EC2, you get 750 hours per month. You also have limits on the number of requests to services. For example, with AWS Lambda, you have 1 million requests per month. Now, after these limits are crossed, you get charged standard rates.
With GCP, you get access to all cloud platform products like Firebase, the Google Maps API, and so on. You also get $300 in credit to spend over a 12-month period on all the cloud platform products. And interestingly, after the free trial ends, you won't be charged unless you manually upgrade to a paid account. Now, there is also the always free version for which you will need an upgraded billing account. Here, you get to use a small instance for free and 5 GB of cloud storage. Any usage above this always free usage limits will be automatically billed at standard rates.
Now let's talk about how you can configure instances. With AWS, the largest instance that's offered is of 128 CPUs and 4 TBs of RAM. Now, other than the on-demand method like I mentioned before, you can also use spot instances. Now, these are for situations where your application is more fault tolerant and can handle an interruption. Now, you pay for the spot price, which is effective at a particular hour. Now, these spot prices do fluctuate but are adjusted over a period of time.
The largest instance offered with Google Cloud is 160 CPUs and 3.75 TBs RAM. Like spot instances of AWS, Google Cloud offers short-lived compute instances suitable for batch jobs and fault-tolerant workloads. They are called as preemptible instances. So these instances are available at 80% off on on-demand price. Hence, they reduce your compute engine costs significantly. And unlike AWS, these come at a fixed price. Google Cloud Platform is a lot more flexible when it comes to instance configuration. You simply choose your CPU and RAM combination. Of course, you can even create your own instance types this way. Before we wrap it up, let's compare on some other things as well. Telemetry. It's a process of automatically collecting periodic measurements from remote devices. For example, GPS. GCP is obviously better because they have superior telemetry tools which help in analyzing services and providing more opportunities for improvement.
When it comes to application support, AWS is obviously better since they have years of experience under their belt. AWS provides the best support that can be given to the customers.
Containers are better with GCP. A container is a virtual process running in user space. As Kubernetes was originally developed by Google, GCP has full native support for the tool. Other cloud services are just fine-tuning a way to provide Kubernetes as a service. Also, the containers help with abstracting applications from their environment they originally run in. The applications can be deployed easily regardless of their environment.
When it comes to geographies, AWS is better since they have a head start of a few years. AWS in this span of time has been able to cover a larger market share and geographical locations. Now, it's time for the big decision. So, who's it going to be?
Yeah, who is it going to be? GCP or AWS?
I think I'm going to go for...
In cloud computing, the competition for leadership is quite a tough three-way race. Amazon Web Services, Microsoft Azure, and Google Cloud Platform clearly are the top cloud companies, hold a commanding lead in the infrastructure as a service and platform as a service markets. Hey everyone, I'm Shamli and I welcome you all to this new video of Simplilearn on AWS versus Azure versus GCP. In this video, we will compare and contrast AWS, Azure, and GCP based on a few related concepts around these cloud computing platforms. It will help us understand the functioning of these top cloud platforms and will also let us figure out the individuality of each one of them. But before starting with the comparison, let's have a quick introduction of AWS versus Azure versus GCP. So let's get started. Amazon Web Services or AWS is a cloud computing platform that manages and maintains hardware and infrastructure, reducing the expense and complexity of purchasing and running resources on site for businesses and individuals. These resources are available for free or for a fee per usage. Microsoft Azure is a cloud computing service that it offers a collection of cloud computing services for building, testing, deploying, and managing applications in the cloud, including remotely hosted and managed versions of Microsoft technology. Google Cloud Platform offers a variety of cloud computing services for building, deploying, scaling, monitoring, and operating a cloud. The services are identical to those that power Google products such as Google Search, Gmail, YouTube, and Google Drive. Now let's move on to the comparison between AWS, Azure, and GCP. We will be comparing them based on few major parameters like origin, service integration, availability zone, cloud tools like compute, storage, networking, market share, pricing, and at last, who uses them. Now, let's move ahead and start with the first comparison, origin. In the year 2006, Amazon Web Services, AWS, was introduced to the market, and in the year 2010, Azure launched its services. Whereas on the other hand, GCP was established in the year 2008. From the start, AWS has been supportive of the open source concept, but the open source community has a tense relationship with Azure. On the other hand, GCP, similar to AWS, provides Google Cloud with managed open source services that are tightly linked. AWS offers services on a large and complex scale that can be manipulated, but Azure support is comparatively low quality, whereas GCP's monthly support price is almost $150 for the Silver class, which is the most basic of services and is quite expensive. Now let's move on to the service integration of these cloud platforms. Service integration is a set of tools and technology that connects different applications, systems, repositories, and data and process interchange in real time. AWS makes it simple for users to combine services such as Amazon EC2, Amazon S3, Beanstalk, and others. On the other hand, Azure allows customers to effortlessly combine Azure VMs, Azure App Service, SQL databases, and other services. Whereas users can utilize GCP to combine services such as Compute Engine, Cloud Storage, and Cloud SQL. Now that we know briefly about all these cloud platforms, let's have a look at the availability zones of these platforms. Because AWS was the first in the cloud domain, they have had more time to build and extend their network. But Azure and GCP both have various locations around the world. But the distinction is in the amount of availability zones they have. AWS now offers 66 availability zones with an additional 12 on the pipeline. Close to it, Azure is available in 140 countries and is available in 54 regions throughout the world. But Google Cloud Platform is now available in 20 global areas, with 3 more on the way. Now let's move on to the next important factor, which is tools. Now let's move ahead and have a look at the first feature, which is compute. Elastic Compute Cloud, or EC2, is AWS compute service which offers a wide range of features including a large number of instances, support for both Windows and Linux, high performance computing, and more. Azure, on the other hand, virtual machines, is Microsoft Azure's core cloud-based compute solution. It includes Linux, Windows Server, and other operating systems as well as better security and Microsoft program integration. In comparison to its competitors, Google's computing services catalog is somewhat smaller. Compute Engine, that company's principal service, offers custom and predefined machine types, per second invoicing, Linux and Windows support, and carbon neutral infrastructure that uses half the energy of traditional data centers. Within the compute category, Amazon's different containers services are gaining prominence. It has Docker Kubernetes, and it's also Fargate service, which automates server and cluster management when using containers as well as other alternatives. Azure, unlike AWS, uses virtual machine scale sets of 2 container services. Azure Container Service is based on Kubernetes, and Container Service uses Docker Hub and Azure Container Registry for management. For enterprises interested in deploying containers, Google offers the Kubernetes engine. It's also worth noting that Google was significantly involved in the Kubernetes project, providing it extensive knowledge in this field. Now let's move on to the next parameter of comparison, which is storage. Simple Storage Service For object storage, Elastic Block Storage. For persistent block storage, and Elastic File System for file storage are among AWS storage offerings. Blob storage for REST-based object storage of unstructured data, queue storage for a large volume workloads, file storage and disk storage are among Microsoft Azure's core storage services. GCP offers an increasing number of storage options. Its unified object storage service, cloud storage, also has a persistent disk option. Relational Database Service or RDS, DynamoDB, NoSQL Database, Elastic Cache in-memory data store, Redshift data warehouse, Neptune graph database, and database migration service are all SQL-compatible databases offered by Amazon. The database choices in Azure are especially wide. SQL database, MySQL database, and PostgreSQL database are the three SQL-based choices. When it comes to databases, GCP offers the SQL-based Cloud SQL and Cloud Spanner, a relational database built for mission-critical workloads. Now the next parameter is networking. AWS uses Amazon Virtual Private Cloud or VPC. On the other hand, Azure uses Azure Virtual Network, VNet, and GCP uses Cloud Virtual Network. Now let's move on to the another factor, which is market share and pricing. All these cloud services are based on comparative pricing strategy, which means you need to pay on the basis of its usage. According to Canalys, the worldwide cloud market rose 35% to $41.8 billion in the first quarter of 2021. AWS accounts for 32% of the market, with Azure accounting for 19% and Google accounting for 7%. On one hand, Amazon charges on a yearly basis, and on the other hand, Microsoft Azure and Google services charge on a minute basis, and also of them provide you a standard price for you to access these services. AWS charges roughly $69 per month for a very basic instance with 2 virtual CPUs and 8 GB of RAM, and AWS largest instance with 3.84 TB of RAM and 128 vCPUs will set you back roughly $3.97 per hour. But in Azure, the same type of instance, one with 2 vCPUs and 8 GB of RAM, cost roughly $70 US per month, and Azure's largest instance has 3.89 TB of RAM and 128 virtual CPUs. It costs about $6.79 per hour. Compared to AWS, GCP will supply you with the most basic instance, which includes 2 virtual CPUs and 8 GB of RAM for 25% less. As a result, it will set you back roughly to $52 every month, and the largest instance that includes is 3.75 TB of RAM and 160 vCPUs. It will cost you around $5.32 per hour. Amazon, other than this, also provides spot instances, reserved instances, and dedicated hosts where you can look for multiple offers and discounts. But for Azure, it provides special prices to developers based on situations, or even Azure Hybrid Benefit, which benefits your organization up to 40% if it uses Microsoft software in their data centers. Whereas Google offers quite assorted pricing to its customer compared to other two. It gives you sustained use discounts, which activate if you use the same instance for a month. The printable instance, which is very similar to Amazon spot instances. But one thing is common in all the 3 cloud services, which is they all offer long-term discount. Now let's have a look at the last comparison, which is companies using them. Because AWS is the oldest player in the cloud business, it has the largest user base and community support. As a result, AWS has the largest number of high-profile and well-known clients including Netflix, Airbnb, Unilever, BMW, Samsung, MI, Senga, and others. With time, Azure is getting a large number of high-profile customers. Azure currently boasts around 80% of Fortune 500 firms as customers: Johnson Controls, Polycom, Fujifilm, HP, Honeywell, Apple, and others are among its key clients. Google Cloud, on the other hand, uses the same infrastructure as Google Search and YouTube, and as a result, many high-end enterprises trust Google Cloud. HSBC, PayPal, 20th Century Fox, Bloomberg, Domino's, and others are among Google Cloud's many clients.
Hey guys, this is Chidanand from Simplilearn, and I welcome you to this short tutorial and demo on Kubernetes. Kubernetes specific to AWS Cloud Platform. So what's a part of this tutorial and demo? What's in store for you? At our offset, I would like to cover the basics of orchestration tools. As most of you would know, Kubernetes is one of the most popular orchestration tools in recent times, specifically for applications which are cloud native and deployed on some or the other types of containers. But what are these orchestration tools? Why would one need to use orchestration tools? What are the facilities or features provided by these orchestration tools? That's the first thing that I'm going to cover. After that, I will pick two orchestration tools specific to container management, Docker Swarm versus Kubernetes. I'm going to compare them with regard to the features that they provide, the use cases that they cover, what facilities that they provide, and when to use what. After that, I will get into a little bit details of the Kubernetes architecture, what exactly is required for setting up a Kubernetes cluster, what runs in a control plane or a master node, what runs as a part of the worker node. After that, I will end the tutorial by running you by setting up a 3-node Kubernetes cluster on AWS platform. I will use something called as kops, which is one of the admin tools for setting up production grade Kubernetes cluster. So I will use this to set up a 3-node cluster on AWS. All right, now that we set the context right, let me get started. So what are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, autoscaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. All right, so having said that about orchestration tools, let's concentrate on two of these orchestration tools specifically for container management, Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native, where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker, Swarm, and Kubernetes for comparing the features that is provided by these two frameworks. For the sake of comparison, I picked up Docker Swarm and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these two orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very, very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which have got LX in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker swarm can manage up to 40, 50 or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is about 50-60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as autoscaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of autoscaling which is provided by Kubernetes, and this unfortunately does not exist in Docker Swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very, very loosely coupled way where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very, very strong. They are very tightly coupled, and even they have the capability where on the cluster size, things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes, Kubernetes groups containers in something called as pods, while a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker's form, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, there's a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected or administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing, where you would need the master nodes to be in odd numbers, so that whenever there's any contention in terms of what needs to be deployed where, or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. What runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair, which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever is asked for any job to be scheduled, based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point in case you don't want somebody to access your cluster, in case you want only specific people or specific users to be running some specific workloads. You can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all that stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the kube API server to the kubelet. And kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod which is running in one container now and running in probably another container, another node altogether tomorrow? So that is where your Kubernetes proxy comes into picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node and what should be existing in a worker node? You're probably thinking that it's maybe pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster, which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it a little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server so that my EC2 server gets powered with all the required role so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys so that from this machine, I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account and let me stick to one particular region and let me bring up one EC2 instance. Alright, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right. I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. Alright, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called open to the word. I would not recommend that you do this since I don't want to, it will take a long time for me to specifically pick and choose the ports that has to be open for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP. I would say from anywhere, just to be on the safer side. I also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. Alright, so I chose a T2 micro instance. Just for the sake of easiness, I've opened up all the ports, and the instance details are, you've seen what is that I've chosen. Alright, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from my Windows box. I would need to convert this into a PPK file. So I have puttygen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes, I would say Simplilearn or Simplilearn private key. I'll save this here. Done that. That's also. This is my public key, which is the PEM file, and this is my PPK or my private key. Now, using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say OK. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. Alright, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an autoscaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission, a role in the EC2, rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. Alright, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly COPS role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here. S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. Alright, so I don't want any tags. I'm going to review. I'll create a role name. I will say COPS role for EC2. Alright, so I'm going to create a role which has got administrative access roles. I'm going to create a role. So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. Alright, now let us have our running instance get powered by this role. So I will connect this role to my running instance. Alright, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. Alright, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update -y. So that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated. So that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update -y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install COPS. COPS is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. Alright, so it is fetching the COPS tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the COPS installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. All right, so I have kubectl as well as kops installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the Simplilearn.Kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone and possibly I will call this as Simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be Simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. Alright, so this is the one that is specific to the Ohio region. So I will say this one, I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. Alright, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. Alright, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. Alright, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already got it copied here. So kops create cluster. The state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and two worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. All right, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying kops update cluster -8. Yes. Now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with one master server and two nodes, or the worker nodes. All right, so this is the command for me to validate the cluster. Then I'm going to try it out first. I'm pretty pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only one server that I had started, which was my COP server, and automatically the other three instances, one is called nodes.simply.in. These two are the nodes, and this is the master node. So these three got automatically provisioned by the COPS command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. It's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are 2 of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is Simplilearn.in. So what I would want to do is now, let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is Simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this COP server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my COP server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. Alright, so let me try kubectl get cluster info. Try kubectl get nodes. Alright, so there are 3 nodes here, master node and 1 master node and 2 worker nodes. So let me see if I have some pods here. Kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very simple pod just to check if my connections everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app, and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. Kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. Alright, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. Alright, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. Alright, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name, ID. This is actually running my pod, which is actually spinning up a container. Great, so far so good. So in Kubernetes, the pods are ephemeral, so they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as I'll just expose this. Let me see. All right, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP, and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving, being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I'll say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. kubectl get pod. Alright, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. kubectl delete service. I don't want this. Alright, that sounds good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. Alright, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the COP server, which had COPS installed on it, has now got a mandate to go ahead and shut down and clean up the whole instances and all those things that are created as a part of my deployment.
Cloud computing is becoming more prominent among tech companies and organizations, making this skill in demand in the sector. Cloud-based solutions are proven to be a boon for company management around the world because they provide convenience at an inexpensive price. This means that if you want to work in technology, a job dealing with cloud-based systems could be a great fit. Hey everyone, I'm Shamli and I welcome you all to this new video of Simplilearn on how to become a cloud engineer. According to Markets, the global cloud computing industry was valued at $371.4 billion USD in 2020. It has been predicted that cloud engineer will be among the top 10 in-demand IT jobs in 2021. Therefore, in this video, we will come across some of the very important aspects needed to become a cloud engineer. Like, first of all, we will understand what is cloud computing. Then, we will understand who is a cloud engineer. After that, we will look into the technical skills needed to become a cloud engineer. After that, we will understand what are the roles and responsibilities of a cloud engineer. Then we will have a look into the roadmap of becoming a cloud engineer. And what is the average salary of a cloud engineer in both the USA and in India? And at last, we will look at the companies hiring cloud engineers.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
The first thing we will come across is what is cloud computing. Cloud computing is the distribution of computing services via the internet or the cloud, including servers, storage, databases, networking, software, analytics, and intelligence to provide faster innovation, more flexible resources, and economies of scale. You usually only pay for the cloud services you use, which helps you cut costs, run your infrastructure more efficiently, and scale as your business grows. That brings us to who is a cloud engineer. Cloud engineers are the IT experts in charge of accessing an organization's technology, infrastructure, and transferring operations and procedures to a cloud-based architecture. They assist with the migration of critical corporate applications and processes to private, public, and hybrid cloud environments. A cloud engineer's job is to access a company's IT infrastructure and migrate certain processes and operations to the cloud. Public, private, and hybrid cloud computing systems are among these functions and operations. Now that we know who a cloud engineer is, let's have a look at the skills required to become one. Cloud engineers must have a diverse set of technical talents that they will use in a variety of positions. Several key skill sets that cloud engineers need to be successful include the ability to program and code cloud-based applications and processes, the ability to troubleshoot technical challenges through problem solving, the ability to plan and design software and cloud applications using critical and creative thinking. Should also include data analysis skills, and should be able to strategically plan and to fulfill projects using technical resources. Now, let's have a look at the roles and responsibilities of a cloud engineer. There are three types of cloud engineers in particular. In a small business, one individual may be in charge of all three roles: cloud architect, cloud software engineer, and cloud security engineer. Cloud architect and organization's cloud computing strategy include application, design, management, and monitoring is overseen by a cloud architect. Cloud architects connect various aspects of cloud computing, including data and networks, with tools and services. Cloud software engineer. A cloud software engineer creates software for cloud computing systems and is in charge of managing their development and maintenance. Cloud security engineer control-based technologies and procedures that enable regulatory compliance. Regulations are included in security. When dealing with the cloud, the major purpose is to protect information, data applications, and the infrastructure. Now let's focus on the roadmap to become a cloud engineer. Cloud engineers generally begin their careers with a 4-year degree in computer technology, and the steps below define the fundamental path to becoming a cloud engineer. Obtain a bachelor's degree in software and systems infrastructure computing or other technical areas. Your bachelor's degree program should emphasize software and system infrastructure computing and other technical courses. A bachelor's degree in a computer or technology related field will also qualify you for advanced degrees if you choose to pursue them. Learn programming languages. Python, C++, Java, and Ruby, for example, are great options to start with. Aside from programming languages, you'll want to brush up on your knowledge and skills with some of the most popular cloud services, including AWS, Hadoop, and Azure. It's important that you gain experience in cloud computing via internships and open source projects. This will help you build a portfolio of work that you can use to demonstrate your competence in future job interviews. And it will also teach you vital skills that you'll need on the job. Consider a master's degree. To enhance your cloud computing abilities while also advancing your career, because of their higher level of education, cloud engineers with a master's degree in a tech subject may have additional career prospects. A master's degree in software engineering or system engineering, for example, will help you develop more of these technical abilities and expertise, advancing your career. Get cloud computing certification. To demonstrate your understanding and skill level in cloud engineering, you can also check out our official website for cloud computing certification. It will help you enhance your knowledge in this particular field. Now that we know everything about cloud computing and how to become a cloud engineer, let's have a quick look at the average salary of a cloud engineer in India and in the USA. In India, the average salary of a cloud engineer is rupees 12,41,000 per annum. And in the USA, the average salary of a cloud engineer is $128,837 per annum. Now, cloud engineers may earn a substantial income with a national average salary, but it can vary, though, depending on your location and how many years you have been in the field. For example, a cloud engineer with a master's degree and several years of experience may make more than a new graduate with a 4-year degree who is just starting out in their career. Now, let's dive down and explore the companies hiring cloud engineers. Cloud computing is gradually establishing itself as the industry standard for data storage and administration. By 2022, according to IDC, over 1 million cloud computing jobs would be generated in India. Amazon, IBM, Wipro, Infosys, Oracle, Cisco, these are the few top companies who are some of the top recruiters in this field.
Every journey begins with a solitary foundational level certification. And for AWS, that starting point is the AWS Certified Cloud Practitioner. Hello everyone, I'm Shamli and I welcome you all to this new video of Simplilearn on how to become an AWS Certified Cloud Practitioner. The AWS Certified Cloud Practitioner certification gives you a high-level overview of AWS. It doesn't go into a great detail about any one service. Instead, focuses on the overall structure of AWS and a basic understanding of what the various services accomplish. So, in this video, I will take you through the path of becoming a successful AWS Certified Cloud Practitioner, starting with what is an AWS Cloud Practitioner, followed by the eligibility criteria for the exam. Then, we will discuss the exam objectives. Then, we will look into the exam content, followed by how to prepare for the exam. Then we will have a look at some of the sample questions for your reference. And then we'll discuss some tips you should remember while taking the exam. So without any further delay, let's get started with the video. So what is an AWS Cloud Practitioner? The AWS Certified Cloud Practitioner certification is a foundational level test designed for people who can successfully show an overall understanding of the AWS cloud, according to Amazon. The skills necessary for specific employment types such as developers, administrators, and solution architects are not assessed by this certification. AWS recommends that you have at least 6 months of AWS cloud experience. Now, let's look into the eligibility criteria for the exam to proceed further. Anyone with a basic understanding of the AWS platform should take the exam. We recommend that you have the following factors before taking this exam. First, 6 months of AWS cloud experience. Second, understanding IT services and how they are used in the AWS cloud platform is a must. And third is basic understanding of AWS services and use cases, invoicing and pricing mechanisms, security concepts, and how the cloud affects your organization. Moving on, let's have an overview of the exam. The exam consists of 65 questions and has a 90-minute time restriction. To pass the exam, you must get at least 700 out of 1000 points. That is 70%. The exam has multiple choice, one right response from 4 possibilities, and multiple response questions, 2 correct responses from 5 options. The cost of applying for the exam is $100, and the certification needs to be renewed after every 2 years. Now that we know of the eligibility criteria for the exam, let's move ahead and have a look at its objectives. It will enable you to articulate the value proposition of AWS Cloud. Next, you'll be able to define the AWS Cloud and the AWS Global Infrastructure with it. Also, it will help you understand and explain the fundamental AWS Cloud architectural ideas. It will enable you to describe the AWS platform's essential security and compliance features, as well as the shared security model. You'll be able to define invoicing, account management, and price models with it. And it will also enable you to describe the fundamental or core properties of AWS cloud deployment and operation. Now, let's proceed further and have a look at the content for the exam for better and organized preparation for the exam. The required knowledge is divided into 4 domains for the exam. These are various objectives within each test domain that broadly reflect the knowledge and expertise required to pass the exam. Cloud concept. This domain makes up 28% of the exam. Security. This domain makes up 24% of the exam. Technology makes 36% of the exam. And billing and pricing makes up 12% of the exam. The following 3 goals are included in cloud concepts. Define the AWS cloud and the value proposition it provides. Recognize characteristics of the AWS cloud's economics and make a list of the various cloud architecture design principles. You should be able to explain the advantages of public cloud services and define the services that are offered on AWS like IaaS, PaaS, and SaaS. You must comprehend the financial benefits of cloud computing and the distinction between CAPEX and OPEX. This relates to item 1. You should be familiar with cloud architectural design principles such as loose coupling, scaling, bootstrapping, and automation, to mention a few. Now comes security. You should be familiar with the AWS shared responsibility model, which specifies who is in charge of which component of the technology stack, from the data center to servers, firewall rules, and data encryption. AWS offers tools and services for deploying security, evaluating your security posture, and creating alert and compliance reports. You must have a thorough understanding of these services and tools in order to describe their use and benefits. Now comes technology. You must know what the basic AWS services are and how they are used. You usually don't need a thorough understanding of a service's specifics, but you do need to comprehend its goal, benefits, and use cases. EC2, ECS, Lambda, Lightsail, EBS, EFS, S3, RDS, DynamoDB, Redshift, Elastic Load Balancing, Autoscaling, CloudFront, Root, S3, CloudWatch, CloudTrail, and SNS are all core services. You should be familiar with the AWS Cloud's worldwide infrastructure. Regions, availability zones, and edge locations are all part of this. Then comes billing and pricing. The majority of AWS services are available on a pay-per-use basis. However, there are also alternatives to save money by signing 1 or 3-year contract with a variety of payment options. You must comprehend these models and the services to which they apply. Make sure you know what AWS will charge you and what will be free. Inbound data transport, for example, is free, whereas outbound data transfer is usually expensive. VPC, CloudFormation, and IAM are all free services, but the resources you generate with them may not be. You must be aware of the potential for costs to arise. Now let's have a look at how to prepare for the exam. Step 1. Start with AWS training classes. AWS Cloud Practitioner Essentials, AWS Cloud Practitioner Technical Essentials, and Cloud Business Essentials are a few courses that will help you build your knowledge in AWS. Step 2. Go through exam guides for AWS Certified Cloud Practitioner certification because they give you an idea of important concepts to focus on for the exam, as well as give you an overview of all the exam objectives and the pattern of questions. Step 3. Get familiar with subject areas. Before the exam, analyze the important subjects for the exam and keep polishing your knowledge in that area by constant revisions. Step 4. Self-study to build your strength. Self-study is ample to clear this exam. Just go through the AWS training, go through the study material available online, and keep revising. Step 5. Examine sample questions and take a free practice test. Practice sample papers from various websites present online to see where you stand and how much you know and how much time you take to keep a track of your performance and improve yourself. And 6. Schedule the exam and get certified. Once you feel you are ready, prepared, and confident, enroll for the exam. Choose a center near you for the AWS Cloud Practitioner exam website and just register yourself. So let me give you a glimpse of some sample questions based on each domain. First question: which feature of AWS allows you to deploy a new application for which the requirements may change over time? Option 1, elasticity. Option 2, fault tolerance. Option 3, disposable resources. And option 4, high availability. The answer is option 1. You can deploy your app without worrying about whether it will require more or less resources in the future, thanks to elasticity. Infrastructure can scale up and down on demand thanks to elasticity. Question 2. Which AWS service is used to enable multi-factor authentication? Option 1, Amazon STS. Option 2, AWS IAM. Option 3, Amazon EC2. And option 4, AWS KMS. Well, the answer is option 2. IAM is used to manage multi-factor authentication and to securely regulate individual and group access to AWS resources. Question 3. A company would like to maximize their potential volume and RI discounts across multiple accounts and also apply service control policies on member accounts. What can they use to gain these benefits? Option 1, AWS budgets. Option 2, AWS Cost Explorer. Option 3, AWS IAM. Option 4, AWS Organizations. Well, the answer is option 4. AWS Organizations allow you to create groups of AWS accounts and then administer policies across all of them from a single location. Consolidated billing is available in both feature sets of AWS Organizations, allowing you to set up a single payment method in the organization master account while still receiving invoices for individual activity in each member account. Question 4. What advantages do you get from using the AWS cloud? You have to choose any two. Option 1, trade capital expense for variable expense. Option 2, stop guessing about capacity. Option 3, increase capital expenditure. Option 4, gain greater control of the infrastructure layer. And option 5, comply with all local security compliance programs. Well, the answer is option 1 and 2. You may pay on a variable OPEX basis for the resources you use and grow on demand using public cloud services like AWS. So you never have to guess how much resources you need to deploy. Question 5. Under the AWS shared responsibility model, what is the customer responsible for? Choose 2. Option 1, physical security of the data center. Option 2, replacement and disposal of disk drivers. Option 3, configuration of security groups. Option 4, patch management of infrastructure. And option 5, encryption of customer data. The answer is option 3 and 5. Customers are responsible for creating security groups, network ACLs, updating their operating systems, and encrypting their data, while AWS is responsible for the physical security of the DC, the replacement of obsolete disk drivers, and infrastructure patch management. Question 6. What are 2 ways an AWS customer can reduce their monthly spend? Choose 2. Option 1, turn off your resources that are not being used. Option 2, use more power efficient instance types. Option 3, reserve capacity where suitable. Option 4, be efficient with the usage of security groups. And option 5, reduce the amount of data ingress charges. The answer is option 1 and 3. Turning off resources that aren't in use can help you save money. Reserved instances can also help you save money on a monthly basis without committing to a 1 or 3 year contract, which is ideal for predictable workloads. Question 7. What are the advantages of availability zones? Choose 2. Option 1, they allow regional disaster recovery. Option 2, they provide fault isolation. Option 3, they enable the caching of data for faster delivery to end users. Option 4, they are connected by low latency network connections. And option 5, they enable you to connect your on-premises networks to AWS to form a hybrid cloud. The answer is option 2 and 4. Each AWS region has numerous availability zones, which are unique locations. Each AZ is designed to be isolated from other failures. A data center is an AZ, and in some situations, an AZ is made up of numerous data centers. Within area, AZ provides low-cost, low-latency network connectivity to other zones within that region. This allows you to synchronously duplicate your data between data centers, allowing the failover to be automated and visible to your users. Question 8. Which AWS support plans provide support via email, chat, and phone? Choose any two. Option 1, Basic. Option 2, Business. Option 3, Developer. Option 4, Global. And option 5, Enterprise. The answer is option 2 and 5. Only the business and enterprise programs offer email, chat, and phone assistance. Now that we have discussed all the important aspects required for AWS Cloud Practitioner exam, let me give you some tips you should remember while taking the exam. First, start by answering questions you are familiar with to prevent spending time on tough ones. It will give you confidence as well as save you from wasting your time on trying tough questions. Second, keep track of your time and learn how to manage it in order to complete all the questions. Distribute your time according to the time available to the number of questions so that you can work on each question precisely. Third, analyze the question first, then respond, as there may be traps in the questions. Focus on keywords and try to read them 2 to 3 times for better understanding. Sometimes it is said that answer lies in the question itself. Fourth, because there may be numerous answers to a question, read and choose your answers carefully. If you feel there is a chance that multiple answers are correct for one question, then do go for it and analyze it wisely before coming to that conclusion. Well, this was all about it.
Today, I'm going to tell you how you can become an AWS Solutions Architect. So who is an AWS Solutions Architect? Now, the main role of an AWS Solutions Architect is to help you deploy your applications on the AWS platform. Now, this is nothing but a cloud computing platform. So it's not to say that you can't deploy your applications on the cloud computing platform yourself. It's just that when it comes to organizations, the applications that you need to deploy become a whole lot more complex. That's where an AWS Solutions Architect can help. Ever since cloud computing became a thing, companies around the world have started migrating their physical infrastructure onto the cloud. That's what an AWS Solutions Architect does. They help you migrate your physical infrastructure onto the AWS cloud. Companies around the world work on a budget, and an AWS Solutions Architect will help design a cloud infrastructure based on the organization's budget. Before that can be done, however, an AWS Solutions Architect has to create a design with an intricate and detailed blueprint of the cloud infrastructure that they plan to set up. Now, AWS Solutions Architects also have to focus mainly on non-functional requirements like usability, reliability, scalability, and performance of the cloud infrastructure. They're also responsible when it comes to minimizing risks that an organization can face when it comes to cloud computing platforms. Now, they could face risks like security leaks, calculation mistakes, and application downtimes. An AWS Solutions Architect has to ensure that these don't happen. Before we can talk about how you can become an AWS Solutions Architect, I have some exciting news for you guys. We've launched our own YouTube community. You'll get to see a lot of quizzes, polls, offers, and much more to make your learning experience a whole lot more fun. You can find all of this on your subscription feed, or you can also click on the top right corner right now to get started. And let's get back to how can you become an AWS Solutions Architect. Now, to become an AWS Certified Solutions Architect, you need to clear the AWS Certified Solutions Architect Associate Level Examination. Now, here's some details about it. The exam score ranges from 100 to 1000 marks, and the minimum passing score is 720. However, there's a catch. The passing marks are actually set using statistical analysis, so they can be changed based on how difficult the examination actually is. The exam fee is $150, and you can also take a practice examination which costs $20. Now, regardless of the examination you take, be it Solutions Architect, SysOps Administrator, or Developer, any associate level examination costs $150. For the professional level examination, it's $300. Now, if you want to learn more about the AWS certifications, I suggest you click on the top right corner and watch our video AWS certifications in 10 minutes to learn more. Now, the exam duration is of 130 minutes and you have two types of questions, multiple choice and multiple answer. Now, the multiple choice questions have 4 options, out of which one of them is right, and you have multiple answer where you have 5 options, out of which 2 of them are correct. You can take the examination in English, Japanese, Korean, and simplified Chinese. Now, let's talk about how you can schedule an examination. First, let's go to Google and search for AWS certifications. Click on the first link. So, on this page, we can go to the bottom and find the different certifications AWS provides. Click on Architect and select the AWS Certified Solutions Architect Associate certification. Click on Register Now. And here you need to click on the AWS certification account. You can sign in with your Amazon account or create a new one. I already have an Amazon account that I'll be using for signing in here. In case you don't, you can click on the Create Your Amazon Account button here and create an account for yourself. Now, after that is done, you can schedule a new examination. And you can scroll down to the bottom. Here, AWS Certified Solutions Architect Associate Level Certification. Click on Schedule Exam. Press Continue. And here you need to select your language, which I'm assuming is English. I'm from India, so I don't need to change anything here, but you can change your country or time zone and other details based on your requirement. And select your preferred month. I want to do it in October. Now select Search for Exam Center. Select the one that's closest to you. I'm going to select this one. And here you can select the day that you want to take your test and the time available. I want to do it on the 15th. I select the time that I want and press Continue. Now you can go through all the details here, change them if you want to, otherwise you can press Continue. After this is done, close. And here we have the final step, which is the fees. You can enter your details here and pay now to finish the process. Now let's look at an outline of the exam content. Now what you're going to see in the exam are 5 major domains, and here you have each of the domains with their respective weightages. First, you have at 34% designing resilient architectures. At 24%, you have both defining performant architectures and specifying secure applications and architectures. At 10%, you have designing cost-optimized architectures, and at 6%, you have defining operationally excellent architectures. Now let's look at each of these domains in detail. Now the first domain, or design resilient architectures, can be divided into 4 parts. Firstly, you need to know how you can choose reliable or resilient storage using services like AWS S3, AWS Glacier, and AWS EBS. Then you have how you can design decoupling mechanisms using AWS Services. Now this is possible with the help of AWS SNS. Now these aren't the only services that enable this, these are just some of the services. Then how you can design a multi-tier architecture solution. Now this is important because you need to know how you can create a solution that involves several other services. Then you need to know how you can design highly available and fault-tolerant architectures. Now for the second domain, defining performant architectures. First, you have how to choose performance storages and databases. Services that are used are AWS RDS, AWS Redshift, and AWS DynamoDB. The second step is how you can apply caching to improve performance. A service that can be used for this is AWS Elastic Cache. Third, how you can design solutions with elasticity and scalability. You have AWS Lambda, AWS CloudWatch, and AWS Data Pipeline. Now, for the third domain, which is specifying secure applications and architectures, You need to know how you can secure applications using services like AWS Inspector, AWS CloudTrail, and AWS IAM. You need to know how to secure data using Cloud HSM and AWS Macie, and how you can define the networking infrastructure using CloudFront, VPC, and Elastic Load Balancer. For the fourth domain, you have designing cost-optimized architectures. Firstly, you need to know how you can design cost-optimized compute solutions. You can use AWS EC2, Elastic Beanstalk, Lambda, and AWS Lightsail. Then you need to know how you can design cost-optimized storage solutions using AWS S3, Glacier, EBS, and Elastic File System. And the final domain, to define operationally excellent architectures. You need to set up design features and solutions that enable operational excellence. Now, some of the features are that you perform operations as code, you annotate documentation, you make frequent and small reversible changes, and anticipate and tackle failures. Now, let's have a look at the job opportunities when it comes to AWS Solutions Architects. Now, if you have a look at this graph, you can see that AWS has always provided a lot more job postings as compared to the other two giants in the cloud computing domain, which are Microsoft Azure and Google Cloud Platform. Now, if you do a little bit of research, you'll find out that there's a significant lacking of experienced personnel when it comes to AWS. So I would suggest this is the best time for you to get certified in AWS.
The Amazon Web Services cloud management system now has over 1 million clients and generates $10 billion in revenue annually. Kellogg's, Samsung, Unilever, Nokia, Netflix, Adobe are the majority of international corporations trust the platform. So, hello everyone, I'm Shamli and I'm going to take you through this new video of Simplilearn on top 10 reasons to choose AWS. Through the medium of this video, I'm going to give you top 10 reasons to choose, adapt, learn, and explore AWS. But before moving ahead, let me give you an overview of the concept of AWS for your better understanding. Amazon Web Services, AWS, is a cloud computing platform that manages and maintains hardware and infrastructure, reducing the expense and complexity of purchasing and running resources on site for businesses and individuals. These resources are available for free or for a fee per usage. It is a comprehensive and simple to use computing platform offered by Amazon. Infrastructure as a service, platform as a service, and packaged software as a service are all used to build the platform. So let's move ahead and explore the top 10 reasons to choose AWS, starting with the first one, which is flexible pricing options. The most popular motivation for learning AWS is because of its cost-effective pricing alternatives. AWS provides a year of free access to the free tier, which is ideal for novices who wish to learn about AWS technology. For beginners, we believe this is plenty. AWS is highly customizable with pay-as-you-go options to match any company need. Flexible pricing is a great approach to scale up or down the architecture as needed. The AWS tariffs are comparable to those for water and electricity. Second reason to proceed with is the global architecture. One of the most appealing features of AWS is that it is offered in 24 different zones across 16 different countries. You can connect to the server from any country. You may use all of the advantages by hiring an AWS developer from anywhere. There are no restrictions on who can use the servers based on their location. Third is automated multi-region backups. AWS offers a variety of backup options, including AMIs and EBS snapshots. AWS's decentralized design and global reach makes storing crucial data in several geographical locations simple and cost-effective. As a result, if your main production environment is brought down by a natural or man-made calamity, your backup data will be unaffected. Third-party solutions can also let businesses automate backups between AWS sites without the need for internal scripting. Fourth reason that we will come across is flexibility and scalability. One of the most valuable AWS features is its flexibility. It lets you pick your operating system, programming language, web application platform, database, and other services. AWS provides a virtual environment in which your application may load all of the services it requires. It also makes data migration easier. When demand increases or drops, autoscaling and elastic load balancing techniques are automatically scaled up or down via AWS. AWS approaches are useful for dealing with unpredictably high or unpredictable loads. Organizations gain from lower cost and more user satisfaction as a result of this. Moving on, fifth is streamlined recovery. Even a small bit of downtime or data loss might be disastrous for some services. For others, the cost of downtime data loss is not greater than the expense of maintaining a multi-site hot standby recovery strategy. Regardless of your organization's resilience to downtime or data loss, AWS Adaptable Platform can provide you with the tools you need to implement a disaster recovery strategy. In the event of a disaster, AWS Disaster Recovery restores your data fast across several locations. Sixth one is PaaS offering. The most prevalent model is Platform as a Service, which has a market share of roughly 32% and is likely to rise in the next few years. A Platform as a Service solution provides a platform for developers to construct unique, configurable software and is a popular choice for enterprises looking to create unique apps without spending a fortune or shouldering all of the responsibilities. Seventh reason I will take you through is customization. Customization for AWS Control Tower is a solution that combines AWS Control Tower with other highly available trusted AWS services to assist customers set up a secure multi-account AWS environment faster and more efficiently using AWS best practices. Customers must first have an AWS Control Tower landing zone set up in the account before installing the solution. Eighth one is scheduling. AWS clients can start and stop services at any moment. Thanks to its service scheduling feature, you can keep track of your assets, pay for the service you use, and run them at a certain time. It enables you to create sample planners to test consumers' viability and schedule services as required. Consider Elastic Computing Cloud, EC2, and Relational Database Service as examples of scheduling services. You are not required to conduct these services on a daily basis. Set the timetable for the service based on the day of the week you utilize it. Ninth is security. AWS provides the same level of world-class security to small startups as well as enterprise-size behemoths. The commercial data center meets the highest conceivable standards, saving you the trouble of needing to defend your own data centers. AWS also maintains a large number of compliance processes in its infrastructure, as well as a large security help network that may provide real-time information about suspicious tasks and potential vulnerabilities. And the last one, the 10th reason, is third-party APIs. AWS API implies that you can manage your cloud-based facilities in a variety of languages, in line with the platform's entire versatility. It also means that third-party solutions, such as yours, can take advantage of all of AWS time and cost savings feature. You can automate ordinary but necessary AWS processes without the use of coding, from automated backups to EC2 and RDS instances. Well, this brings us to the end of this video.
So how can Simplilearn help you with your AWS certifications? Now we are on the Simplilearn homepage. And here we have the AWS Solutions Architect course. On this course, which is the AWS Solutions Architect Certification Training course, we have 36 hours of instructor-led training, 20 hours of self-paced learning, 16 live demos, 3 simulation exams, 3 hands-on practice projects, and so much more. Here, our main emphasis is on making sure that you have enough hands-on experience with the services that you crack the examination at your first attempt. So here we also go through some of the more important services that you need to learn, like IAM, VPC, EC2, S3, and so much more. We'll also talk about databases, application services, security practices, disaster recovery, and so on. We even have practice examinations to help you prepare for the real one.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
I'm here to walk you through some of the AWS interview questions which we find are important. And our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. By the way, I'm a cloud technical architect, trainer, and an interview panelist for cloud, network, and DevOps. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. All right, so in an interview, you would find yourself with a question that might ask you, define and explain the three basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain three basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere. And networking, that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute EC2 is a major one. That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk. And then function as a service, which is Lambda. Autoscaling and Lightsail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application. Again, Lambda is a compute service, so the compute service also helps in running event initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service. And the products that are built based on the storage services are S3, object storage, Glacier for archiving, EBS, Elastic Block Storage as a drive attachment for the EC2 instances, and EFS file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, it's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used, right? So that actually proves you to be a person knowledgeable enough in that particular service or product. So talking about networking domain, VPC, networking, can't imagine networking without VPC in a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have CloudFront, which is an edge caching service that helps customers to read their application with low latency. So networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer, or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that gets asked would be the difference between the availability zone and the region. Actually, the question generally gets asked so to test how well you can actually differentiate and also correlate the availability zone and the region relationship. Right? So a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there. You should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is autoscaling? What do we achieve by autoscaling? So in short, autoscaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So autoscaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because autoscaling is going to handle it for us. So business does not need to worry about it. And autoscaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. The ability to increase and shrink based on the need of that hour. That's how powerful is autoscaling. The other question you could get asked is, what's geo-targeting in CloudFront? Now we know that CloudFront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for CloudFront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit. Not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? CloudFront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it gets cached there forever. And the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other. CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. What happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an EC2 instance to a better EC2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you should be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger EC2 instance type or with a bigger capacity, and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using Elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are Cost Explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so. And it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. Alright, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount, stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an EC2 instance. An EC2 instance does not always have to be logged in through the console. You could use PuTTY to log into an EC2 instance, and like the jump box, like the proxy machine, and like the gateway machine, and from there you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI in any of the Linux machines or Windows machines. We can install, so that's point 2, 3, and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are, we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. Right? So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system would scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter, and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used And here are some of the services and how they actually connect to each other. It could be logs that belongs to one account. It could be logs that belongs to multiple accounts. It doesn't matter. Those three services are going to work fairly good, and they're going to inject, or they're going to suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account. And all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs instead of looking at log as just statements or in a bunch of characters, a bunch of files. Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management, or incident management. Then you could have a question like this: what are the native AWS security logging capabilities? Now, most of the services have their own logging in them, have their own logging, like S3. S3 has its own login, and CloudFront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS config services. So there are a variety of logging options available in the AWS, like CloudTrail, config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the accounts. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now config service helps us to understand the configuration changes that happened in our environment, and we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happened? What are the things it went through? They can be looked at using AWS config.
All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS, which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary, Amazon native services. And a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to, or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections. and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses, so everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them, so that's denying the service for the actual users, denial of service. All right, and distributed denial of service is generating attacks from multiple places, from a distributed environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. CloudFront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create a secure virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. Anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as and when the traffic increases, as and when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime we don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application, which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a place, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And if your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of, at least new startups and new companies that are thinking of having a monitoring environment. Now, they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available, because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to website? How do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind. because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes, not only the state changes, the autoscaling life cycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage, and very informative messages can be received through CloudWatch. CloudWatch can now support scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it. And it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto-healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor, and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, there are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. Alright, the 3 major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para virtualization on hardware virtual module. Alright, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para virtualization, Paragrub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region, they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific. So we can't have a Route 53 for every region. Route 53 is not a region specific service. It's a global service. And it's one application. Users access from everywhere or from every part of the world. So we can't have one URL or one DNS name for each region if your application is a global application. And then Web Application Firewall works well with CloudFront. Then CloudFront is a region-based service. So the Web Application Firewall, it's not a region-specific service. It's a global service. And CloudFront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service, right? It's not bound to any region. So when you activate CloudFront, you're activating it away from region or availability zone. So when you're activating a web application firewall, because it's not a region specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations, and they are global as well. Web Application Firewall, a service that protects our web application from common web exploits. They are global service as well. CloudFront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. All right, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like NAT gateway or NAT instances, you can expect this question: what are the difference between a NAT gateway and NAT instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them, right? On a high level, they both achieve providing NATing for the service behind it, but the difference comes when we talk about the availability of it. NAT gateway is a managed service by Amazon, whereas NAT instance is managed by us. Now I'm talking about the third point, maintenance here. NAT gateway is managed by Amazon, NAT instance is managed by us, and availability of NAT gateway is very high, and availability of NAT instance is less compared to the NAT gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails, we'll have to relaunch it. But if it is NAT gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. A billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in NAT gateway cannot be assigned, meaning it already comes with full packed security. But a NAT instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the NAT gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product. But NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used lab and are attending the interview, chances are that you might be always lost when answering this question. It might look like both are the same. Well, stopping and terminating both are the same, but there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and terminating an instance. If you're thinking of using the instance again along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us. But if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short-term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance, and anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. All right, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And Cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelist put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this. How do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY. And this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually an hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them. If I don't find a Marketplace, I can always go to Community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different, Solaris does not support, the architecture does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now these are different hardwares, different CPU itself that the cloud providers they do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question, how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch. And once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes. right? It's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case, it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply, just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you, right? This is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect, or even on the SysOps side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JEOS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI, just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. Can be a bit expensive, it can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI, so a lot of planning, a lot of thought process will go into it, and the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use, or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI. Just like the name says, it has as you can also see in the diagram or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security monitoring, logging are packed in that AMI, and the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all the systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. All right, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup. But here the specific question is, we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue, and then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question, what are some key differences between AWS S3 and EBS? Well, the differences are, S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, a very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC, but EBS comes under a VPC. It's on the same VPC, so you would be able to use it kind of locally. Compared to S3, EBS is very local, so that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS. S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an EC2 instance. Right? Just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is, how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service.
Now he is in the production group, and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize, right? So you put a tag on them. Put a tag saying, well, they are highly critical, they are medium critical, and they are not critical at all. Still they're in production, stuff like that. And then you would pick the users who wants to or who should be or should not be given access to a certain server, and you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you deny access to them. And the same goes for bucket as well. Or if an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1, and on the right hand side we have region 2, and region 1 is the source bucket and region 2 is the destination bucket. Right, so object is put in the source bucket and it has to go directly to the region 2 bucket or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross-replication or cross-region replication monitor that actually monitors your environment. So there are CloudWatch that make sure that the data is moved, no data is failing. Again, there's CloudWatch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature. And we will have to enable the DNS hostname resolution before
Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default, it's not allowed. But if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices, and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data. All right, so they would actually mimic the hub and spoke topology where you have the VPC, which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions, and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts, and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. All right, that's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers, or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who, and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. Right? So that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, stuff like that. So there are some security products and features available in VPC. Now, how do you monitor VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC, except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on our VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard. Now let's talk about multiple choice questions. When going for an interview, you might sometimes find yourself that the company is conducting an online test. Based on the score, they can put you to a panelist and then they would take it forward. So we thought we'll also include multiple choice questions to help you better handle such situation if you come across. Alright, when you find yourself in such situation, the key to clear them is to understand the question properly, read between the lines. That's what they say. There can be like a big paragraph with 3 lines or 10 lines. You really got to understand what the question is about and then try to find answer for that question. So that's thumb rule number 1. And then the second rule is try to compare and contrast the services mentioned, or try to compare and contrast the answers. You can easily weed out 1 or 2 answers and then you will be left with only 2 answers to decide from. So that also helps you with time, and that also helps you with some precision in your answer. So number 1, read between the lines. Number 2, compare and contrast the services, and you'll be able to easily weed out the wrong ones. So let's try answering this question. Suppose you are a game designer and you want to develop a game with a single digit millisecond latency. Which of the following database services would you choose? So we know that the following are database services. Good enough. All right. And it talks about millisecond latency. That's a key point. And the third thing is it's a game. Could be a mobile game. It's a game that you are trying to design and you need millisecond latency and it has to be a database. Alright, so let's talk about the options available. RDS. RDS is a database for sure. Is it good for game design? We'll come back to that. Neptune. Neptune is a graph, a database service in Amazon. So that's kind of out of the equation. And Snowball is actually a storage. Alright, it's a transport medium, I would say. So that's again out of the equation. So the tie is between RDS and DynamoDB. So if we need to talk about RDS, RDS is a platform as a service. It provides cost-efficient, resizable capacity, but it's an SQL database, meaning the tables are kind of strict. It's good for banking and other type of applications, but not really good for anything that has to do with gaming. So the only option left is DynamoDB. Again, it's the right answer. DynamoDB is actually an fast and flexible NoSQL database service, and it provides a single-digit millisecond latency at any scale. And it's a database at the same time. It's a key value store model database. So the right answer is DynamoDB. All right. Let's look at the next question. If you need to perform real-time monitoring of AWS services and get actionable insights, which service would you use? Alright, let's list the services. So it talks about real-time monitoring. A firewall manager, what does it provide? Now, firewall manager is not really a monitor, just like the name says, it's a manager. It manages multiple firewalls. And AWS GuardDuty is an threat detection service. It does monitoring. It does continuously monitor our environment, but it monitors for threats. All right, only threats. Now let's talk about CloudWatch. CloudWatch is a service that helps to track metrics. It's a service that is used to monitor the environment and give us a system-wide visibility, and also it helps us to store logs. So at the moment it kind of looks like that could be the right answer. We don't know that yet, but we have one more option left. That's EBS. So what's EBS? EBS is a block storage, Elastic Block Store. If we abbreviate EBS, it's Elastic Block Store. So all three of them are easily out of the question. The first one is to manage. Second one is to find threats. Of course, it does monitoring. So there's, if there is one relation between CloudWatch and GuardDuty, that's monitoring. So easily we can actually find ourselves slipped towards picking GuardDuty, but know that GuardDuty is only for gaining security insight, but not about gaining AWS service
insights. So CloudWatch is a service that helps us to get a system-wide or an AWS-wide or an account-wide. It has a number of metrics we can monitor and get a very good insight of how a service is performing, be it CPU, be it RAM, be it network utilization, be it connection failures. CloudWatch is a service that helps us perform a real-time monitoring and get some actionable insights on the services. Alright, let's talk about this 33rd question. As a web developer, you are developing an app especially for the mobile platform. Alright, there is a mention that this is especially for the mobile platform. So a lot of services gets filtered out, mobile platform. Right, which of the following lets you add user sign up, sign in, and access control to your web and mobile app quickly and easily? Alright, so this is all about signing in to your mobile app. So if we need to read between the lines, that's how we can read sign up or sign in into a mobile platform. Alright, so we have like 4 options here. Shield, AWS Massey, AWS Inspector, Amazon Cognito. So let's try to weed out services which are not relevant to it. So what's AWS Shield? AWS Shield is actually a service that provides a DDoS mitigation or a DDoS protection, denial of service protection. It's a security feature. Let's talk about the second option. AWS Massey is again a security service that uses machine learning to automatically discover and classify the data. It again talks about security, and this security is all about encrypting or saving the data. It does not come close with signing up and mobile platform. Alright, let's talk about the other one, AWS Inspector. Now, AWS Inspector has something to do with apps. It definitely has something to do with apps. So kind of looks like that's relevant as of now. So it actually helps with improving the security and compliance of the apps that we deploy in the cloud. So kind of looks like it could be because it has to do with apps. The last one, Cognito. Now, Cognito is a service that actually lets the administrator to have control access over web and mobile apps. And it's a service that helps us to sign up and sign in to an mobile and web app. So that very much looks like we found the answer. So Cognito is a service that helps web app and mobile app for sign up and signing in, and also gives the administrator to have control over access control over the web and the mobile app. Pretty much we found it. So it's Cognito. Cognito is a service that helps us to set up, sign in, and have access control over the users who would be using our mobile and web app. Alright, how about this question? You are an ML engineer or a machine learning engineer who is on the lookout for a solution that will discover sensitive information that your enterprise stores in AWS and then uses NLP to classify that data and provide business related insights. Which among the following services would you choose? So we have a bunch of services that's going to help us achieve, or one of it is going to help us achieve the above requirement. So it's a service that deals with machine learning. You're a machine learning engineer who's looking for a service that will help you to discover information at your enterprise store. So we're talking about storage, discover information in store, and then classify the data depending on severity, the sensitivity, classify the data. So which service is that? So firewall manager, just like the name says, it's a manager. And AWS IAM, if we abbreviate it, it's identity and access management. So it's identity and access management, nothing to do with identifying sensitive data and managing it. So the first two is already out of the equation. And then the AWS Massey, we already had a quick definition description for AWS Massey, that it's actually a security service that uses machine learning. Kind of looks like it could be it. It's a security service that uses machine learning, and it discovers and classifies the sensitive information. Not only that, it does not stop there. It goes beyond and protects the sensitive data. AWS Massey kind of looks like, but we still have one more option to look at, which is Cloud HMS. Cloud HMS is also a security service. Kind of looks like that could be the answer as well. And it enables us to generate encryption keys and save the data. So kind of 50% of it. It's a security service. It encrypts, helps us protect the data, but AWS Massey is right on spot. It's a machine learning service. It helps us to classify the data and also to protect the data. So the answer for this question would be AWS Massey. So hope you kind of get it how this is going. So first we apply the thumb rule, identify the question that's being asked, read between the lines, and then try to find the service that meets your requirement. And finding the service is by first weeding out the wrong ones, recollect everything that you've learned about the service and see how well that matches with those hints that you have picked up. And if that doesn't match, weed that out, then you'll end up with just two to decide from at some point, and then it becomes easy for you to decide. Click on the question, submit it, and then move on to the other question in your interview. Alright, so how about this one? You are a system administrator in a company which is running most of its infrastructure on AWS. You are required to track your users and keep a look on how your users are being authenticated. Alright, so this is where the problem statement starts. Alright, you need to keep track of how your users are being authenticated, and you wish to create and manage AWS users and use permissions to allow and deny their access to the AWS resources. Alright, so you are to give them permission, number one, and then, if we put them in the right order, first giving them permissions and then tracking their usage. Let's see which of the service will help us achieve it. IAM is a service that helps us to, looking at the permissions, we can actually predict whether the user or the group will have servers or not. So that helps us to get a track of who's able to use, who's not able to use certain servers and all that stuff. So it kind of looks like, but we have other three options left. Let's look at AWS Firewall Manager. Just like the name says, it's actually a firewall manager. It helps us to manage multiple firewalls. Simple as that. And Shield is a service. It's a service that's used to protect denial of service or distributed denial of service. An API gateway is a service that makes it easy for developers to create, publish, maintain, and monitor and secure APIs. So, it's completely on the API side, very less on user and how you authenticate your user. We can get that by looking at the name itself, right? If we abbreviate it, or if you try to find a definition for the name API gateway, you would get it. It has to do with API. But if we abbreviate AWS IAM, it's Identity and Access Management, pretty much meets the requirement for the problem statement above. It's AWS Identity and Access Management. That's the right answer. Alright, let's look at this one. If you want to allocate various private and public IP address in order to make them communicate with the internet and other instances, you will use this service. Which of the following is this service? So it talks about using public and private IP address. So this service uses IP address, and then this service helps us to allow and deny connections to the internet and to the other instances. So you get the question, is it? Let's pick the service that helps us achieve it. Route 53. Route 53 is actually a DNS service, right? It's not a service that's used to allow or deny. No, it does not do that. VPC uses public and private IP address. Yes. So kind of looks like VPC helps us to allow, the security in VPC, the security group, the network access control list in a VPC, the routing table in a VPC, that actually helps us to allow or deny a connection to a particular IP address or to a particular service within the VPC or outside of the VPC. So as of now, it kind of looks like it could be, but let's look at the other services. What if we find a service that closely matches to the above requirement than the Amazon VPC? Gateway, API gateway, we know that it's a managed service that makes it easy for developers to create, publish, maintain, and monitor APIs and secure APIs. So that has completely to do with API, not with IP. CloudFront, we know about CloudFront that it's a content delivery network, and it provides global distribution of servers where our content can be cached. It could be video or bulk media or anything else. They can be cached locally, so users can easily access them and download them easily. All right, so that's CloudFront. Now at this point, after looking at all four, it looks like VPC is the right answer, and in fact VPC is the right answer. VPC has public IP address. VPC can help us with private IP address. VPC can be used to allow deny connection based on the security group, access control list, and the routing table it has. So that's right answer is VPC. Alright, how about this one? This platform as a service or platform as a DB service provides us with a cost-efficient and resizable capacity while automating time-consuming administrative tasks? So this question is very clear. It's a DB service we got to look for, and it's a service that can provide automating some of the time-consuming tasks. It has to be resizable at the same time. So let's talk about Amazon Relational Database. It's a database. Kind of matches the requirement. We can resize it as and when needed. All right, looks like it's a fit as of now. It actually automates some of the time consuming work. Looks like it's a fit as of now. Let's move on to Elastic Cache and then try to see if that matches the definition that we've figured out above. Elastic Cache, it's actually a caching service. It's again an in-memory data store which helps in achieving high throughput and low latency in memory data store. So it's not a full-blown database, and it does not come with any Amazon provisioned automation in it for automating any of the administration tasks. No, it does not come up with anything like that. Yeah, we can resize the capacity as and when needed, but automation, it's not there yet, and moreover it's not a database, so that's out of the equation. VPC is not a resizable one. Once we have designed VPC, it's fixed. It can't be resized. So that's out of the equation. And Amazon Glacier is a storage but not a database. Right, so that's again out of the equation. So the tie is kind of between Amazon Relational Database Service and Amazon Elastic Cache, because they both aid the database service, but Elastic Cache is not a full-blown database. It actually helps the database, but it's not a full-blown database. So it's Amazon Relational Database. So that's the one which is a platform as a service. It's the one which can be resized. It's the one which can be used to automate the time-consuming administrative tasks. All right, let's talk about this one. Which of the following is a means for accessing human researchers or consultants to help solve a problem on a contractual or a temporary basis? All right, let's read the question again. Which of the following is a means for accessing human researchers or consultant to help solve problems on a contractual or a temporary basis? It's like assigning tasks or hiring AWS experts for a temporary job. So let's try to find that kind of service in the 4 services that are listed. Amazon Elastic MapReduce. MapReduce is actually an framework service that makes it easy and cost effective to analyze large amount of data, but that has nothing to do with accessing human researchers. All right, let's talk about Mechanical Turk. It's a web service that provides a human workforce. That's the definition for it. For example, automation is good, but not everything can be automated. For something to qualify for automation, it has to be a repetitive task. A one-time task can't be automated, or the time and money that you would be spending in automation is not worth it. Instead, you could have done it manually. So that does not qualify for automation. And anything that requires intelligence, right? Anything that's a special case. Right? Automation can do repetitive tasks. Automation can do precise work, but it has to be a repetitive task. The scenario, it should have been there already. Only then that can be executed. But if it's a new scenario and it requires appropriate addressing, then it requires human task. So we could hire researchers and consultants who can help solve a problem using Amazon Mechanical Turk. The other 2 are already out of the equation. Now, DevPay is actually a payment system through Amazon, and multi-factor authentication, as it says, it's an authentication system. So the right answer is Amazon Mechanical Turk. All right, this sounds interesting. Let's look at this one. This service is used to make it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. Which of the following is this AWS service? So it's a service to deploy, manage, and scale containerized applications. So it deals with containers. It also should have the ability to use Kubernetes, which is a container orchestration service. All right, the first one, Amazon Elastic Container Service. It kind of looks like it's the one. The name itself has the word and the relation we're looking for, Elastic Container Service. So this container service is an highly scalable, high performance container orchestration service. Let's look at the other one, AWS Batch. It's a service that enables IT professionals to schedule and execute batch processing I mean, the name itself says that that's meant for batch processing. Elastic Beanstalk, that's another service that helps us to deploy, manage, and scale, but it helps us with EC2 instances, not with containerized instances. So that's again out of the equation. Would Lightsail be a good tie for Elastic Container Service? What's Lightsail? Now, Lightsail is a service. It's called as a virtual private server without a VPC. It's called as a virtual private server. It comes with predefined compute, storage, networking capacity. It's actually a server, not a container. Right, so at this point that also becomes out of the equation. So it's Amazon Elastic Container Service. That's the one that helps us to easily deploy, manage, scale container services, and it helps us orchestrate the containers using Kubernetes. Alright, how about this one? Alright, this service lets us to run code without provisioning or managing servers. So no servers, run code. Select the correct service from the below option. Alright, so no servers, but we should be able to run code. Amazon EC2 Autoscaling. EC2 Autoscaling? EC2 is Elastic Compute Cloud, which is a server, and Autoscaling is a service that helps us to achieve scaling the server. So that's the definition for it. Could be that's out of the equation. AWS Lambda. Now Lambda is a service. It's actually an event-driven serverless computing platform, and Lambda runs code in response to the event that it receives, and it automatically manages the compute resource that's required for that code. As long as we have uploaded a code that's correct and set up events correctly to map to that code, it's going to run seamlessly. So that's about Lambda. It kind of looks like it could be the answer because Lambda runs code. We don't have to manage servers. It manages servers by itself. But we can't conclude as of now. We have other two services to talk about. AWS Batch. Alright, Batch is a service that enables IT professionals to run batch job. We know that. And about Inspector, Amazon Inspector, it's actually a service that helps us to increase and identify any security issues and align our application with compliance. Well, that's not the requirement in the question. The requirement in the question was run code without provisioning a server, and without any more space for confusion, AWS Lambda is a service, or is the service that runs code without provisioning and managing services. Right? The right one would be AWS Lambda. I'm very excited that you're watching this video, and I'm equally glad that we were able to provide you a second part in AWS interview questions. Alright, let's get started. So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new autoscaling group? Now this is when you are taking an instance away from the autoscaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the autoscaling, you might need to re-add that instance to the autoscaling group. Only then it's going to take part in it, right? Only then the autoscaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've had worked with some clients when their developers were managing their own environment, they had problems adding the instance back to the autoscaling group. Irrespective of what they tried, the instance was not getting added to the autoscaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting counted in the autoscaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance to the autoscaling group? There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to autoscaling group, right? If you have multiple autoscaling groups in your account or in the region that you're working in, then you're going to be posted with the different autoscaling groups that you have in your account. Let's say you have 5 autoscaling groups for 5 different applications. You're going to be posted with 5 different autoscaling groups, and then you would select the appropriate autoscaling group and attach
the instance to that particular autoscaling group. While adding to the autoscaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the autoscaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the autoscaling group. So it's actually a 7-step process, adding an instance back to the autoscaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, if the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately, is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud. Because in on-premises, procuring, or buying an infrastructure, buying the bandwidth, buying the switch port, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is an urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the software, or if the product that you're launching, it requires hardware, it requires an updated hardware all the time, that's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises, but in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company, and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen or for the recovery to finish when an disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is if you'd like to transfer huge amount of data, which is the best option among Snowball, Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball and all of the Snowball series deals with petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. Let's talk about some CloudFormation questions. This is a classic question. How is AWS CloudFormation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button, right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the CloudFormation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the lifecycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk, in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version. or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS cloud resources that will be created through this CloudFormation template. And then we have a version. Version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question. What happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot go forward. CloudFormation cannot create additional resources because we have reached the Elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to launch additional resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work or because there was an CloudFormation executed some, there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail, and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the fifth point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot in the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and instance store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, instance store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and instance store is locally attached to the instance or locally attached to the host of the machine. We cannot detach an instance store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data and another one is EBS is permanent, instance store is volatile data, and instance store, with instance store we won't be able to detach the storage and attach it to another instance. And another feature of instance store is data in an instance store is lost if the disk fails or the instance is stopped or terminated. So instance store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not instance store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System. Right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated. Right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data from, we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration, it's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list, and from there we can use the region selector in the console navigation bar to select the actual region in which we want to work on, and from there ensure that we have selected the right template. Some of the templates would be EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied and from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS and what's their use case? What's the difference between them? And as of now, as we speak, there are 3 types of load balancers which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, simplilearn.com/some web page, simplilearn.com/another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090. Based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information to work with than compared with application layer. So comparatively, it's a lot faster, and it handles millions of requests per second. And after the load balancer receives a connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between a load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said, instead of having one load balancer address all type of traffic, we're going to have 2 load balancers called as the child from the classic, 2 load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have 2 different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are 3 types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the 3 types, and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, Web Application Firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF or Web Application Firewall protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked your application. With WAF, we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies, or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. We can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of a malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users. And once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials, kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, the corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times depending on the number of instances that we have. So like I said, there are 2 types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update, and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource, and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM and how does IAM help your business? Two important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users are non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory, they could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so two things. One is manage users and their access manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that we'll only be charged for the use of the resources, not for the IAM username and password that we create. All right, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency-based routing and geo-DNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request. And on the other hand, the latency-based routing utilizes latency measurements between networks and data centers. Now, latency-based routing is used where you want to give your customers the lowest latency as possible. So that's when we would use latency-based routing. And on the other hand, geo-based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have 2 different or 3 different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product, and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if you have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. You wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing a self-contained administrative and technical unit on the internet, right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com is an hosted zone, whereas simplilearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplilearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be: how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now, this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service, right? It's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS config. A classic question would be: how does AWS config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTPS access or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given? Was it a failure? Was it successful? They also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS config. Right? So with that information, you can always answer the question, what did my AWS resource look like at a given point in time? That question gets answered when we use AWS config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail or with the help of CloudTrail, you can easily answer the question, who made an API call to modify this resource? That's answered by CloudTrail. And with CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime and you want to identify. Let's say there happened to be a downtime and you want to identify who made that change in the environment. You can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS config. Can AWS configure or AWS config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of the services are region services, you still can do some changes, add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all of the regions into an S3 bucket in one particular region. That's possible. And CloudTrail CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime a new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3 year reservation, and in return we get a very low per hour pricing because we're paying upfront. It's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about autoscaling, how will you understand the different types of autoscaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. Right, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right? That's horizontal scaling. So a database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres, SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora, and I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres, SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? Right, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDS, the failover mechanism of Amazon RDS, stuff like that. So RDS maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event, because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of a user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conference, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS EC2 Autoscaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. It looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 Autoscaling is introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon SageMaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment. And Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer, we can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's servers. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is an free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications, and they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS Budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect. And the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? And what is the trend? What is the projected cost for the coming month? All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have a CloudFormation as a service, we have AWS Aurora as a solution, we have AWS Autoscaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is Autoscaling. Right? That's a basic service and solution architect course, is it? Autoscaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and Postgres SQL. Which service are we referring to? Amazon Aurora, Amazon Elastic Cache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elastic Cache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and Postgres SQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification system or a simple notification service.
And with that, we have come to the end of this video on AWS full course of 2022. I hope you found it useful and entertaining. Please ask any questions you have concerning the topics covered in this video in the comment box below. Our experts will assist you in addressing your problems. Thank you for watching, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.